mga kababayan, ang pambansang awit ng Pilipinas.
Kayang mag-ibig, helas ng sinakanan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyag ka ng magiting, sa manlulupin, di ka pasisingil, sa nagagang tutok sa simoy at sa langit mong pagaw, ay hinagang tulang awit sa pagkayang minamahal. Ang isang ng matawad mo'y tagumpay na nag-iingin, ang bituin at araw niya kailan pamay di magtitingin. Luman ang araw ng walhati pagsinta, buhay langit sa piling mo. Ang hindi kaya ng pagkay mag-amin, ang mamatay ng dahil sa'yo.
We are one in IIE mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contributions to our nation. Rising to any challenge, involving what's homes and boats, B-E-A-R-E-E and R-M-E, connecting industries by the electric circuits. Bind us together, IIE. Bind us forever, IIE. With power cords cannot be broken. Bind us together, IIE. Bind us together, IIE. Bind us forever, IIE. Synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission with more reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Bind us together, IIE. Bind us forever, IIE. With power cords cannot be broken.
to IE Cebu. We are here to serve you. We give seminars and webinars for our members near or far. Come to our training center. Our goal is to help each member to become more and more better. As licensed electrical practitioner, in actuaries to become PEs. Our core value is generosity. For electrical practice is not easy. So yes, you're welcome to study. Welcome to IIE Cebu. We are here to serve you. We give seminars and webinars for our members near or far. Whatever you do with electricity, always think of electrical safety. For discipline protects life and property, and safety starts with you and me. Our profession is amazing. Don't underestimate the learning required for proper understanding. Design analysis, troubleshooting. The residential, commercial, industrial. We prepare plans, diagrams, and bill of material. Don't take for granted your skill and knowledge. 'Cause from the rest, that's our permanent edge. You're a brother or a sister, loved by your very own chapter. Don't regret the vocation you chosen. As a electrical practitioner, by God you're chosen. Our profession is amazing. Don't underestimate the learning required for proper understanding. Design analysis, troubleshooting. If you're down and looking for mentoring, come drop by and start asking how to improve in your profession and find success in your vocation. Our profession is amazing. Don't underestimate the learning required for proper understanding. Design analysis, troubleshooting. Our profession is amazing. Don't underestimate the learning that we'll be sharing with you here in IIE Cebu.
Naka-mute ka, Sir Bob. Naka-mute ka.
Hi, ladies and gentlemen. This is your host, Bob Cobb. So, we are going to start our day to wrap up our activities yesterday. We are running out of time. So, hopefully tomorrow, rest assured that the activity of the other day will be wrapped up this day. Okay? So I hope that you'll be staying there until we are going to finish this activity this day. So we are going to go to our speaker. He is a graduate of the Bachelor of Science in Electrical Engineering at Liceo de Cagayan University, proprietor and general manager of MR Electrical Services, awarded by IIEE for the third ENC with VP Internal Bronze Chapter Excellence Award in 2018, awarded by IIEE for the fourth ANC President Bronze Chapter Excellence Award 2019, with specialty in electrical, contracting, industrial, commercial, and residential buildings, with subspecialty in electrical system design, consultant and audit, professional electrical engineer, 2019 former IIE president. Ladies and gentlemen, would you please welcome our first speaker for this morning. He will discuss about the conceptualization for high-rise building design. Please welcome Engineer Raulito Baldonado Jr.
Right. Thank you. Thank you very much, Sir Bob. Am I audible now? Am I audible, Sir Bob?
Yes, sir. Claro, sir.
Yes. Thank you very much, Sir Bob, for that introduction.
My
And
pleasure, sir.
yeah, I will share my screen now. Okay. Again, good morning to all and welcome to this 21st Eastern and Central Visayas Regional Conference. And today we have a great number of participants. We have,
Excuse me, Sir Jun, Sir Jun.
yes, Sir
Sir
Bob.
Jun.
Yes, Sir Bob.
Ang audio ni mo, sir, murag ubos na, sir.
Okay. How about that, Sir Bob?
Okay, sir. Sige, sir.
I'm using my laptop's audio good anyway. Automatic. Okay. How about that? Is that fine? Okay. Anyway, perhaps it should be louder now, no? Anyway, welcome again to this regional conference, and we have a very good number of participants. We have 284 participants this morning, and I know that this is still counting, no? Perhaps yesterday we have 300 plus. So it was a very good seminar yesterday. So as the day two first speaker, so pressure tagamay, no? Anyway, our participants is coming all over the Philippines, and perhaps we have also from abroad. So welcome again. I think this is our first hybrid, no? In fact, tomorrow, see you sa atong face-to-face at SM Seaside Trade Hall. Well, to begin with, my topic is conceptualization of basic multi-story building design, or shall we say, the high-rise building design. This presentation is very familiar nowadays. And Sir Bob, may I request to mute the mic? Medyo may background kasi, Sir Bob. Okay, all right. Thank you very much. So this presentation is actually the basic overview the basic calculation, the basic design considerations. We are merely on basics, no? So this presentation is focused on our newbies of the design, no? So especially to the new graduates, new registered electrical engineers and master electricians. And of course, I know we also have participants here, the students, no? This will be their introduction to this kind of design, the high-rise design for electrical system. And I know that some of you now are experts on this kind of electrical designing. Perhaps you just sit back and relax there. You can never tell. You might have some inputs. No? You can learn also something from me. So, to begin with, our objective is the purpose of this seminar is to give presentation to develop power system design for high-rise multi-story buildings in summary form and concentrate on calculations which can be made by simple methods. By the way, if I encourage you, if you have your PEC 2017 copy, as we go along the presentation, gamitin nyo yun, no? Kasi mayroon tayong mga sections in order for you to be familiarized. So what are the sections applicable for this kind of electrical design? So I am given only 1 hour presentation, so perhaps we will skip some of the slides in order to fast track. However, the slides that we only skip the slides that is not substantial to this presentation. Then allow me first to categorize what is an high-rise or multi-story building. So we call low-rise buildings when it is up to 4-story building. Then we would have mid-rise buildings no more than 8-story. Then the high-rise building, which is our focus in this presentation, is about 9-story to 43rd story, or 23 meters up to 137 meters. Then we have also the skyscraper, which is 44-story and up, which is seldom here in the Philippines. So one of that is the Abu Dhabi, no, yung pinaka mataas na Taj Khalifa ba yun? Right? So the entire presentation will discuss on the basics of electrical designing in high-rise building. So we will have an introduction, then as part 1, we will discuss the general design considerations, the calculation procedures. Then in part 2, we'll have sample calculations on the residential, then to the commercial, then to the administration loads. Common administrations loads are fire pumps, elevators, transformers, and etc. By the way, for you to imagine what is we're dealing with here is the presentation is focused on a certain multi-story building wherein multiple occupancies, no? Perhaps the ground floor to second floor is a commercial, then commercial occupancy, then the fourth floor to fifth floor is a commercial also, and the rest of the 34th story from fourth floor up is a residential, no? Then my presentation will also discuss or showcase a basic voltage drop calculation and a basic short circuit calculation. So as you can see, by the end of this presentation, you will learn something, and perhaps I will provide the presentation, a copy, no, and so that it would be your reference in the future. So allow me to begin with. So high-rise buildings distinctively differ from industrial buildings. Of course, industrial buildings are more on manufacturing. So with regards to the electrical utilization, then The latter are mostly single or two-story lang, no? Yung mga industrial. While the high-rise building is normally multiple occupancies, no? For general office, commercials, hotels, condominiums, and combinations, or shall we say the mixed use. So, the definitions as to numbers of areas vary from one party to another party. So, the development of power system design for high-rise building is long and tedious. However, this presentation suggested simple steps so that it will be shortened, so that we could come up a basic design concept. Okay? So, these slides presenting a single line diagram, no? Allow me to have a simple presentation, no? So, as you can see, this vertical here is a example of bus duct, no? Bus duct. Later on, we'll discuss more on that. So this bus duct is catering. This first bus duct is catering even floors, no? The 2, the 2nd, the 4th, the 6th, and so on and so forth. While the other bus duct is the odd floor, no? The 3rd, the 5th, so on and so forth. So in this design, we have 2 bus ducts operating simultaneously. However, there is a tiebreaker here in case of one bus duct is not will shut down, so it can be transferred, normally open. Okay, so much for that. We'll go over. Yes, this is very important. Before we will have the procedure on how to design high-rise building, we'll have first the basic design consideration. What are those? So, what are those basic design consideration? Number 1, the simple steps, of course, are the applicable standards. No? So, review on the applicable provisions to our codes, regulations on electrical, other installation requirement. First of all, we have the Philippine Electrical Code. Now, if your design is in Japan, so the applicable is their code, no? The GIS, the Japan code, electrical code, yeah. In USA, we have the IEEE or the NEC, right? So these are the things that we have to consider. Kasi kung yung design natin Japan tapos ginamit natin electrical code ng Philippines, ay hindi yun, no? So be attentive to that, no? By the way, in our PEC 2017 for high-rise design, the chapters are needed, chapters 1, 2, 3, 4, and Article 6.95, the fire pump, no? Then other codes are the new electrical engineering law, the building code of the Philippines, the distribution service, as well as the distribution code of the Philippines. So we should know that. Another consideration is
Sir John.
yes.
Wala kay presentation, Sir John.
Okay. Sir Russell, no?
Oh, dagani kwan na walay presentation daw nakita.
Okay. So balik ta.
Sir Jun, wala ka naka-share screen, sir. Kana, sir, kita na.
Yes, tama. Sorry. So, no. Anyway, sige.
Mura ko soda, sir.
Oh. Mo po day. Anyway. Kana, sir.
Oh, nana sir.
Okay, so I'm very sorry, no? I have not shared my screen. Okay. So anyway, allow me to go back. We will just make it faster, no? Okay. Thank you, Sir Russell, ha? So, Nana, sir, na-share na. Share na ngayon, sir.
Okay na, sir. Okay na.
Okay. Thank you. So, allow me to go back, no? I mean, in the objectives, we have that development of power system design in summary form. Then, we will imply here simple methods. Right? So, we will define first the multi-story building. So, if we would say, okay, So we will say low-rise building, it is only up to 4-story. Then for the mid-rise building, it is 8-story. While the high-rise building is, which is our focus right now, is the 9-story to 43rd story, and we have the skyscraper, which is seldom here designed in the Philippines, no? Again, I'm sorry earlier that I have not shared my screen. So the outline of my topics will go to introduction, then in part 1, we'll have design considerations and calculation procedure. Then we'll have sample calculation on the residential loads, sample calculation in the commercial. It is almost same as the residential. Then we'll have the administration loads. Very common to that are the fire pumps, elevators, transformer, how we are going to go about it. Then we'll have a basic voltage drop calculation as well as basic short circuit calculation. Okay, so as introduction, I have said earlier, so I will just skip this one and this one also. Okay, allow me to have a short description. No? So this is a simple single line diagram, a section. So very simple for a high-rise design. It is usually common that 2 riser bus ducts are given. No? So at this point, this is the first bus duct. It is serving the even floors, the second, the fourth, the sixth, and so on and so forth. While the other bus duct riser is the odd floor. Okay, so first we'll go to the design consideration. Before we go to our procedure, we will have the design consideration. Earlier I said the Philippine Electrical Code, the codes are very important. So sa PEC natin, articles 6.95 and chapters 1, 2, 3, and 4 are applicable of this. Then we have the RA 7920 sections applicable 26, 31, 32, and 34. By the way, I will give you this copy of this presentation so that it would be your reference in the future, right? So by considering those codes, we would also have to prepare an electrical load estimate based on areas of the building of other pertinent data. So by doing this, we will have a guide, no? Of course, we have certain guide on, let's say, we will have a 34-floor high-rise building. So it's a very good presumption or estimated load of 100 watts per square meter. So this is not the final, although you will have your presumption of what is the size of your transformer or your bus duct as you go along with your colleagues in the design. So perhaps the owner will ask you, okay, engineer, we have 34 floor, then 10,000 square meter all in all. So even without the design pa, meron na kayong approximation. Okay, sige ma'am, at most tayo, meron siguro tayong mga 10,000 square meter times 100 watts. So meron tayong mga 1 megawatt, no? So you have an idea to what is the transformer size on that. But this is not the final, okay? So that is just your direction. So you should check now the proper designing itself. Then other consideration also, which is very important, is consult the local utility company, right? So if your design is in Manila, so alam mo na yon, no, Meralco. So you have also the idea, 34 kV yung primary side ko. Delta Y yung connection ko. Parang gano'n, no? Then kung sa Veco franchise here in Cebu, so alam na natin 23. So at least in your design, na tayo, no? Kasi kung na-design natin 34 tapos sa Cebu i-apply, so erroneous na yung design natin. So before doing in actual design, dapat alam natin yon, no? These are the considerations. Other consideration also is to determine other designers' exact electrical rating, no? Of course, our counterpart designers like the mechanical, the plumbing, the sanitary engineers, they will the one to give us the rating, no? What is exactly the size of the elevator? They will give us 10 horsepower. So we will do the electrical assessment on that. While on them, the mechanical side, no? Escalators, and so on and so forth. So other consideration is to determine the load location and estimate sizes. Yes, this is often often anong tawag doon? Often na mistake natin, no? Kasi sa design stage hindi natin nakita yung mga locations, no? Example kanina sabi ko yung 34 story requirement natin most likely is 1 megawatt, no? So alam na natin yung size ng transformer, ng size ng generator. By the time the architect will give us the architectural plan, so we can now say, architect, maliit lang yung room ng electrical room natin, ganito yung kuan, di ba? So this must be considered, no? Kailangan natin before doing the design. Anyway, practical lang naman to. However, nilagay ko na rin, no, para hindi tayo maano. Then we have to have the design for the lighting system, I mean. So this must be separate, no? Lighting layout must be separate from power layout, from other layouts, fire pump, because it would be topsy-turvy if we would do it in one sheet of blueprint. So it shall be separate. Then we'll assign circuitry for lighting and power. Again, separate, no? The power is separate. Then of course, ito yung pinakaano natin, kahit wala pa tayong actual na layout, so we can have that single line diagram. So ito yung pinaka-importante sa lahat, no? Meron na tayong single line diagram. So this is a sample of a single line diagram for a high-rise design, no? This is just the continuation of my earlier presentation, no? So as you can see, merong dito yung transformer galing sa utility. However, I shall not dwell on this kasi time constraint. Then take note on this, no? Later on my presentation, I will give this explanation, no? Yung ano natin sa bus duct configuration, right? So allow me to continue. I'm sorry. Okay, so again, another consideration is check and coordinate with other trades. That's it. So we should coordinate for our counterpart designers, no? The architect, the mechanical engineer, and others. Now we will go on the procedure itself. Earlier I have mentioned the design considerations. Now we will go to the procedure. So what must be done first and what is the steps in doing this high-rise building design? Nowadays, condominium or residential commercial types of high-rise building are most common. So the section will showcase the calculation of the latter. Okay, so calculation for the residential loads, this must be done first, right? So earlier I mentioned that our building is multi-occupancy, no? Mixed use. The first floor to third floor is commercial, which embedded also the administration loads, the fire pump, and so on and so forth. Then the rest is a residential loads, no? Condominium. So we'll do first the residential loads. So we will obtain first the sub-service entrance per floor, calculate the total connected load, each unit, and per floor. Perhaps later in our calculation sample, you might understand this well. Then add the total load per floor. Okay. Then after that, compute the current based on the number of units per floor. Then apply demand factor from PEC 2017. Later on, I will show you the application on this. Determine the size of subservice. Then the main service entrance for the residential loads. So add the connected loads of all the units. Compute total current of all the units, the entire residential loads. Then determine its size of conductor for main service and main protection. Then we'll go to the commercial loads. However, commercial loads is basically the same as the residential loads in terms of its procedure. So on how we are going to go about the residential, the commercial is the same. Now for the administration loads, we will emphasize the lighting convenience load, basically same process with the residential. We'll emphasize more on the elevator. Sample calculations later on will be provided, no? How we go to branch sizing of elevators, group of elevators, and its protection devices, overcurrent protection devices. So fire pump also, we will have a short sample on that. Okay, so as you can see, there is always a PEC section that I included for your reference, including the page number, para madali lang sa ano ninyo, no? Madali na lang yung buhay. Okay, so while disconnect of fire pumps is based on lock rotor current, perhaps the PIC 2017, no, has a major changes of this article 6.95 regarding fire pump, no? As you can see, hindi lang based on the lock rotor current yung requirement sa PIC 2017. Ito na yon, no, per section 6.95.1.4V. So the overcurrent protection will also be within 2 minutes it shall be at 600% full load current of fire pump motor. It shall also comply this following conditions: at a restart of 24 times, then within 10 minutes at 300% of the full load current. So this is the major changes in PIC 2017, no? Meron ng introduction ng another compliance to the overcurrent protection sizing of fire pump. But unfortunately, we will not discuss this, no, on my presentation. However, I showed you so that you will be aware that this is another for our fire pump. So allow me to go over. So the lock rotor current, this is the formula. So we will have, yes, I know you're very quite familiar with this, especially those newly graduates. Then, very important, bear in mind that the overload protection for fire pump system is not required. Okay? So, bear in mind that the fire pump is installed for destruction. We will not protect the fire pump motor. We will destruct it, no? Kasi yun yung trabaho niya. Kahit magsunog na, aandar pa rin siya. Hindi magti-trip yung breaker niya, hindi magti-trip yung overload niya. So, yun, no? Kaya walang overload protection requirement. So, the rest other motors is treated as ordinary motor calculation, no? Based on our PIC article section 4. So, for the admin loads, we will have also a basic sizing of the conduits, conductors, then overcurrent protection. Later on, you will understand more if you have an example. So for the voltage drop, I would like to emphasize our PEC required that no more than 5% from the source until to the utilization load, no? So from the transformer itself going to the last utilization load, wherever is the farthest. So, by the way, tips lang, no? Usually, yung ginagawa namin, mga designer, voltage drop. So, we will have the worst case scenario, yung voltage drop na pinakamalayo na load, no? Especially kung motors pa. So, yun yung ginagawa nating sample calculation lang, no? Then, I'm sure the rest, which is shorter na yung distance, papasa na yun, no? Okay? So, we will have also a short circuit current calculation. Basic lang. At least meron na kayong understanding kung, for example, galing sa transformer at his infinite bus, ano ba yung size ng ka-ike rating ng breaker natin. Okay? So, very important also, the sizing of generator, no? So, this is also often mistaken by our practitioner as well as some other designers, no? Kasi ang ginawa natin, kung ano yung size ng transformer, ganun din yung size ng generator. Perhaps that is not the case, right? So the generator sizing itself is this formula, no? The starting kVA of the largest motor load plus the running kVA of the remaining loads. So a simple explanation, no, in my room today, I have 4 lights and 1 aircon and 4 outlets. So kung gusto kong mag-size ng generator, so ang starting ng transformer yung kukunin ko first, then I will add up the remaining, yung 4 na ilaw at saka I mean 4 na outlet at saka isang ilaw, no? So just keep that in mind. Unfortunately, again, we'll not discuss that this sizing of generator for this presentation. However, you know na, no, kung paano gawin yon. Then the lightning protection system for the high rise is very very important also. For protection itself, the word says itself, lightning protection. So we will have the conventional system using the rolling spear method, and we will have also, okay, that there is also a peak section here for your reference, right? So assignment nyo na to, no, to read that. We will also have the enhanced lightning protection system like the Dynasphere, enhanced yon, no, mga EMS, no. Then again, pinaka last procedure, prepare all necessary document. Important yon, no, yung mga forms ng OBO, ayon, single line diagram, specification as well. Sa design natin, included yon. Ano ba yung brand na gusto natin? Ano ba yung mga specifications like copper wire ba? Aluminum wire ba? Yung panel board mo? Yung switch gear mo? Ano ba yung mga no? So, that is the procedure. So, that was my part 1. It is just all about the general consideration, then the procedure. Now, we will go to sample calculations. Like our college days, mas maiging maintindihan natin kung mayroon ng sample calculation, right? So our sample calculation might be, as earlier I'm saying you, this is a 34-story residential commercial condominium building which have a typical residential units from 4th floor to 34th floor. Okay? So each floor has 16 residential units. Each unit has 7,515 volt ampere, 230 volts, single phase line to neutral, which is supplied by a transformer rated 1,500 kVA, 23 kV, 400 Y, 240 volts, 3 phase, 4 wire, Y grounded, with impedance, percent impedance of 6%. Now the system pala is 5-wire system, which is 3-phase line to line at 400 volts, then the line to ground or line to neutral, single phase 230 volts, with the neutral is current carrying. So again, later on I will show you how to calculate the size of the neutral, no? So voltage drop is also given an example, basic voltage drop calculation as well as short circuit calculation, no? So this is the single line diagram. The single line diagram is earlier shown, and this one is summarized, no? As you can see from the transformer bolt, this is from the 3rd floor, I think, or 2nd floor. Then this is a 2 bus duct, no? Yung dalawang bus duct na nakita nyo. Number 1, ito yung sa residential from 4th to 5th. Then yung isa for the commercial, or the commercial and the admin loads, no? Now we are for simplicity on sample calculations, we'll just focus here on the section of the residential. Anyways, perhaps the calculation is the same, no? It might be different on the demand factors and other, but the calculation is just the same. So moving on, what we're gonna do is, first we will have the residential occupancy first, no? Para simple lang, no? So we will size the subservice and the main service feeder cables per floor, and then to its protection, and then likewise on the main, no? Sa total na ng 4th floor to 34th floor. Then for the commercial also, we will subsample for fire pump, elevators, and generator. Okay? So this is for the residential. We will have, earlier I mentioned, yung unit per floor is 16 units, tapos 7,500 volt ampere per unit. That's why 7,500 15 VA times 16 times 0.39 divided by the line voltage, and this is a three-phase bus duct, right? So 0.39 is derived from PEC 2017 table. Okay? So as you can see, nandito tayo no sa, okay, if you have your PEC now, turn to page 61. So as you can see, meron tayong dwelling units na 16 units no per floor. So applicable demand factor, but take note, this is a optional, right? As designer, this is your reference, but this is not supposed to be yun talaga yung ano mo. Reference mo lang to, but it is the very minimum 39%, no? So it is safe also to have 40, 50. So it is your prerogative. However, hindi ka na pwedeng ano pa sa 39. So for simplicity lang of this presentation, we have an example for that 39% so that we have an economic design. However, in actual, kailangan nyo talagang balansehin yun, no? So again, for simplicity, ito lang yung example natin. So the calculated current is 67.69. Ito yung sub-service or the sub-feeder line per floor. Kasi identical lang from 4th floor to 34th floor. Let's say sa 4th floor yan, no? So, yung size pala ng conductor natin based doon sa 67.69 is 322 mm squared copper, no? So, here, from the table. So, I would like also to emphasize that even we're using a THHN wire, which is actually 90 degree. However, because our current is only 67, so we would refer only to 60 degree C, no? As you can see, yung mga breakers na 100 amperes and below, nasa 60 ampere rating yun, no? Utilization. So, even you're using a THHN wire or THW, we will refer the ampacity here. On the other end, if it is 100 amperes and up, so it is based on the THW, the 75 degree C column. Even THHN or ano pa yung gamit mo. So, it is there in the PEC Article 1.2, no? Yung thermal consideration ng equipment, no? Kasi sa production, ito yung kadalasan, no? If 100 amperes and below, yung operational temperature rating inside the breaker, the contacts and so on and so forth is 60 degrees C. Unless kung naka-specified siya na 75 siya, go for it. However, on my case, it is always for me the worst case, no? Kasi kung dati yan 75 degree tapos pinalitan ng maintenance kasi na ano yon, broken, so pinalitan ng 60, so wala na. So anyway, that is for the prerogative of the designer. However, you will take first the worst consideration, mas maigi yon, no? Then the sizing of current protection is just simple. At least equate mo lang sa ano ba yung size na ginamit mo, ganon pa rin. The size of the neutral is, if you have your PEC at page 59, nandun din yon. Kung 200 amperes and less, 100% talaga yung neutral. 100% in contrast to the phase conductor. So if you have 22 mm, dapat 22 mm din yung neutral mo. And perhaps nga, yung ibang designer, 1.5 pa, 150% or 200% considering the harmonics effect, no? However, for simplicity and for, like I said, this is a calculation based on our PEC 2017 minimum, right? Okay, for the overcurrent size of the equipment, grounding conductor, it is also on the PEC. Our specs is 70 amperes, yung gagamitin nating breaker. Yung wire natin is 22. So, our grounding conductor using copper is most likely, hindi pa siya umabot ng 8.0, hindi pa siya abot ng 100. So, 5.5 lang, no? As minimum. However, kung gusto mong paano, pwede pa. Okay, I'm sorry, 8.0 yung nalagay ko. Pwede pang 5.5, no? Again, this is the designer's prerogative. So, pwede ding 8.0, no? On my case, 8.0 yung nilagay ko. So, yung size of conduit, para ano din, I know some of you now might learn, no? Na meron tayong reference pag size ng conduit. Kasi yung iba is parang butikaw-butikaw lang, no? Ganito yung ginawa namin sa ibang project, so ganito yung susundin ko. Now, you have the reference, no? We have our pick table C9, no? So, nakalagay doon kung ano yung, yes, this is for your assignment na lang, no? Yung number of conductors every conduit that have a 40% fill, no? So, this is for your assignment na lang. However, I included this as our reference for your future designs. Okay? So, moving on, the subservice protective device is 70. Okay, so 400 volts, 4 wire plus ground. So, yung neutral ay hindi kasali sa breaker. Dapat yung neutral hindi purple, ha. Dapat triple lang plus neutral. Kasi the neutral is dapat hindi natin puputulin yun, no? But there is a case na gagamitan natin ng 4 pole, no? Especially on the ATS or the MTS side, wherein that is a separately derived system, no? Kasi kung ang neutral ay naka-common, so kung blackout si utility, so nakapasok yung neutral ni generator, tapos papasok si utility, so there is a short circuit of the zero sequence, no? O kung layman's, merong short circuit sa neutral, so that's why purple, may cut yun. So doon lang allowed, no? Within this entire building, it is only 1 point banding, no? Yung neutral at saka kuan. Yun lang. So the rest of the building, wala ng purple. Okay? But unfortunately, again, this is not included on our topic, no? Due to time constraint. So, yung main service ng residential, perhaps the same process, pero ano na natin lahat-lahat, no? Meron na tayong 7.5 volt ampere times 16 units times 30th floor. Now, the demand factor is the change, no? But perhaps also, I've shown you dito na, no? 62 and over, so 23%. Again, this is the minimum, but you are safe to assume it as 60%, 50%. That is the common sense of you as the designer. So overall, sa residential, yung bus duct natin design is 1,250. Derived from this calculation, right? 1,197. Okay, so pwede mo rin gawing 2,000. It's up to you. However, this is the minimum, no? However, yung design mo rin is magiging expensive. So, baka tawagin kang engineer, designer, expensive. So, dapat balance lang lahat, right? Okay, so we'll go out on the neutral, no? Sa main service ng residential, sa 30th floor, 4 to 30th floor. Ang sabi sa spec natin, if that is 200 amperes and up, you are permitted 70% reduction, no? So, from that, ang size ng neutral natin, again, for this simple presentation, allowed tayo na 70%. So, from 1,250 yung face bus duct natin, pwede tayong mag-neutral ng 1,000 lang, 70%, right? So, wala tayong ano doon. But, for good practice or good recommendation as designer, at least gawin natin 100. No? Kasi, in fact, yung iba nga, sabi ko kanina, 200% pa yung neutral based on the phase conductor. Kasi to compensate, no, or to mitigate on the heating effect of harmonics, no. So, perhaps, yun lang, no. Pwede rin na 70%. Then, the equipment grounding bus is simply based also from this, no? Kanina, 1,200. So, perhaps, we'll have a bus duct of 250 amperes grounding bus. So, to summary, sa residential, meron tayong bus duct ampacity of 1,250 amperes. Then, his neutral is 1,000 and his grounding bus is 250. But some other bus duct supplier or assembly, they are no, yung casing na niya is good as equipment grounding na yon. But make sure na nakaano talaga yon, no? Na meron silang certification nun. Kung wala, i-apply nyo talaga yung equipment grounding bus. Right? Okay? Nasabi ko na to kanina. So we'll just speed up. My time is okay. So for the voltage drop calculation, we'll have a simple calculation from the 4th floor, no? Okay. Yes, from this. We'll have an example from, ang sabi kasi na ano is galing talaga sa transformer going to the farthest load. But for simplicity lang, dito lang tayo sa 4th floor, no? At least the idea and the principle is there. So, yung pinaka main bus natin is 1,197 yung full load current niya. I mean, full load demand current, no? Apply na natin ang demand. At saka ang subservice niya per floor is 67.69. So, yung bus duct natin from ground floor to 4th floor is approximately 40 meters. So, from manufacturer's data, okay, yan. So, kung meron kayong manufacturer's data, so pwede nyong i-ano dito, no? But in this case, I make it conservative na wala yung bus duct kasi designing pa tayo, hindi pa tayo nakapag-award ng bus duct. For example, we have a good reference from our PEC, no? This is in page, I'm sorry, I'm not put the page, but chapter 10, no? So we have the resistance and the reactance of the cable. Okay, I'm very sorry. Cable yung na-example ko dito. However, the process is still the same, no? Instead of bus duct sana. So, just presume na bus duct ito, no? I'm very sorry for that. But anyway, the principle is like this, no? So, yung resistance natin at 40 meters, meron tayong 0.00176 ohms. Then, ang reactance din natin is, again, doon ko kinuha, no? Sana, sa bus duct, sana ito na reference. However, hindi ko na malayan masyado. Anyway, we will just presume na bus duct na ano to, no? Meron sana akong bus duct na reference dapat 'yon, pero anyway, let's presume na lang, no, na cable ito, no? Pero I think the principle is very very the same. So, nakuha na natin yung voltage drop presuming the power factor 0.8. So, cosine theta at sine theta is respectively 0.8 and 0.6. So, we are using the approximate formula for obtaining voltage drop, right? So, by doing that, i-add natin yung voltage drop for the main bus at saka yung sub-feeder. Okay, so ito yung voltage drop ng main bus natin, 40 meters up. Then we have the sub-service, same calculation. Okay, so this one is very applicable. Ito yung kasi kable yung sa 4th floor, no, yung main service. So ito yung applicable. So yung answer is voltage drop 2. So, i-total natin yung voltage drop sa main bus duct which is earlier presented 4.1 and this one is sa per floor na voltage drop. So, our total voltage drop is 4.2. So, the percent voltage drop is equivalent to 1.051%. So, very much marginal to our 5% requirement from the code. No? So, again, due to time constraint, allow me to go over and perhaps this presentation will be given to you. This would be your reference, no? Actually, madali lang naman, no? Then, for the short circuit calculation, we will have a very sample calculation, very short lang, no? So, this is the applicable formulas using the per unit method. So, parang cake of the icing na lang to sa mga designer, no? So mga students, go over with it. This is your assignment, and for the newly graduates and newly passers. Okay? So this is the per unit conductor. This is just the formula. I'm going to skip it. Okay, for that Simple example, ano lang natin, no, from Beco Utility, given tayo na may 170 MVA short circuit fault duty, no? We are considering that. So palagi nating i-coordinate, hinihingi natin to palagi sa utility. In this case, for our presentation calculation, 170 MVA, then our transformer is 1,500, percent impedance is 6%. So this is the dictating factor, no? So trivia lang, no? Oftentimes ang transformer is ma-mistaken natin na source of short circuit. No, it's not the case. That is just the source kasi doon nagdaan yung galing sa utility or sa grid, no? Actually the transformer are the impede, no? Yun yung nag-impede sa short circuit natin. So in any case, para naging source na rin kasi siya yung nag-dictate kung the higher the transformer, the higher also the short circuit value given. Likewise, the higher the impedance is the lower the short circuit, no? So the lower the impedance, the higher short circuit current value. Anyway, I'd like to move on. So from that single line diagram earlier, we will have an equivalent impedance diagram, no? From the utility, it is 1.0. Using per unit, always 1.0, angle 0. Then for our utility, given those 170 MVA, ito yung formula, yung choosing MVA base over the MVA ng short circuit ng utility, fault duty. Then the percent impedance of the transformer. This is the formula for the utility, right? So our answer would be 0.0082 plus 0.06. Okay, so naka-series yung dalawa, i-add natin, no? The two reactances. Then our equivalent impedance is 0.0688 at 90 degrees as the equivalent impedance. Then we will have to obtain the where the transformer is 1,500 as well as the fault duty of Beco is 170 MVA. So you just replace it in the formula. Alam naman natin na using per unit method is the formula of actual current is per unit multiplied by the base current. So para makuha natin yung actual, yung base current muna yung i-derive natin, which is from the transformer, which is our choosing KVA base ang transformer, at saka choosing KV din is the 0.4, and this is 3-phase that would obtain a 2,165 current base. So yung multiply natin yung per unit value natin kanina, so this would be the case. So yung transformer, the KI rating relative to the transformer itself, no? Para simplicity lang nga kanina, dito tayo, ang kinuha nating short circuit for simple calculation is the infinite bus lang ng transformer. So in reality, meron pa yung kable going to the main LVSG, no? So i-add mo na rin yung kable diyan. But for this presentation, dito lang, no? Sa transformer, yung secondary, yung 400 volt side, yung secondary bushing, no? Doon natin, so yung secondary bushing from our calculation, ito yung available fault duty doon, 31.46. Now, kung lagyan natin ng breaker doon sa infinite bus talaga, sa breaker nung sa ng distribution bushing ng secondary side, so ito yung basis natin. So the next higher size is the 36 KI rating. So specify natin yon, no? Select breaker with at least 1,250 amperes with 36 KI. But that is not the case, no? Like the seminar yesterday of Go Brian and Sir Russell Paraguso, even low voltage, we will have to consider the asymmetrical value, no? Yun yung pinakamalaking ma-discount ng breaker. So, this 36 kA, you should check if this 31.46 i-multiply mo nung XR ratio nung fault point, no? Yung fault point, yung sa bus, kung ano yung XR ratio doon based in your calculation, i-multiply mo pa yan, no? Okay? Very clear? So, for the commercial, similar lang yung calculation sa residential, but I would like to emphasize here for the more on the administration loads. So, simple administration loads, fire pump, very common. So, ang fire pump natin in this case is 50 horsepower, 83 amperes full load. Okay, so yung 83 amperes, kinuha lang if your fire, so sabi ng mechanical designer na 50 horsepower yung ano natin dyan, tapos 400 volts. So, kasi wala pa tayong code letter F. So, wala pa tayong pwede natin gamitin ang PEC, no? Nandito din sa PEC natin, no? Kung wala pa tayong, in the absence of the nameplate rating. So, 50 horsepower at 400 volts. So, we have the 83 amperes. Okay, so yun yung basis natin pag size up ng conductor. Ang sabi lang sa PEC, 125%. So, 103. Doon natin isi-size ang ating wire na 38 mm. Okay, so in this 133, doon na tayo sa 75 degree C column. Right? Okay. Now, this is more, we emphasize more in the overcurrent protection. So, based doon sa PEC natin is lock rotor yung pag-size natin ni fire pump. Okay? So, i-obtain natin yung lock rotor current, which is yung 5.59, galing din dito sa table. Code letter F. So, under code letter F, ranges from 5 to 5.59. So, pinili natin yung mataas, 5.59. That's why, at 50 horsepower, then starting code letter 5.59, we obtain 400.3 amperes. So, size up natin yung ating next higher size rating of the overcurrent protection for the fire pump is 450 at least. Okay? Again, meron pang another, aside from this overcurrent lock rotor requirement for overcurrent protection, as I shown you earlier, i-consider din natin yon, no? Yung 2 minutes at 300%, no? Nung full load ng 50 horsepower fire pump. Again, hindi ko na lang pinakita. The basics lang, no? Yung lock rotor. Kasi oftentimes, mistaken kasi, parang regular motor yung treatment natin sa fire pump. So, dapat lock rotor at least. Then, you counter-check the additional requirement in the PEC I have shown you earlier. Okay, again, there is no load over current protection. Then, of course, I would like also to emphasize elevators. So, for elevators, we have 30 horsepower elevator, 51 amperes. Then, with the auxiliary amperes or controllers, about 10 amperes. No? So, sizing the elevator protection, I mean branch circuit, is not 125%. It is 140% due to this intermittent duty cycle. Meron akong ibang designer nakita 125 talaga yung in-apply. So, violation yon. According to PEC, elevator is an intermittent load. So, dapat 140% ito, intermittent duty-free passenger. So, for continuous rating, for continuous load natin, 140% yung i-apply. So, that's why, meron tayong, but the auxiliary is, for example, yung on-off, up-down switches is only 125%. It is only the intermittent motor that is applied by 140%. Okay? So, the answer is 83.9. So, we will use 30 mm wire, copper. Again, I will just skip that one because shown you similar example. Then, the protection device for elevator is just 250%. Okay? Just the same. Nandito sa PEC din natin, if you're using inverse time circuit breaker for motors, it is 250%. Okay? Everything has reference. So, for your copy, madali na lang yung buhay ninyo. Then for the feeder circuit, we have 4 elevators of the whole building. So perhaps 51 amperes bawat isang elevator times 4. Again, kasi feeder circuit tayo, kable 140%. Then we'll apply 85% demand factor as shown on our PEC also. I'm sorry, this is for the intermittent. This one. If you have feeder demand factors for elevators, apat na, so 0.85%, you can assign demand factor of 85%. So by doing that, we'll have an answer of 292.76. Okay, allow me to fast track. Then yung gamitin natin na wire is 175 mm. Likewise, yung conduit is 80 mm. Okay, then the breaker is 350. Okay. So, yes, before I end up this presentation, wrap up lang. So, bali yung procedure natin for this example is gawin natin first yung residential, no? From the utilization to its subservice to the main service entrance, and then sa commercial ganun pa rin. However, the same lang yung calculation, and then followed by the administration loads. Yun nga, yung fire pump, alam nyo na paano pag-calculate, and so on and so forth for the elevators. So my time is anyway, malapit na, no? So allow me to emphasize, no, very important. Like I said kanina, yung bus duct orientation, I mean configuration. So this is it. Common mistake kasi, yung bus duct natin all the way from ground floor to 34th floor, naka-straight lang, no? Yung bus duct assembly natin, phase 1 ganyan, phase 2 at phase 3. So alam natin na may kuryente tapos mayroon yang induction, no, between. So as you can see, our phase B interacts with phase A as well as phase C. So, yung phase C interacts with phase B lang. And the phase A again is also interact phase B lang. So, kawawa si phase B. So, ang mangyari nito, meron tayong inductance unsymmetrical, no? So, mag-unbalance yung voltage natin. Perhaps dito sa ground floor, sa source talaga, lahat sila 230. Kahit walang load sa 34th floor, mano na, no? So, how to deal with it? So, we will impose a transposition method, no? So, yung phase A, gawin natin dito, ang phase C, phase A na siya, no? Parang i-cross over natin. Gawan natin yan ng flexible braided bus duct to connect that, no? Para makancel yung para mawala yung unbalance. Kahit no load, you might wonder, no, na yung system nyo ngayon, bakit unbalance kahit walang load. Okay, so that is the culprit of that. So, the recommendation is transposition recommended every 100 feet or 305 meters. Ano na talaga yan? Kailangan mo i-transpose yan. However, kung gusto mong 100 meters, much better also. Okay? So, comparison na lang, no, Sir Bob, maliit na lang, bus duct system at cable system. So, sa bus duct system, compact design, lesser space, economical siya kung 100 amperes and above ang system mo. So, additional feeder is quite attainable. Introducing top-off breaker, madali lang, no? In terms of voltage drop, maliit yung voltage drop niya kasi mataas yung mga resistances ng bus duct. While the cable system, larger space, then it is economical, 100 amperes and below. So, you have your tips, no, kung mga design na 100 amperes, wag mong i-bus duct. Then insulation is poor, no, kasi through the years, 15 years, 25 years, wala na. But easy to maintain lang, no. Okay, so that is the pros and cons of a bus duct and cable system. Then, okay, okay. So, yung reference ko is, uh, okay, if you like to study more, or shall you say, you will verify what I have said. So, this is yung reference natin, no? Okay. Ang reference natin is, yes, PIC 2017 issued, the IE Standard 551206, the IE Standard 241 1990, Design Analysis Building a System by J.H. Matthews, and the late Emiliano Marabollas. I was attending his presentation 2010, I think, and technical seminar also by Questo, no? So that are my presentation. Then perhaps before I end this presentation, allow me to have a simple quote by Bill Cosby, no? In order to succeed in life, your desire for success should be greater than your fear of failure. I'm afraid that this is the end of my presentation. Thank you very much, everyone. Sir Bob, thank you very much.
Thank you, Sir June. That is the very interesting topic you shared this morning. Especially, you are the designer of one of the mall chain in Cebu. So, at the same time, a contractor. So, thank you, Sir June, for sharing that information about the design of building an high-rise building. So, may I call in our one of the member of II Cebu chapter to award this certificate, Sir June. May I call in Engineer Eugene Araco.
Thank you, Mr. Engineer Rolot Litos Baldonado Jr.
Yes, thank you, Sir Jane.
Uh, Clear, sir. Claro.
Yes, 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 sir.
I, Cebu chapter would like to award this plaque of appreciation given to Engineer Raulito C. Baldonado Jr. PE as technical resource speaker on the topic of conceptualization of high-rise building in the Eastern and Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Sky Hall E&B SMC side South Road Property Cebu City. Given this 28th day of July 2022 and signed by our VP Technical Affairs, Engineer Ronmar Gonzalez, and then signed by Engineer Erwin J. Salvador, our Master of Science of Electrical Engineering, and also a PE. He's a technical consultant and advisor. Then signed by our Cebu chapter, IAE Cebu chapter, Engineer Magdaleno Baclay Jr., PE. And lastly, Engineer Ryan Pasilan, PE, our regional governor of Region 7.
Thank you, Sir Eugene.
Yes, thank you, Sir
Sir,
Bob, and see you tomorrow. Thank you very much.
okay.
Thank you, everyone.
Much appreciated, Sir June. By the way, for those who have questions regarding the presentation of our speaker, Engineer June Baldonado, you may put that in a Q&A box, and then if we cannot answer you right now, we will send you the answer of the respective speaker. Okay? So, thank you very much, Sir June. So, our next speaker for today, he is a young engineer, a graduate of Bachelor of Science in Electrical Engineering at Mindanao State University main campus, SCADA supervisor at Visayan Electric Company Incorporated, with specialty in SCADA system, installation and maintenance, with subsidiary in distribution automation, a registered electrical engineer, and soon to be a professional electrical engineer. Ladies and gentlemen, would you please welcome our speaker for today, Engineer Marcelo Canitan Jr. Isra, okay. So, Engineer, my apology. So, I messed up here. Engineer Isra Kadeven, Fundamentals of a SCADA System.
Yeah, thank you, Sir Bob.
Sir, my apology, sir.
Thank you, Sir Bob. Pressure ko sa soon to be PE na.
Soon to be.
Dungan na, Sir Bob. Sige, sir. Thank you, Sir Bob, sa kaning makahubag ugat tayong introduction. Ito. Thank you, Sir Bob.
My pleasure.
Sige, sir. So, mag-share screen ako, sir, so I can start with my topic. For a while, Sir Bob, ha?
Taking pictures with 2 lamps per picture.
Sir Bob, pakiconfirm ko, sir. Makita na ako mo screen, sir.
Okay. Sir, ikaw na sir. Oh, okay na. Okay, sir.
Kana, Sir Bob? Okay na, Sir Bob?
Kita na. Okay, good.
Sige. Sige, thank you, Sir Bob. Once again, good morning sa tanan. Once again, I am Ezra Nelson Cadiven. As mentioned by Sir Bob, I am currently the SCADA supervisor of Visayas Electric Company, no? Especially under the System Operations Department. So right now, I will be sharing to you, to all of you, the fundamentals of a SCADA system. And by the way, up to present, I'm 14 years na handling SCADA system that is Visayas Electric. So I will share my Maduro ko, Sir Bob?
Yes, Sir Isra. Okay ra, sir.
Okay. Thank you, Sir John. So I will be sharing to you my experiences, no, of the SCADA system. So start with my topic. I will share to you the outlines, for you to have a glimpse pod. So what will be expected of my topic. So first is I will share to you a short definition of the SCADA system and the evolution of the SCADA system, where I will be sharing to you the 3 different generations of the SCADA system, how it evolved from a simple system up to what system we have right now. And then number 3 is the typical SCADA system setup and its components. And the number 4 is SCADA system applications. So I'll be sharing some of the applications of the SCADA system and the benefits and the challenges of the SCADA system as the last part of my topic. So to continue, so let's define a SCADA system. So a SCADA system is a control system architecture comprising of computers, network data communications, and graphical user interfaces for high-level supervision of machines and processes. So it's actually a combination of a lot of components. So it was mentioned here, computers. You also have network data communications, as well as the graphical user interface. So I'll be explaining to you all of these components as we go forward with my topic. So SCADA is actually an abbreviation of the words supervisory control and data acquisition. So kita nga mga taga Cebu, we call this SCADA. The other, sa mga foreign, they call this SCADA. So as you can see in my slide, if you're into SCADA system, a lot of these words in yung ma-encounter. So the HMI or the human machine interface, we have the supervisory system, we have the RTU or the remote terminal units, we have the SCADA programming, we have the PLC, programmable logic controls, we have the communication interface. So to explain to you, the different generations of the SCADA system, so as you can see in the slides, we have the first generation, it's called the monolithic. The second generation is the distributed, and the third generation is the latest generation is the network SCADA system. So I'll be explaining one by one what are these generations. So the first generation or the monolithic generation is a SCADA system wherein standalone systems with virtually no connectivity to other systems. Meaning to say, simple lang itong setup. You have SCADA master in here, and you have different remote terminal units. They talk with one another. And if you have another system, they are actually standalone, so it doesn't talk to other systems. So it's just a simple SCADA master to RTU connection. That is the first generation of SCADA system. And this system is vendor supplied. So lahat ng mga devices na andito connected sa system na ito is actually provided by a single vendor. So if you are to purchase this kind of system, magiging tied up ka na sa single vendor. So all the devices that you have to add to your system, dapat andun lang sa isang vendor ang nagsusupply. Okay, so for the second generation naman, this is a distributed generation. So dito na-introduce na ang distribution using the local area networking. So a lot of operating stations are connected via the network. You still have the remote terminal units talking to your master stations. So multiple stations, each with a specific function, were connected to a LAN and shared information with each other in real time. So if I do have a single operator here, and also have an operator here, as long as they are connected to a LAN network, they can actually control your SCADA system. Pwedeng sabay kasi real time sila. So yan yung distributed SCADA system natin with the second generation. So the third generation naman, ito na yung parang cloud natin na database. So if you have a certain RTU here, so meron ka pa ring local area networking, and then if you want to add the data or to put the data dun sa WAN or sa cloud, pwede mo siyang ilagay dun. So as if ever you have a system na malayo sa iyong lugar, let's say if you are here in Cebu, and then if you want the data to be transmitted in Davao, so you can actually apply this kind of generation of SCADA system. So virtual, nagiging nagiging cloud-based na yung data mo. You are not specific na dun sa local area networking. So ano bang, just a little trivia, ano ba kaibahan ng LAN at saka WAN? Yung LAN, local area networking, which is yung kadalasan na applications niya, if you are in a one location, let's say a building, so if you have a network, pwede mong tawagin ayan as a LAN network, so local area networking. But if you are to extend that network farther, so let's say from Cebu going to Manila or Cebu going to Davao, that's a wide area networking. And we also have MAN, if you happen to hear that kind of word MAN, the metropolitan area networking. So it's actually parang upgraded version yan lang ng LAN. So we're in, let's say the whole Cebu, if you have a network, so that will be considered as MAN, or the metropolitan area networking. So that's for the TBS. So those are the three generations of a SCADA system. So it evolves from a simple system now to the latest system that we have, wherein we introduces the cloud database already. Okay, so showing now in the screen is the typical SCADA setup. So for a certain distribution utility. So ito yung typical na setup ha. So dito sa pinakababa, ito yung tinatawag nating area wherein we acquire or we are getting all the data. So we have the voltage sensors, we have the current sensors, we have the relays, we have a lot of devices sa field. So lahat ng mga data natin is galing sa field. So particularly dyan, sa amin, we are under the distribution utility. So most of our data galing sa substation. So we have a lot of sensors there. We have a lot of relays, input and output devices. So the next part of this typical SCADA setup is this one. This is very critical because this is the communication infrastructure. So this serves as the bridge from your remote, from your far away assets going to your control centers. Ito yung nagiging bridge yung communication infrastructure mo. So this could be a wireless or wired. So I'll be explaining that one later on with my slides. And then the last part is ito na yung control center natin. So we have the engineering stations and we have also the HMI stations. HMI is the human machine interface. So dito mo makikita kung ano yung nasa field. So let's say we have transformer here, it will be represented here by an HMI, by a human machine interface. So andito yung mga operators mo, dito sila nagko-control with all your assets outside. Okay, so ito yung parang typical setup of a distribution utility na SCADA system. So I will explain to you one by one these components. So yun na-mention yung kanina, data acquisition happens in the field. So ito yung the usual na data or mga devices natin na ginagamit in order for us sa SCADA system na makuha ng data. So we have the remote terminal unit or sometimes we call this one as the data concentrator kasi dito kinukuha o dito parang nagiging na-concentrate lahat ng data. So we have the meters, we have the relays, we have the line controllers if you are communicating to the line devices, we have the PLCs also and a lot of sensors in the field. So all these devices are called the IEDs or the intelligent electronic devices. Intelligent in the sense na or minsan tinatawag din silang smart devices. So hindi lang basta-basta if ever you are to include the device in a certain SCADA system, hindi lang siya pwedeng the usual device lang. Dapat smart device siya. Meron siyang protocol, meaning to say meron siyang DNP ba, meron siyang Modbus, or meron siyang proprietary protocol. Protocol pala is for us in the layman's term, para siyang language ng isang device in order for a certain device to another device to talk to each other. So this one, the remote terminal unit, is a key device in a local substation because this gathers all the data from the IEDs, different IEDs. So data acquisition, the data from the remote site substations are gathered to an RTU via different sensors, relays, or meters. So yan yung level ng data acquisition. So the next naman, as I mentioned earlier, yung communication, ito yung pinaka-critical sa lahat kasi ito yung exposed talaga. We have the fiber optic for the wired communication and we have the wireless, the microwave. We're actually using the IP-based radio. Itong wired naman, as I mentioned, na ito yung pinaka talagang critical kasi ito yung talagang makikita mo dun sa labas. Installed to sa mga poste namin. So ito prone sa cut. May mga instances na included ito sa mga nabe-break during pag may aksidente sa labas, vehicular accident, pwede itong matamaan. So very critical ang ating communication infrastructure and this is very vital dun sa ating SCADA system. Kasi you cannot get the data, you don't have all the operators dun sa ating control center will be blinded if ever wala yung communication. So data from the remote sites or substations are transmitted to the control station via wired or wireless communication. So if you happen to ask me, ito bang dalawa applied ba dito sa amin? Yes, we are applying this medium the wired and the wireless. Kasi meron kaming backup system. So if ever maputol tong wired, maputol tong fiber optic, we have a wireless communication that will that is ready to accept the data galing ng fiber optic if ever mawala yung fiber optic natin. Okay, so yan yung the next na components ng SCADA system, the communication. And the last one is the data presentation and control. So ito yung pinakahuling, let's say, hierarchy or level ng ating setup. Ito is, as I mentioned earlier, dito na-present or parang presented na yung data natin or ang mga devices natin doon sa field. So all our assets, ginagawa natin yan ng presentation dito sa control center. So we as the SCADA engineers or the SCADA team are the responsible teams who will do the setup for this one. So vital to kasi yung ating operators talagang ito yung gagamitin nila if they want to control a certain station. So if mali yung na-configure for a specific station, talagang mali din yung mao-control ng ang ating operator. So we have to make sure na well-maintained and well protected itong control center natin. So diagram showing the data from the remote devices, it is represented by a GUI, a graphical user interface, or an HMI, a human-machine interface. So data includes binary, analog, and control points. So andito na lahat, monitoring ng temperature ng certain asset namin, especially transformers. We have the status of the breakers. Dito din namin manalaman kung ilang load na ba ngayon ng certain feeder, anong feeder ba ngayon ang energized, ano ba yung hindi. So dito namin nakikita sa control center, which is through the HMI. Okay, so balikan ko lang. So we have the data acquisition sa field, and then we have the communication, and the last part is the data presentation and the control. So basically, ito yung parang cycle ng SCADA system data, no? So we have the data acquisition, wherein we gather all the data from the IEDs, different sensors. And the next one is the data transmission. So we can tinatransmit natin yung data from the field. Then we have the SCADA programming and the data mapping. So sinaset up natin yung data. And then the presentation, archiving, and the control. So included pala dito sa presentation, archiving, and control are the data historian natin or the database. So lahat ng mga data natin for the specific na feeder, nakalag yan in a specific archive time. So dito natin kinukuha. So ang importance ng data is for reporting or any post-fault analysis na ginagawa din namin. Okay, so yan yung basic na SCADA system data cycle natin. So moving forward, so what are some of the applications? I'll be sharing to you some of the applications of a SCADA system. No? So number one is the manufacturing industries. So a lot of manufacturing industries are actually using the SCADA system. No? So in the manufacturing industries, the regular processes like running the production systems to meet the productivity targets, checking the number of units produced and counting the completed stages of operations, along with temperatures at various stages of the manufacturing process, and so on, are taken care by using the SCADA application. So imagine if ito lahat, you will do this manually, so a lot of manpower, so parang may delay sa data. So if you have a SCADA system, pwede isang operator, yung ilagay mo dyan, and then the operator will just watch the system. So he can now know, or he have a parang the whole picture na sa manufacturing process mo. So yan yung advantage if you apply SCADA system in the manufacturing industries. So number two, applications, sample applications is sa mga water utilities natin. So SCADA systems are used for controlling the automatic operations, the equipment used like backwashing the filters based on the hours of working or amount of water flow through the filters. So included din dito sa mga water utilities natin ay yung level ng mga toxins or chemicals ng water, pwede ding ma-view nila via SCADA. So a lot of things can be done through a SCADA system. If wala, again, as I mentioned, talagang tedious yung process if you do this manually. And the third one Ito is yung pinaka-common, the usual mga distribution utilities natin are using the SCADA system to aid our operators. So a lot of things pwedeng mong magawa if you have a SCADA system. So the application of SCADA in a power system improves the overall efficiency of the system by providing the supervision and control over the generation, transmission, and distribution systems. SCADA in a power system network increases the system's reliability and stability of integrated grid operation. So ito lang, i-highlight ko lang tong sinasabi na increases the system's reliability. Reliable yung system mo in the sense na talagang nakikita mo na in real time kung ano nangyayari sa system. Let's say, may certain substation na may problema. So let's say, nag-trip yung feeder. So in real time, nalalaman ng operator kung saan area ang brownout ngayon. So so in a lesser time, pwede niyang maibalik yung power. If ever manual yung pagka ano niyan, talagang the longer time yung needed to be able to energize that certain area. So this is one of the advantage if you are to use a SCADA system for the power utility. Okay, so moving forward. So again, this is one of the applications also, no? So dun sa distribution utility, substation monitoring and control namin. So we are using the SCADA system HMI, operations like bus voltage control, bus load balancing, circulating current control, overload control, transformer fault protection, bus fault protection, and etc. So SCADA system continuously monitors the status of various equipments in substation and accordingly sends control signals to remote control equipments. So the next also is we have what we call the FLISR, or the fault location, isolation, and service restoration. This is one of the advanced na pwedeng magawa ni SCADA system wherein ito is wala na itong hindi na kailangan ng isang operator nito. So ito is nagiging automatic na ito yung FLISR. So we can set up this SCADA system to do the self-healing in a certain segment of the system. So ang mangyayari during a FLISR system is system detects the fault. So if ever may fault, so the next step is system isolates the faulted segment by opening the normally closed line devices. So if ever may certain area or segment ng system na faulted, so if meron kang SCADA system, i-detect niya yan. So yung mga naka normally close, i-open niya to isolate those area na may fault. So the next is the system commands the normally open devices to close to energize the healthy segment. So nangyayari pag may fault, so may interruption. So the system will isolate that segment na faulted. And then, if ever na-isolate na niya, i-restore na niya yung system to a normal state. So, i-energize na yung system via those line devices na are ready to accept or ready to energize yung faulted, yung unenergized na segment. So, with this application, in a very short period, na-energize mo yung healthy na portion ng iyong system while continuously isolating those faulted na segment. So ito yung one of the applications or advanced application ng SCADA system namin. So the fault, location, isolation, and service restoration. So now I will be sharing to you also what are the benefits of the SCADA system. No? So even though na-mention ko na as I go along with my presentation, so these are the benefits of the SCADA system. So number one, increased system reliability. So due to a timely recognition of faults, equipment damage can be avoided. So talagang talagang helpful yung SCADA system namin kasi meron kaming profiling of our assets. So tinitingnan namin kung ito is parang problematic na ito kasi yung trending niya medyo tumataas na yung temperature level niya, though hindi to normal. So we are actually monitoring the assets namin. So timely recognition of faults or equipment damage can be avoided. So number two is continuous monitoring and control of distribution networks performed from remote locations. So as long na connected kami sa network namin, even though we are at the farthest substation, pwede namin makontrol yung system namin. So the next is to reduce the outage time by system-wide monitoring and generating alarms so as to address problems quickly. So yan, kasi may mga real-time alarms na lumalabas. Let's say may brownout to a specific area ng Cebu, nalalaman agad ng operator namin via the SCADA alarms. So the next is improves the continuity of service by restoring service after the occurrence of faults. Ito yung sinasabi ko kanina, one of the applications yung Fleaser. So the last is automatically improves the voltage profile by power factor correction and bar control. So ito, as you can see at the bottom of my slide, no, yung Sci-Fi SID. Ito yung pinaka talagang target namin. We have to make sure na we have a low Sci-Fi and SID for the year every year. Kasi we are being regulated, no, sa ERC. So we have to make sure na minimal lang talaga yung interruption ng mga customers namin. So yung frequency at yung duration ng interruption. We have to make sure na at the very least of time, talagang ma-energize o ma-normalize na namin yung system. So the next benefit ng SCADA system is reduce operational cost. Of course, if you have a centralized monitoring, pwede ka nang wag maglagay ng tao dun sa certain substations to do the manual operations. So pwede mo nang the operations will be at the control center na lang. So pwedeng wala ka ng tao to do the manual operation. So reduces the labor cost by reducing the staff required for meter reading. So noon talagang manual pa, though hindi naman talaga lahat na automated na yung meter reading namin, meron pa rin kami mga manual. Kasi meron din tayong mga technical na limitations din. Okay, so due to timely recognition of faults, equipment damage can be avoided. Yes, so I mentioned this earlier, no? Kasi meron na tayong trending ng mga data natin, so we can set up a schedule na to do the preventive maintenance on our specific assets. So number 3 is improve worker safety. So kasi wala na tayong or less na yung manual na controls natin doon sa field, so less na din yung exposure ng ating mga lineman, particularly the lineman, no? So less na lang yung exposure nila sa field. So eliminates manual operation and remote health monitoring and different substation assets. So ito yung pinakamahal na assets namin when we are in the utility, because we are in the utility. So yung transformer namin talagang minomonitor namin yan. Kung talagang normal pa ba yung temperature niya with a specific load. If ever hindi na, so talagang yung schedule namin for the maintenance. So yeah, and then to also explain the safety side, no? Kasi monitor na namin yung mga assets namin, most of our assets. So pwede din namin sabihin na, oy, yung certain substation na yan, huwag yung pasukin kasi medyo mainit na yung temperature ng mga bus bars natin. So pwede na namin yung shut down automatically before the substation engineers will go. So that improves the safety of our workers sa field. And then number 4 is again greater customer satisfaction. Kasi nga as I mentioned, if medyo maliit lang yung time na nababrown out in specific area, so yung satisfaction level ng customer talagang mataas. So reduce the outage time by system-wide monitoring and generating alarms so as to address problems quickly and to improve continuity of service by restoring service after the occurrence of faults. So like mga temporary faults. So those are the benefits. No, I'm not saying that yun lang yung benefits ng SCADA system. Yun lang yung parang major na benefits ng SCADA system. But a lot of benefits pa na pwede makuha when you are using the SCADA system. So dito naman tayo sa challenges of a SCADA system. So what are the challenges that we are facing, especially us na we do the maintenance sa aming SCADA system. So number 1 talaga is cybersecurity threat. We all know na late lang kasi the usual sa atin naka-work from home, so technology talagang lahat gumagamit na ng internet. So itong SCADA natin is we are actually doing or investing a lot of money for the protection of our SCADA system kasi we cannot afford na pwedeng mapasok ng mga hackers itong system namin. Kasi we don't know if anong damage ang pwedeng magawa if ma-hack ang system ng SCADA. So we have to make sure na protected yung SCADA system. So on the right side, as you can see, the IT and the OT, talagang separate yung SCADA system. SCADA system actually falls under the OT or the operational technology. So hindi siya pwedeng directly connected with the IT. Meron kaming tinatawag na DMZ or a demilitarized zone. So dito mo lang pwedeng ipasok yung data galing ng IT. Pwede mo rin dito ipasok yung data galing ng OT. Hindi mo pwedeng ipagsama itong dalawa. Kasi vulnerable, so vulnerable itong sa IT na side. Sa OT naman, dito yung kinukuha yung data. So if ever may mga applications tayo, ito yung gamit ng IT. So again, cybersecurity, we are investing a lot to be able to make sure na yung system namin is protected. The maintenance costs, we have to make sure also na up-to-date yung mga systems natin. So if ever may mga update ng technology, na technological changes, update din natin yung system natin kasi hindi natin pwedeng iwanan na yung system na ganun kasi yung mga devices din naka-upgrade din sa field. So if our system is parang out of date, so hindi mo na pwedeng ma-add yan ng mga bagong devices. You have to make sure na updated din yung system natin. So that's one of the challenges that we are facing. So and then maintaining a reliable and robust communication infrastructure. So as I mentioned earlier, ito yung talagang critical sa system namin, yung communication. Kasi nga prone siya sa public, no? Kasi andun siya sa labas yung asset namin. So we have to make sure na yung robust yung communication infrastructure namin, especially the wireless, because most of our line devices are actually using wireless communication. So we have to make sure na robust yung communication infrastructure, ulan man or init, talagang talagang dapat tested siya na talagang tatagal siya dun sa labas. So yun yung mga challenges namin sa SCADA system. With all the benefits, yun yung parang alam natin na if you go higher with the technology, talagang tataas din yung level of threat mo in terms of security. Okay, so I guess that's the end of my very short presentation. No? Thank you for listening. And then if ever may mga questions, I am willing to answer. Sir Bob?
Yes, sir. Thank you very much. Very, very interesting. By the way, sir, there is a question in a Q&A box from Pancho. So did you read that, sir?
Sige, sir.
Okay, so you just send your number to Sir Pancho. Okay, as a summary of your discussion, sir, it is about the input and output for SCADA. So the inputs, there are sensors that sense the voltage, current, power factor, and so on so forth. Then you have the output, and that would be the execution of what has been programmed. So the that is more on maybe someday uh, the connectivity mostly is done by fiber optics. But as I have read on the papers, we have already the carbon nanotechnology, carbon nanotube technology, wherein it is better and less resistant. So it might become someday. Okay. So thank you very much, Sir Isra Kadaven. May I call in Engineer Rako to award the certificate to our speaker, Engineer Isra Kadaven. Sir.
Hello. Thank you, Engineer Ezra Nelson Kadibin, RE, for the for your session. Uh, Institute of Integrated of Electrical Engineers would like to award this plaque of appreciation given to Ezra Nelson M. Kadibin, RE, as technical resource speaker on the topic of fundamental of a SCADA system in the 21st Eastern Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Sky Hall E&B, SMC Side South Road Properties, Cebu City. Given this 28th day of July 2022, signed by Engineer Ronmar B. Gonzalez, PE, our President Technical Affairs, and Engineer Erwin J. Salvador, our Master of Science in Electrical Engineering, and also PE, our Technical Consultant and Advisor, and also in our IIE Cebu Chapter President, Engineer Magdaleno Baclay Jr., PE, and lastly, Engineer Brian A. Pasilan, PE, our Regional Governor of Regional 7, Eastern and Central Visayas.
Thank you, sir.
Okay, thank you very much. Sir, you are on time. So our next speaker for this morning, he is a graduate of Bachelor of Science in Electrical Engineering at the University of Cebu, main campus. Former distribution engineer of Cyan Electric Company. Former account executive of VECO for managing account contestable customers. 1 megawatt club. Candidate of graduate studies. Master's in for public administration. Training cadet program, electrotechnical officer. General manager, MARR Engineering Services. Soon to be a professional electrical engineer. Ladies and gentlemen, would you please welcome our speaker for this hour, Engineer Marcelo Canitan Jr. He will discuss the watercraft power system design.
Yes, sir, Bob.
I-unmute na.
Good morning once again, fellow engineers and practitioners.
Good morning.
Okay, today allow me to share with you the watercraft power system design. Actually, last year during the regional conference, it was discussed the introduction of the watercraft in reference to our Philippine Post Chapter 9. Today, we will be doing the power system design of the watercraft. Are you ready to listen? You can just press the heart button to start with this presentation. We're just kidding. I have been practicing my profession as an electrical engineer for 17 years already in different various industries. I am currently managing my own company, my engineering services part. My primary services, offering and engineering services focusing on technical design, installation, and maintenance. What Sir Bob introduced anyone who was hard work. Thank you very much. My pleasure. Okay. I have been serving for 8 years already as a technical officer in your company. So today, I will be imparting to you part of my technical engineering report related to the presentation of power system design. So objective of this presentation is to discuss the watercraft power system design velocity of the vessels, system dimensioning, system detection and maintenance. Lastly, to identify the questions in the Philippine development code. So I will be tasked to do this presentation for an hour. So if I will already extended, Sir Bob will. Sorry guys, now we have
By the way, our apology for you guys. We have a technical glitch here. So there's a feedback and so on and so forth. So we do some mitigation here. Hopefully, we are going to go for a couple of minutes. By the way, we are going to also to announce that this internet here in IICB chapter is powered by Dito for free for a couple of days through the effort of Engineer Catalino Munin. Thank you very much, Dito, and also Sir Catalino Munin. Thank you very much. Okay, so Sir June, your time.
Sir, can you hear me?
Yes, sir. Loud and clear.
Yeah. Okay, going back to our discussion. First, we have to understand the ship's important components. So we are all know that in the design stage, we must consider factors that contributes the successful design and installation. So for a ship, ships are identified as large, complex vehicles, which must be self-sustaining in their environment for a long period with a high degree of reliability. A ship is a product of three main areas of skill, those of naval architect, the navigating officer, and lastly, the marine engineers. As all we know, the naval architect is concerned with the hull, this part. And these two components playing big role in operation of the vessel, hull and the superstructure. So more especially, this means the machinery requires for propulsion, steering, anchoring, and ship securing, cargo handling, air conditioning, power generation, and its distribution. So as I mentioned that there are two main parts of the ship, the hull and the superstructures that are presented in the slides. Okay, the hull of the ship is the most notable structural entity of the ship. To define the hull, it can be said that it is the watertight enclosure of the ship, which protects the cargo, machinery, and accommodation spaces of the ship for from the weather, flooding, and structural damage. But this alone does not suffice our requirements of understanding all the aspects of the ship's hull. Hull also serves as the biggest form of mass that can hold any huge amount of electrical faults that may occur. This also, we can find a grounding plate for the lighting protection in the design of our electrical system design. So, watercraft common electrical system requirement. We all know that there are different classification of watercraft. As to mention, we have this Roro, we have this general cargo ship, we have also these tugboats, but all these different type of classification have the same requirements in terms of electrical system. So as we are going to discuss the power system design, for the watercraft, we have this power source, the wires and cables, distribution and circuit protection, and lastly, the loads. For the power source, we have three main generators. This consider as the normal. And there is also an emergency generators that can operated during an emergency situation. And lastly, we have this shore connection. This shore connection can be utilized during dry dock season or schedule. The second is the wires and cables. Wires and cables are different type of wires that are installed on board the ship. This is different from the household that we are using right now on the shore, and more protective and more rigid compared to the normal or common wires that we are using. For distribution and circuit protection, we have this short circuit protection, overload protection, main distribution circuit protection, motor circuit protection, lastly, the power transformer primary protection. For the loads, we have identified the essential loads and the non-essential loads, duplication of services. For the essential loads, these loads are essential for the critical operation of the ship. Di dapat ito mawala. There are duplication in order to have this full backup in case of emergency. So in the event that the one unit failed to operate, then the other is available at any time. For the non-essential loads are qualified as a non-essential. Hindi siya masyado kailangan in the entire operation. It not necessarily connect to the day-to-day operation of the ship, most especially during navigation. So hindi siya laging ginagamit. So they classify that as non-essential loads. For this discussion of this power system design, allow me to discuss the power system design of the proposed 150 kilowatt 3.3 kV bow thruster. This is part of my technical engineering report during my application for professional electrical engineer. So in this discussion, we have this classification of watercraft, which I have some data coming from a general cargo ship or general cargo vessel, a load requirement of 1,150 kilowatt, 3.3 kV, design calculation and analysis and recommendation. So background, if you are familiar with the structure of the ship, for the bigger ships such as ships are having 44,000 gross tonnage. For the international law, they are required to have this bow thruster system because during the transiting from port to port, this bow thruster helps to easily maneuver of the big or huge or large ship in crossing across the sea or the channel. So with this bow thruster, the maneuvering of the diverting and departing can easily be done. And the second purpose of this bow thruster is the economic impact. So for big ships such as this type of ships of general cargo, we have considered these tugboats in order to bring the ship up to the port. But because of this bow thruster installation or bow thruster system, ship can independently maneuver or operates up to alongside of this ship. So the bow thruster can be found in front or bow, meaning the front side of the ship, where this large motor are installed, an axial form of motor at the bow part of the ship. So overview of electrical design. So from the source of generator, main bus, the low voltage protection, step up transformers, medium voltage protection, and motor load. So usually, commonly the ships having a 450 volts main bus coming from 3 different generators, or some are they are identical generators. But in this case, there are 2 identical generators and the others different size from the 2. This is because of economic aspect that the company is looking at. Because during navigation, they will be using this smaller size of generator in order to sustain the small loads, small non-essential loads and essential loads during navigation. So this is the overview. If we are going to put in the bow thruster system into the system of power system of the electrical over yes, from transformer we have this medium voltage protection and the motor loads. So for the load calculation and analysis, the motor specification to be installed in the system, which is as I mentioned, that this is 1,950 kilowatt output and 3.3 kV, 60 hertz, at full load current of 425. So by using the code of 2017 part section 1, section 4.330.11 page 368 for calculation of sizing of branch motor. So the branch conductor current at 125% of the full load current of the motor load. So this is the computation. If we are going to multiply it, we got 531.25. So based on that, we will be using 3 sets of FAH-TYPC70. Actually, this is the type wires that will be using on the marine application. So this is tray core of 17 inch square, ethylene, propylene, rubber, insulated, polyvinyl, chloride, sheet, steel wire braid. This can be found on the table 3.5, 1.4, TMC marine, and shipboard cable. So this is the table that we are referring to in order to get the size of wires that after computation of the size of the conductor. Sizing of motor branch circuits over current protection, we have this 250% using again the PEC 2017 part 1 table 4.3 30.4.2 page 356. We are getting the product of 1062.5 as 250% of the full load current of the motor. So we can use the 2000 ampere trip, 3300 volts inverse time circuit breaker, referring to PEC 2017 part 1 section 2.4 40.1.6. The sizing of equipment grounding protection is we can use this one or single wire for 1 to 5 million square stranded copper HW wire based on the Philippine Electrical Code 2017 table 2.5.630. The sizing of the motor branch circuit overload protection. So this formula is coming from Philippine Electrical Code. It says that the bow thruster, since the bow thruster is 1,000 volts of nominal voltage beyond or more than 1,000 volts, in a consideration of these loads as part of the Philippine Electrical Code, and it states that the conductor supplying the motor shall have the capacity not less than the current at which motor overload protection devices are selected trip. Hence, Philippine Electrical Code Part 1, Section 4.30.11, page 300 state the rating of the motor control apparatus, which states that that the devices used shall not exceed for 115% of the controller's continuous current rating. So if you remember that a while ago we are stating that 250%, but right now that's because of this provision, we'll be using now the 115% of the motor, 115% times the motor nameplate full load current. So with this, we have 488.75 amperes. So we can use the overload protection relay that limits the maximum settings to 600 amperes only. For transformer of the bow thruster motor, assuming that 80%, we have this 1,150 kilowatt watts at 80% demand factor. Transformer kVA will be 2,437.5 kVA. So we will be using 2,500 kVA at 450 volts, 3,300 volts delta Y dry type transformers. Calculate the full load current of transformer. So since we have already established the size of transformer, we will be solving or calculating the primary side full load or full load current of the transformer. So with this, we have this 3,207.59, but the secondary is only 435 because we are in the step down dry type transformer. So calculation of transformer cables, again, a standard
reference from the Philippine Electrical Code, we have this 125% of the rated full load current. So 1.25 times the full load current at the primary side of the, for the sizing of the cables. We have this 4009.48 amperes. Calculation of transformer cables. So we have these 16 sets of HP TPYC 120 for the primary side of the core 120 M square, ethylene, propylene, rubber insulated, polyvinyl chloride sheet, steel wire. So this can be found at the table of the TMC marine and shipboard cable. All right. For the transformer secondary cable, as computed, we have this 546. So we will be using another type of transformer of H-TPYC 50. 3 core, 50 mm square, ethylene, propylene, rubber, insulated. Yeah. So for the main generator sizing, we have consideration. We have this power system that includes the engine system, which is includes the motor operations for the entire engine system, the cranes, the ballast, the steering gear. Lighting system is also have this accommodation and navigational lights that can be using during this navigation condition. And the third one is the internal communication and navigational system. The last one is the automatic system. This consideration of loads that are contributing to our sizing of our main generator. So this is the actual data that I gathered from the actual operation of the general cargo vessel. There are limitations or there are conditions that are considered in order to get the total loads of the generator during this running condition, a normal running with ballasting, berthing or deberthing of port, cargo operation at port, no operation at port, emergency general use, generator use, and emergency use blackout. But by the way, bow thruster system is only can be operated only during berthing and deberthing of the port. So meaning to say, in a normal situation like loading, the bow thruster system is not in operation. So most of the time during maneuvering lang ginagamit itong bow thruster natin. So if you notice, these are the total loads that requires to operate using the bow thruster system plus the other loads contributed during those time operation. So we have we get the total load of 3,148. This is a 79.34% of the total load factor of the installed generators on board the ship. And for the normal operation, we only have this gantry cranes and the other loads such as 440 volts for the motor loads. We have summarized to 642.67%. And for the other cargo operation, we have this 55.78% of the total load capacity of the generator. The total load of generator of 2,497.5 So we divide it by 3 as we are allocated for the 3 main generators in order to size them up. So we have 832.5 kilowatt. So in the general cargo vessel, it is about 75 to 80% to one generator set in order to get the actual size of the generator. So in this total load for one generator computation, 832.5 divided by 75%, we have this 1,110 kilowatt. So we will be using the specification of the generator as 1,499 kVA at 450 volts, 60 hertz, 3-phase, 80% power factor, diesel-driven generator. So the watercraft power system, this is how it looks like, but some ships are different of having this shaft generator motor. But typically, this is the this is how it looks like underneath the engine room, where the service generators are being situated nearby this main engine, the main engine, and the main switchboard distribution transformers are also located at the electrical room, at the engine control room. So this is the actual photos of service generators. These generators are identical, but there are some ships, as I mentioned a while ago, that there are ships providing 2 identical generators only, and the other one is a small size compared to the other 2. But there are some ships that are less than 40,000 gross tonnage having this identical generators are being installed in the engine room. Sizing of generator sets protection. So actually, this is all familiar with us with this applying this computation in reference to our Philippine Electrical Code. Familiar naman na itong lahat sa atin kasi ito yung ginagamit natin na formula in consideration to compute this protection. Spreader lines for bow thruster motor. We have sizing of motor branch circuit conductor. Again, we have this 155% of motor load full current. So we have this already. By the way, in marine cables, we have this H-TPYC, means the 3-core ethylene propylene rubber insulated polyvinyl chloride steel wire thread are normally shaped in triangular. So, meron pa rin sa practice pa rin sa barko na ginagamitan natin ng triangular shape during the installation of these cable wires. So voltage drop calculation from IEEE standard, we have this formula. Voltage calculation will be determined whether the farthest motor in the power system conforms the Philippine Electrical Code 2017 Part 1. And the maximum total voltage drop on both feeder and branch circuits to be farthest outlets does not exceed 5%. I refer to the drawing, I refer to the illustration or formula of this voltage drop calculation that we can get it from the IEEE standard. So this is the values of the actual wires being installed. From resistance, we have the reactance values, and then computed, we have total of voltage drop 43.25 VR, and with the medium voltage of 3,300 300 volts, we have the total voltage regulation of 3.2 kV. So in percentage, we have only 1.31% of the total voltage drop percent. So I have also presented the voltage drop calculation in all designation from the line goes to the group starter panels, from group starter panels to the load, and same with the bow thruster to transformers to bow thruster motors. So this is in relation with the computation of the total voltage drop that had been computed. Now, for the short circuit withstand, we will also be referring the formula coming from IEEE. This one, this short circuit withstand formula or calculation. The short circuit withstand rating of the cable will be determined value of the alternating current component of the prospective current of the cable will be able to carry the event of short circuit condition. So I think we are familiar with this, that in order to have a good quality of wires that we are going to install, we have to determine first the short circuit withstand of the system. So however, the protected by the suitable short circuit protective devices or SCPD in series can withstand the operating time of the current under specified test condition. In consideration to the main purpose of the study about the bow thruster rated 1,950 kilowatt, or that's around 2,614 horsepower at 3.3 kV, three phase. The short circuit withstand rating copper conductors using the equation here from the IEEE. So as computed, we arrive the total short circuit current at 56,321 amperes. For the fault calculation, we have these steps or procedures in order to determine the value of the in calculating this fault calculation. So first, we are going to draw the single line diagram showing all sources of short circuit currents and other essential power system elements like transformers, cables, circuit breakers, etc. The second, calculate the resistance and reactance of the components in per unit expressed from the common MVA and kV base. Note that data necessary in fault calculation should have already been established or identified. The third one is to draw an equivalent impedance diagram showing all significant resistance and reactance expressed in per unit quantities. Identify the type of fault and location of the fault in the system. Draw the individual sequence network diagrams, positive, negative, and zero sequence diagram. The sixth one is to calculate the Thevenin's equivalent impedance at the fault point. 7, calculate the per unit value of the fault current. And lastly, calculate the actual value of the fault current. So we have here a single line diagram, and this is the diagram of the general cargo ship, where you can see the three generators as the main source of power, and we have this bus. As I designated the fault 1 here at the main bus, and the second fault at the emergency bus, and the third fault would be at the bow thruster system bus. So actually, we will be repeating the same procedure as we are going to solve each fault location, but the output or the outcome of the computation will be different from each other. So there are 4 types of faults in the power system presented in this technical report. No? three-phase fault, a single line to ground fault, line-to-line fault, and double line to ground fault. Of all the faults, the three-phase fault is usually most severe and damaging, but its occurrence is not as common as compared to the single line to ground fault. The three-phase faults are calculated using Thevenin's theory, and it is based on the positive sequence components. The single line to ground fault is composed of all the three sequence components, namely the positive, negative, and zero sequence components. However, in IEC 60909-0 recommends that the line capacitance be included in zero sequence network if the system neutral is not solidly grounded. If the system neutral is solidly grounded, neglecting zero system shunts leads to conservative results, and it is not necessary to consider inter-sequence coupling in order to justify the use of symmetrical components. For this, we have these impedances that are relating to our the whole system of the bow thruster, and also considering also other loads that are contributing for the entire of ship's operation. We have this the summary of the impedance for calculation, for fault calculation. So this is the equivalent positive impedance at fault 1. But by doing this, so we will be repeating again for the process of getting the positive sequence impedance for the fault number 2 and 3. So from the single line, from this drawing, we will be converting this to impedance drawing like this one to form this and to form this diagram up to this impedance diagram. Now, by doing it so, we can get these values to summarize the fault calculations. By the way, this is just a presentation of my onboard the ship calculation of the power system, the presentation of the power system design. But we have these different topics can be discussed for calculating or doing the fault calculations. But with this, I will just be presenting to you the output or the outcome of the calculation, where the process are already done by this fault calculations. Here we have this understanding the grounding system, the watercraft. So for the word grounding, it is commonly used in electric power system to cover both system grounding and equipment grounding. So here we have these two types of system, ungrounded system and grounded system. But for the type of vessel, we have commonly used this ungrounded system. We have this comparison connection of ship connection and the shore connection. Now, the requirement ashore is to safety of human beings. So in order to prevent human electrical accidents and neutral earth, the priority neither be the safety of machinery. So in order to prevent human electrical accidents, the neutral is earth. So that is the methods that the ashore is using. For the priority, neither be the safety of machinery nor the continuous necessary operation of the machinery. But the scenario on board the ship is totally different. The priority is the continuous operation of the machineries, which are classed as essential. The distribution system followed on board is insulated neutral system. This one, insulated neutral system. The main priority on board is the safety of the ship, which includes navigation and fire safety. So actually, this is more on the machines that they are protecting to any occurrence of fault during navigation or operation. Kahit na may fault, tuloy-tuloy pa rin yung operation. But there are alarms, there are audible alarms are being raised or automatically alarmed by the automation system that the system is experiencing some earthfall. No? So the main priority on board is the safety of the ship, which includes the navigation and fire safety. If due to earthfall, the machinery classed as essential get isolated. For example, the steering gear, we have this. This is one of the navigational equipment. Then the safety of the ship is a question. If there are some faults occurs at this machine, that may lead to collision. So, importante siya na kahit naka-experience ito ng fault, ay it will not be automatically trip off the entire operation. You can just imagine that the ships is transiting from one port to the other at a narrow seawater. So kailangan natin na i-sustain or kailangan natin na operate pa rin, in operation pa rin yung machines natin kahit na may na-detect na fault. Different from the shore side, if there are faults are being detected, the breakers are automatically tripped in order to isolate the fault of that particular equipment. So, actually, the priority on board is to maintain the continuity of the supply of the machinery in the event of a single earth fault occurring. So, yun na yun. Kailangan talaga na manatili yung operation ng equipment natin, most especially parts siya sa mga critical loads and at stake yung safety for the navigation. The basic circuit consists essentially of two parts, no? The conductor and the insulation. The conductor, which we know that which carried the current around the circuit, and the insulation, which keeps the current inside the conductor. Only two types of circuit faults can occur: either break-in in the insulation or break in the conductor. The break in the conductor leads to non-flow of the current in the circuit. A break in insulation leads to an earth fault, allowing the conductor to touch the hull or earth metal enclosure. So nabanggit ko rin kanina, di ba? Hull is the biggest mass of the ship. If we know that the ships are made of metal, so in the event that there is a break in the insulation, so automatically this earth leakages can be continuously detected because of the metal composition of our hull, metal earth composition. So a short circuit fault is due to the double break in the insulation, no? Allowing both conductors to get connected. So thus, a very high current passes through by passing the load. So a majority of earth faults occurs within the equipment. So generally, insulation failure occurs, which leads to the conductor getting in contact with the body of the metal enclosure. So nagko-conduct na siya doon dahil meron na tayong break-in insulation. So when such earth faults happen, the metal enclosure of the equipment, if not earth, would be cause a heavy shock and may result in fire accident too. So significance of earth faults. So in an earth fault occurs in an earth distribution system. Yung 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 common name natin yan is parang grounding, no? Nag-ground natin yung yung distribution system natin. But in this case, if an earth fault occurs in an earth distribution system, it would be equivalent to a short circuit, a fault across the load via ship's hull. The resulting large earth fault current will be immediately blow up the fuses in the line. Thus, the equipment is isolated from the supply and thus rendered safe. This may result in hazardous situation if the equipment is classified as essential. For example, the steering gear, as I mentioned. The steering gear is the equipment, the critical equipment using operation during navigation. So thus, the earth distribution system requires only one earth fault on the line conductor to cause an earth fault current to flow. So if the earth fault occurs in insulated neutral distribution system, it will not cause any equipment to go out of operation and thus maintains the continuity of the operation of the equipment. So kaya yung design or kaya yung system doon sa barko ay kailangan natin yung insulated neutral distribution system, hindi yung tinatawag natin na earth distribution system. So talagang magkaiba yung methodology of electrical wiring installation from the shore and on board the ship. So at this point, to be noted that the machinery still continues. So if the system is insulated neutral distribution system, it will not hamper the operation of that specific equipment. Just like we are going to navigate from port to port, so all navigational equipment are being used or utilized during that time. So there must be no interruption of the operation. So thus, a single earth fault will not provide a complete circuit for the fault current to flow. So continuous pa rin yung operation. Other significance is the three-wire insulated neutral. If the second earth fault occurs, then the two earth faults together would be equivalent to a short circuit fault. Thus, resulting large current would be operate the protection devices, cause disconnection of perhaps essential services, creating the risk to the safety of the ship. An insulated neutral distribution system requires two earth faults on two different lines to cause an earth fault current to flow. Thus, an insulated neutral system is therefore more effective than an earth system in maintaining the continuity of the supply to equipments. Yan. Iyon ang kalagahan natin for the three-phase for the insulated neutral system as practice on board the ship. So for this is the typical three-phase, three-wire neutral insulated ungrounded with low voltage grounded system. So this is the typical electrical schematic diagram of watercraft. Either you could have been on board for RoRo, general ship cargo, passenger ship, tugboats. All of these, we have the same system, the three-phase, three-wire neutral insulated ungrounded system. So parehos pa rin yan kahit iba-iba yung classification ng barcode. So insulated system in one that is totally electrically insulated from earth, or the earth sa barko, ang tinatawag nila yung ship's hull. No? The reason for using an insulated system, the priority requirement on board the ship is to maintain the continuity of electrical supply of the equipment in the event of single earthquake. Kaya nga yung lahat ng install doon, meron siyang insulation. So an insulated system, one earth fault does not interrupt the supply, but raises warning on the earth detection system. This allows the operator to locate and clear fault. Advantages of insulated neutral system avoids the risk of loss of essential services like steering gear. One earth fault doesn't interrupt the supply, but an earth detection system will warning. An earth system has one pole or neutral connected to the earth. On board the ship, the main system is normally insulated for the bus bar voltage of 440 or 450 volts. When the voltage exceeds at 1000 volts, then the neutral of the alternator has to be earth. So kung lalagpas pala ng 1000 volts yung voltage system doon sa barko, then the neutral of the alternator has to be earth. So this is the typical diagram for the earth leak detection. As I mentioned a while ago, in the event that there is a fault, so there will be an audible alarm, alarming that that single line have this has detected some earth fault. This one. A generator of neutral earthing resistors from Philippine Electrical Code of 9.4.31. The grounding resistor defines that the grounded neutral of the generation and distribution is used. Grounding shall be through fault current is limited to a value which is not greater than the full load current of the largest generator on a switchboard section, nor less than the 3 times of the minimum current requires to operate any device against fault. Yun. So itong neutral earthing resistors, may mga ship's classification or watercraft classification is also installing this type of neutral earthing resistors. Most especially the voltage is beyond 1000 volts system. We have this protection in earth system. Yeah. So the core balance current transformers, we have the starter, we have their ring circuit for earth fault relay. So with this protection of an earth system can also be provided using the CT, the current transformer. If the motor is healthy, phasor sum of the current measured by CT is 0. So if an earth fault occurs in motor, phasor sum of current will not be 0. May ma-detect or may makuha na fault in the motor, phasor sum of the current down will not be 0. If the system is healthy, then the equivalent reading coming from CT is 0. So this is the diagram for air fault detection. So in some cases, especially sa barko, during arrival or alongside of the ship, this port authority will directly inspect, will directly check this earth fault monitoring, because as all we know that ships are made of metal, so natatakot sila if in the event that there are fault detected along the line. So in their mind, unsafe to work with this earth fault occurrence of the system. Kaya tinitingnan nila doon yung monitoring natin kung ano na yung actual reading. If the code, kung makikita nila na below or mababa na yung insulation, nag-aalarma na yung ships are subject to detain. So hindi nila bigyan ng clearance to depart from the port. Or otherwise, they will be assigned for the penalty after the ships are being checked at mag-ano sila inform sila sa port captain that they are going to correct the the alarms of earthfall, single earthfall. So hindi bibigyan ng clearance ng port authority in the event na mayroon tayong madidetect na fault. So ito yung kalagahan na if we are having a problem or having a short circuit or short fault or fault, single fault, na-detect doon sa system doon sa barko. So this alarm will give us the signal that there is a problem, especially for the three-phase system. So this is the indicating lamp. Makikita natin dito, pag yung ilaw ay madilim, yung dim yung light, it means that there is a fault between that line. But if the line are glossy or maliwanag siya, like this line 2 and line 3, this indicates that there is no earth fault in this line. So makikita doon, ito pinipindot ng authority. Pag pinipindot ito, hindi balanse yung ilaw. May isang ilaw na may dalawang ilaw na maliwanag at isang ilaw yung madilim. So magdududa na sila na mayroong air fault. Kasi minsan kasi sa barko may mga ninja moves rin. In order to avoid any penalties, kami doon sa mga electrotechnical officer, we will have to install some resistors in order to avoid na bababa yung insulation. So ang mangyayari, pag pinipindot ito, malalaman talaga nila may problema. Pwera lang sa inspector na alam nila yung sistema for this earth fault indicator. Yeah. Now, we have already completed the power source, the wires and cables, the OCPDs, the essential loads and non-essential loads. We have been discussed. The ships are now ready to sail now. So with this, I think we are already finished my presentation, and that would be all for the watercraft power system design. Thank you very much.
Okay, thank you, Sir Kanitan, for your wonderful sharing of this shipboard technology, especially for the electrical engineers. By the way, if you are working on the ship and then you are an electrical engineer, you are still EE and you wish to become PE, just advance information that you should have at least one key on the so just like Engineer Kanitan. So that's the biggest load he have in that ship is on the thrusters. So that is why he is soon to be a professional electrical engineer. So there are questions here, sir. Sir, what should the type of wire used by the ground wire or grounding system on a water vessels? Can we use bare wire? That's from Israel Kaluzay. Sir Mar? Sir Mar? Do you copy, sir? Sir Mar? Sir- please wait because there are another technical glitch here in our system. So, Engineer Mar will answer that question. Isel Kaluzay. If I may read, Sir Mar, what should be the type of wire used in the ground wire or grounding system on a water vessels? Can we use bare wire and uninsulated wires or insulated copper types? Your thoughts?
Good question, Sir Bob.
And this is from Hazel, sir.
Actually, we have these issues on using these ordinary wires and the marine wires application. For the marine wires, we have this a different type, uh, a fully protected wires that are being installed on board the ship. No, we have this in my presentation. If you remember, the wires are being used are these. Wait for a while. Are these ethylene, propylene, rubber insulated polyvinyl chloride sheet steel wire bread. So makapal yan, i-compare natin yan sa normal wires na ginagamit natin household. There are also a protective sheets
Sir Mar? Okay. So, may I call in Engineer Eugene Araco to award the certificate to our speaker for this morning. Engineer Araco?
Hello, good morning. Thank you, Engineer Marcelo Canitan Jr., for sharing this presentation. It can be useful to our electrical practitioner, especially when they are making new designs for watercrafts, electrical system for the safety of the ship and on the ship, and also safety of the operating personnel. Institute of Integrated Electrical Engineers Cebu chapter would like to award this plaque of appreciation given to Engineer Marcelo L. Canitan Jr., REE, as technical resource speaker on the topic Watercraft Power System Design in the 21st Eastern Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Skyho ENB, SMC side, South Road Properties, Cebu City. Given this 28th day of July 2022, signed by Engineer Ronmar B. Gonzalez, PE, our VP Technical Affairs, and also signed by our technical consultant and advisor, Engineer Erwin J. Salvador, Master of Science in Electrical Engineering, and also PE, Engineer Magdaleno M. Baclayo Jr., PE, President of IIEE Cebu Chapter, and lastly, Engineer Brian A. Pasilan, PE, Regional Governor, Region 7, Eastern and Central Visayas. Thank you. Madungog lang, Sir Mars.
Hello? Sige, sir. Sige, sir. Okay na, sir. Okay na, sir. Thank you.
Pero na, Sir. Kuhan sa tibugan ng mouse na po.
Ano, sir? Ano,
Siko ka na na. Si Sir Bijili.
Hindi po nga po. Hello?
Lunch break na.
By the way, thank you. Oh, another technical glitch. Sige, sir. Salamat, sir. Okay. Again, our apology because of these technical issues here. Now, we are going to give you, by the way, there are a lot of inquiries about the copy of the respective presenter this morning. So, as per our office staff, we said that when you are going to claim your certificate, then they'll have also to give you the link of the presentation of the respective speakers. Okay? So, that's it. Now, we will have a lunch break. We'll be back at exactly 1 p.m. Please take your lunch, sit back, and relax. Thank you very much.
Luzon, Visayas, Mindanao, ay kamakaret nakakawaw. Yeah.
Malawag pa'y itiranyag kiti aldaw. Sumikat ka ito'y lubong na baw. Pilipibyo, kung orgulyo grita na itero mundo.
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, Dito, Ilocano, Dito, Bisaya, Dito, galing, Dito, Chavacano, Dito, Bicolano, Dito, Tapawenyo, Dito, galing, Dito.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118
Okay, Alec? Hi, good afternoon. What a wonderful day. So we will start at exactly 1 p.m. And our speaker for this afternoon, I will be introduced him later. Okay, so this is to inform that this internet we are using right now is powered by Dito. So sponsor na to ang Dito. And then through the effort of Catalino Monin, Engineer Catalino Monin. So he was the one who bridged IIEE and D2 communications. So we have a fast internet here, and of course, there is continuous upstreaming of our activity. So, by the way, we have a line-up of topics here for this afternoon. We have the short circuit calculation, low voltage system, and solar PV, compliance with safety installations, and of course, lastly, for this afternoon, electrical system designed for health care facilities. Okay, this is very, very nice because this is a very special design because it consists of health issues, especially for the hospitals, clinics, and so on. So hopefully, try to be with us all the time because every topic here we discussed with our speaker, also your renewal of our license. Okay, CPBs. Okay, that's very, very important for us. So again, the most important part of the program, we will have. By the way, this morning there is a bowling billiard third level SMC side, and also our chess tournament uh, venue Cafe Point near Bayfront Hotel, North Reclamation Area, Cebu City. And of course, there is an exhibition game golf. Alta There's Dodge Energy Philippines, United Electrical Specialist, HBL Engineering, FB Electrical Services and Supply, Fuji Haya Electric, ADLT, Power Builders, MARR Engineering Services, Multahi Engineering Services, Power System Incorporated, CK3 Engineering Services, and of course, MR Electrical Services, headed by Sir June Paldonado, our consultant, at the same time speaker this morning. And there is also a basketball sports feast, Leyte and Samar basketball venue, Lorelco Compound, Tolosa Leyte. Skills Olympics hosted by West Cebu chapter. It will be 8 a.m. this morning, has been started and until 5. Skills Olympics hosted by West Cebu chapter. Lineman Skills Olympic. Venue Cebu South Road Properties. SRP. Cebu City. Then also we have the RMA Forum hosted by Mactan chapter. Venue CEER's or Sears Review Center in Tisa, or it is in Labangon or Tisa. And of course, there is a 3M splicing and termination training at Sears Review Center. It will be done 1 p.m. to 5 p.m. So those are the activities we have today. So please be with us. And our first speaker. For tomorrow, we will have the opening of exhibits. 8 a.m. to 8:15, opening of exhibits. All national and regional officers will be here tomorrow. Then we have a face-to-face protocol, audio-video. Opening ceremony, plenary, all officers, national and regional processional march, face-to-face. Entrance of colors, doxology and prayer, audio-video. Philippine National Anthem, audio-video. IIEE hymn, audio-video. And of course, IIE Cebu chapter, the famous IIEE Cebu chapter hymn. This has been composed by Engineer June Baklay and arranged by our new governor. He is Engineer Brian Paselan. So this is very unique. So I think this is the chapter that had an IIE hymn. So listen to the IIE hymn. It is very touching. Then there will be a continuation at the IIEE mission and vision to be rendered by engineer. The formal opening, Engineer Brian Basilan, PE, IIE Eastern and Central Visayas Regional Governor. Junior President of IIE Cebu Chapter. Acknowledgement of delegates, guests, and dignitaries by our Secretary of IIE Cebu, Engineer Christopher M. De Leon. Special message by our City Councilor, a PBE star, Honorable Donald Hontiveros, the incumbent Cebu City Councilor and a former Vice Mayor. So for those who are the fans of this PBA player, Honorable Donald Hontiveros or Dondon Hontiveros, you may take a photo op after his speech. Then the introduction of this speaker by Lowell Ratilia, our VP Internal. Message of the guest speaker. Our guest speaker is Engineer Luciano P. Padua III, National President. Then we will have the awarding of certificate and a plaque of appreciation by Engineer Magdaleno Baclay, President, and Engineer Brian Pasilan, Eastern and Central Visayas Regional Governor. Of course, we will have the introduction of the keynote speaker. It will be done by a PEE, PME, Master of Science in Electrical Engineering. Then we have the address of keynote speaker, opening by Honorable Francis V. Mapili. Kinira ba si Francis? Di gini patawag og honorable. So, but in writing, we should address him as honorable. Okay? So, it will be our opening keynote speaker. It will be Honorable Francis V. Mapili, PEE, ACPI, ASEAN Engineer, FIIEE, Chairman of the Board of Electrical Engineering, Professional Regulation Commission. Awarding of plaque of appreciation by Magdaleno Baclay, Junior and President of IIEE Cebu Chapter. And of course, it will be in tandem with Engineer Brian Pasilan, IIE Eastern and Central Visayas Regional Governor. Then, formal opening of technical session by our VP Technical. That is the program for tomorrow's event. Now, our speaker Okay, so I'll have to introduce to you guys the speaker for this afternoon. Okay, so again, a friendly reminder. Anybody can pose a
If you have
question in
a
the
box,
Q&A
please. And then
box,
if you want to
and
have,
then
or if you want or you don't like, if you
or
are
you
going to
don't
claim your
want to, if
certificate,
you are going to claim your certificate, you will also be furnished by the link of each respective the speaker. So meaning to say that do not just ask for any more for the copy of the presentation of the respective speaker, okay? Because you will be furnished. So please. Now, if you have some questions, post it in our Q&A box, okay? It will be answered either by the board member here in our office who are all professional electrical engineers, and of course it will be also answered by the speaker. So if you ask question, meaning to say that you are following the presentation. So those who are not, okay, by the way, ato na beginning sakit sahay. So when we are attending a Zoom conference, we just log in and then ato dahil i-mute ang video o ang sound, microphone. Then we go. After, you go back. So don't do it because you will miss the opportunity of knowing more about electrical engineering. Okay? So that's the deal. So I hope and pray that each one of us will religiously attend this webinar. So of course tomorrow, don't forget, we are going to, there will be an opening of our IIEE regional conference. Okay, so if you have time, you can drop by at SM Seaside at the third floor. So there are exhibits there, so you will know the latest innovative devices for your projects. So by the way, uh, this is only an advanced information. We is not here in the Philippines yet. Have you ever heard the carbon nanotube? Carbon nanotube. It has been founded by a Japanese. By the way, the carbon nanotube is a very strong material, and it even used as the as bulletproof, meaning to say it's very strong. So carbon nanotube is also a conductor with a resistance of very low resistance. No? Meaning to say that if you and the tensile strength is very strong because it is made of carbon nanotube. So maybe lang this is only an advanced information. This is not a chismis. This is not a Marites news. But personally, I've met the supplier of this. So he is right now in the United States, and he's planning to be back, bringing the sample of the carbon nanotube. You know, carbon nanotube, you can even replace the fiber optic cables. So fiber optics very difficult to splice. No? You need a special tool to splice, but this one is very easy to splice because it needs only a special glue. So meaning this carbon nanotube, if this will be mass produced, Philips ang Philips manufacturer na to sa wires, murag it will compete. The price may be higher than the copper wires. So it may be soon, it may be soon marketed here in Cebu prior to Manila. Of course, this should pass the Philippine standard. So that is only the say advanced information. Okay, so we are going that later on. So when the marketer, or let's say when the owner or the representative of that carbon nanotube, he promised he'll be back maybe end of the quarter here in Cebu, and he's planning to have a distributor here in the Philippines and centered in Cebu. Okay, that's all about. So meaning to say, we revolutionized the transmission, the it is just like a vein, no? In our body there are veins around here. Carbon nanotube, because of its property that is very very low, so it can be used as transmission lines, or it can be used for motors. So the meter or the ohmmeter or whatever meters you have, that wire in the meter, because there is a meter there, there is a magnet and a wound copper around the meter, and then there is the analog, no, the analog that moves like that, or that is the old way. So the conductor, the superconductor, has a very very low resistance, meaning to say whatever the meter reads there, it is only the resistance of the meter but not the carbon nanotube. Okay, that is only an information, that is not amarites, but it is actual. Okay, so hopefully when the owners get back from the USA, he will bring the sample, and we are going to show that to our electrical engineers. So it takes about more time to do it. Okay, so at least you are the first, or we are the first here in the Philippines, focused in Cebu, to have this carbon nanotechnology or carbon nanotube that will be used for wires instead of copper. So, ladies and gentlemen, again, sorry, there are still an adjustment in our presentation here. So, please. Oh, nice. There are already some messages here. There are already messages here. And then if we cannot answer you by voice, or let's say by whatever, maybe I'll be answering your question on your chat personally. But if there are some expert present here with me, they'll be the one to answer your questions related to the topics or not related to the topics. Anything. Okay? So, kamu na lang, basta anything. Basta we can answer that, we will answer it. If not, we will just say sorry. Okay? So, my dear brothers, let's sit back and relax and try to listen to our first speaker this morning, this afternoon. So if you have some questions, yeah, the speaker is still adjusting with this presentation with the administrator here. So I just mention here some chat messages here. Prospero Salubre. My friend Prospero Salubre, maay lagi ka mo balak, Sir Bob, Cab. Sir Peru, mao ni atong mga haligi kaniadto sa IIEE. Dito bata sa TISDA nag-office. Hasta ako na-appeal ko itong una. So na pa yung habiling haligi diri, karon nibalhin diri sa bago na itong opisina. So, Sir Peru, napagyapong ka diya sa imong balay, sir. Okay, Sir Pero, thank you very much for joining with us this afternoon. And of course, this morning, I see your name there, but I wasn't able to acknowledge you. Okay?
Of course,
Of course,
RV, good
Harvey, good
afternoon.
afternoon.
Good Harvey.
Harvey,
Lunch, kailan?
lunch, kailan?
Okay, so since our
Okay,
speaker
so
is
since our
already
speaker
ready
is
for his
ready
presentation,
for his presentation,
our speaker for this afternoon
our speaker for this
is a
afternoon
graduate of
is a
Bachelor of Science
graduate
in
of
Electrical
Bachelor of
Engineering
Science in Electrical
at
Engineering
University of
at
Cebu,
University of Cebu,
Lapu-Lapu,
Lapu-Lapu,
Mandawi Campus,
Mandawi Campus,
UCLM.
UCLM.
He was
He
a
was a
former
former
instructor,
instructor,
College of
College of
Engineering
Engineering,
of University of
Cebu,
Cebu,
UCLM,
UCLM,
from
from
2008
2008
to
to
2012.
2012.
Former
Former
principal
principal engineer
of
of
National
National
Grid
Grid
Corporation,
Corporation,
2012
2012
to
to
2018.
2018.
That's
That's
6
6
years.
years.
Most
Most
outstanding
outstanding
alumni,
alumni,
2015.
2015.
My God. And
And
this
this
next
next
credential,
credential,
he
he
is
is
very,
very,
very
very
dili siya dili siya mogibaw sa giingon sa pagkuha niya nga kuan kini tawag natin doctorate. He is
he
a
is a
PhD
PhD
doctor
doctor
in
in
technology
technology
management.
management.
Ni mo siya tanong di pagtaw
Oh,
about
it's in
doktor. Nay
like
kuman
one
pila pa yung doctorate pagtaw ka doktor. Pero kini nga doktor di ko pagtaw doktor. Mauna he is
He is
also
also
an
an
awardee
awardee.
of 10
Then
outstanding
outstanding civil
architects
architects
and
and
engineers.
engineers.
2021,
2021,
he
he
is
is
the
the
only
only
one
one
of
of
IITs who
IITs who
got this
got this
award.
award.
President
President
of
of
Lovisio
Visayas
Construction
Construction
and
and
Power
Power
Solution.
Solution.
He is
He is
also a
also a
contractor,
contractor,
electrical contractor. And of
of
course,
course,
he
he
was a
was a
former
former
president
president
of
of
IIT
IIT
Cebu
Cebu
chapter.
chapter.
Ladies and
Ladies and
gentlemen,
gentlemen,
would you
would you
please
please
welcome
welcome
our
our
first
first speaker for this afternoon,
engineer,
Engineer
General
General
P.
P.
Novicio.
Novicio.
Thank you very much, Sir Bob. No? Now, Marcel, not to Sir Bob. So, once again, no, to all our participants online, thank you very much for your time spending with us. This is our day 2 of our IIA Eastern and Central Visayas Regional Conference. So tomorrow we'll see each other at SMC site, Sky Hall, in the morning, no? Around I think 8:30. Okay, so without further ado, let's start our discussion this afternoon. My topic is short circuit calculation in low voltage system. Basically, this is more on the ANSI or the American National Standard. No, I think other speaker, Engineer Russell Bragoso, also present more on the IEC standard. Okay, so please be with me the rest of the 1 hour, I think. 1 hour? 1 hour. Okay, so I try to make presentations that will, what do you call this one? Make the one of the challenging topics, electrical engineering, which is short circuit, to make it simple. No? Our introductions. Basically, when we do power system, it should be planned and studied, no? And after that, it will be construct, commission, operate, and of course, there is the maintenance as well. And having all those load equipment or load characteristic, that would be a good advantage so that you'll be able, no, to foresee the future demand or future maintenance that will be to be applied, no, in the system. And despite of all of these things, all of this data, and despite of the technology that we have right now, the power systems that we have is not exempted or is not free from faults or interruptions, such as short circuits, or it might be an open circuit. No? So, because of this, and because of these faults that will occur in our system, basically we need to have protection in our power system in order that it will be safe to properties and personnel who are maintaining the facility. So, how to solve short circuit currents? Actually, this can be done manual or hand computation for radial and small system. But I suggest if you're doing a network system, you use some computer programs that could help you to fast track your works or design. So application of short circuit currents. So where we go or where we can apply the short circuit currents. Why is it the OPO or the LGU required that all of the electrical plants that will be submitted to the OPO must have a short circuit analysis or short circuit calculations. So basically, the short circuit is used for interrupting ratings of overcurrent protection device or OCPDs. Can be used also for momentary withstand. Can use also for bus bar, bracings and cables can be used also. And of course for the protection relay, arc plus SADIs. So there are some of the requirements or there are some of the application wherein the short circuit current of our system is useful. So what are the causes of fault? Again, despite of all of the advanced technology that we have, despite of all the careful planning and all of those standards that we apply, both local and international, and yet our system is not free from fault. So the causes of fault, it can be internal factors or external factors. It will depend on the type of facilities that you have. If you are more on the transmission lines, also if they are, the fault also can be done by external. It can be animal intrusion, can be vegetation. It can also be earth construction works. No, we have example of this what you call this one, the underground cable. Sa backhoe. Now, for low voltage system or even medium or high voltage system, there are still the number one problem that we have is the insulation. Basically, insulation over time it will deteriorate, and these are due to surges, lightning surges, and even switching and among others. And once the insulation will collapse, then you have this short circuit or abnormalities that will occur in our system. So what are the types of fault? Faults are classified as unbalanced or unsymmetrical. There is also balanced or symmetrical. Okay? So when you say unbalanced, these are kinds of or types of faults that are called single line to ground, line to line, and double line to ground. And the most common is the line to ground fault. And the balanced fault, which is symmetrical, this is what they call as three-phase fault. So usually this is the largest fault currents that will occur in your system. So if you have here the diagram, no? So the different types of faults, and the largest is the three-phase, and most common is the single line to ground fault. So what are the fundamental considerations if we undergo fault calculations? So the proper selection of the protective devices and their selective trip settings is based on short circuit calculations. So that is why we really need to have a short circuit analysis or calculation in every electrical power system, because the basis or the reference for the trip settings and the interrupting rating of our protective devices are based on short circuit currents. So as all we know, short circuit protective device is any device that will inserted in a circuit, no, that will protect against damage from overload or short circuit of our equipment. So the most common are the breakers and fuses. So basically, they will automatically trip or interrupt the excessive current in the circuits. So, inadequate short circuit protection, may to say undersize yung ano natin, yung rating ng circuit breaker, this will end up to disastrous failures. No? It can be a cause of fires. Alright? However, or conversely, if oversized naman yung rating, it's a waste of unnecessary extra cost. Because as all we know, if you try to go to the market, the same ampere rating but but different interrupting capacity, no? The higher the interrupting capacity of the breaker, the more expensive it is. So, which is which? Kung undersized ka, it might cause fire. If oversized, extra cost. So at this point, here comes the engineers will coming in, because the engineers will evaluate, no, will do the short circuit calculations, and he can based on the short circuit calculations, he can make a sound decision up to what is the rating or the interrupting rating of our circuit breakers in each of the points of the power system. So really, it's not advisable that you will say, we'll use the higher rating because it is more expensive. And the more na hindi po pwede na kapag under rating, because it can cause fire or injuries. So what are the sources of short circuit currents? No, these are the sources. No? These are the electrical equipments that are found in our facility or in our system. It will depend on how big is your system is or how complex is your system, but definitely these are the four major equipment that are sources of short circuit currents. Number one is the utility, and we are not all exempted from this because all of us or most of us consumers, we are tapped directly to the utility. So the utility is usually supplied by a step-down transformers, no? And next one is the generator. So the generator, usually, if they are supplying power to the grid, most of the time, malayo po sila sa consumers because meron pa tayong transmission line at saka distribution. Maliban na lang kung meron kayo sariling generator on your facility. So, ano ba ang characteristic ni generator? So, si generator, when a short circuit occurs, the generator continues to be driven by its prime mover and to produce voltage. So, because the generator is, even if there is short circuit, but the prime mover will continue to turn and it will still supply voltage. That is why it will still contribute with the short circuit currents. Si synchronous motor, okay, so it will behave like a synchronous generator, but the one who drives its prime mover is due to inertia. Because by the time na nag-short circuit, syempre, nag-take off or gano'n, but nag-contribute pa rin ng voltage. Nag-contribute pa rin din siya ng short circuit currents na sa system. The last one is the AC motor or induction motor. So, sa induction motor, by the time nagkaroon ng short circuit, immediately, collapse na din yung contribution niya. Because the induction motor does not have this field wind or field source. So it is due to induction na lang. So by the time nawala yung supply in the primary side, immediately yung ano din niya sa secondary mawala din. It's like a transformer principle. So if we add on all of this equipment, we have this total waveform. All right. So this waveform wala akong screen. Ano sa tayo? Wala. For a while. Makita ka? Okay, see? Palay na. I think the projector, no? No problema. Okay, sorry, no? For we have some technical errors here. Okay, let's proceed. So again, no? If we combine all of this waveform, ito po yung total niya. Okay? So this will the short circuit current it looks. We'll discuss this one for more in the next slides. So what are the assumptions and steps in the calculation of faults? So in order to come up an accurate, what we call this one, in order to come up a more simplified steps in the calculations of fault currents, these are the considerations or assumptions. The load currents are not considered. The voltage of the power company and generator sources are assumed to be equal to their nominal values. Motors are running with the rated voltage. The transformer present impedance values used be actual. And the switchboards, switchgear, panels, motor, bus bars, the impedances will be neglected. So as the impedance of the bus are usually of small values, excluding them from the calculation will give a fault current a little bit higher value. So in this case, since we neglect some of the impedances of the bus bars and the controllers, so we are in the same side, no, in our calculation of the short circuit currents. And the fault is bolted, meaning to say it has zero impedance. And the transformer exciting current is also neglected. Thus, the interrupting rating of the protective devices will be a little bit higher. So in these assumptions that we have, we can assure that the short circuit the short circuit current or the calculated short circuit current is a little bit higher with the actual short circuit current that will occur in the system. So in this case, we can guarantee that by the time we size up our MCCB or our overcurrent protection devices, really can withstand with the short circuit current that will occur in the system. Okay? So what are the steps in solving fault calculations? So over time, we're able to formulate or establish the 7 steps in short circuit calculation in a 3-phase system. Okay, symmetrical fault. Out of the 7 steps, if you follow this one, we can guarantee that we will not get lost in the process along the way. So, mean to say, if we follow these steps, basically, you're able to finish the short circuit calculation analysis. Right? So the number one, okay, the number one or the first steps is prepare the single line diagram or SLD. So basically, the SLD is very important, no, in our electrical system, because out of it gives us an overview how complex or how big is our system and what are those electrical equipment being connected. So here we have an example of single line diagram, a very basic. Step number 2, we're going to select a convenient base MVA or KVA. So since our methods of solving short circuit calculation is using the per unit, so we need this base MVA or KVA. So there are some recommendations for numbers. Now these are arbitrary numbers, no, or assumption. It will depend on you on what number you're going to use. But see to it, it is constant all throughout the way. So you can use MVA or KVA that is available in the system, or you can use a larger and a good number that is easy to remember. Like for example, number 10, 100, 1000, and others. So it will depend on you. Now, the next step is number 3, give the proper impedance values. So what are these impedance? Or what are the impedance values needed? So these are the electrical system equipment materials, no? Ayan mga impedances. And all we know that these sequence networks have positive, we have negative and zero sequence impedance. But for our three-phase calculation, we are only focused or interested for the positive sequence impedance, in which its characteristic or its behavior is the same as the original phasor. While the negative sequence, same as original phasor but without a source. And this zero is equal in magnitude and in phase with each other. So basically, the equipment are the generators. We have also the utility line. We can have also the transformer, the motors, and of course the medium of connection that we are going to interconnect these various equipments at different voltage level. We are going to use the wires and cables. So how to get the impedance of the generator? So the generator, we have here the positive Z. One is for positive, but some authors, they really write the number or the symbol positive. But for some, they are used number 1. It stands or represent for positive sequence, the G for generator per unit, and then new. And this one is same, but it's the rated MVA or at the rated sa M1 generator. So this is the formula. Just review for this. And the next is the utility. Now the utility, like this one, the tapping point, it has a maximum short circuit level. Basically, you can get this one through the utility provider in your respective area or project site. It can be BECO, MECO, SEBECO, or MERALCO. If you wish to, you can send our letter request from their, I think, power system engineer. They will provide us the short circuit level at that particular area from time to time. It must be updated because when there is a new power plant or a big industrial establishment that will coming in that area, the fault level also will change. So the best practice is it must be updated request prior you will do your short circuit calculations. So I have here an example. This is located near the old or the first bridge, Mactan Mandawi Bridge in that area. So you have there the examples. The primary line voltage is 23 kV and the amperes is in kilo amps. And you have there the XR ratio, and that is why I have the 78.43 MVA. So this is the maximum short circuit level at that area. Okay. So next is what is the reactance value of the utility at the topping line? Okay, the answer is 1.0 per unit in its rated value. So there is what you call this one? There is a derivation for this, but in this presentation we will skip that one. It's not that important. Okay, so next for utility line is the transformer. So the transformer and the generator most likely they have the same formula, and you can get their impedance through their nameplate rating or manual. But oftentimes na makikita po sa nameplate rating ng transformer. Okay? The next is the motors. It can be induction or synchronous. It is the same. The same formula, only the subscript will change. Now, for low voltage motors, you can refer to nameplate rating or other international standards as well. But for this presentation, I will use the reference from IEEE standard, the recommended practice for electric power distribution for industrial plants. For motors that are rated below 600 volts, all right, the positive sequence is 0.25 per unit. Negative sequence po is 0.15. So the negative sequence can be used only if we will do unbalanced fault analysis. But for this presentation, since we are only interested for the three-phase, for the interrupting rating of short circuit, interrupting rating for the MCCB, so we'll use only the positive sequence. Next is for medium connections, the wires and cables. So where we can get the impedance. This is the formula in converting the per unit value of our impedance for wires and cables. And basically, we are relying in our PEC, the Philippine Electrical Code. But in the absence for that, you can use also manufacturer's catalog or table. So in our Philippine Electrical Code, 2017 edition in table 10.1.1.9, you can find there the alternating current resistance and reactance for 600 volts cables, three-phase, then single conductors in conduit. So here, it is already tabulated. No? So it is already tabulated. This is a generic value. But if you want a more specific one, you can consult the manufacturers. More or less, there is a very slight difference when it comes to their reactances and resistances of the wires or cables. But you just take note that this value here, the unit is ohms to neutral per 305 meter. Okay? So be careful because oftentimes dito po tayo nagkamali pagkuha ng reactance and resistance of our cable. Okay, so more or less these are the impedances that we need to get in order for us to do, or in order for us to solve, to perform a short circuit calculations. This is the step number 3. Now, what is the step number 4? Step number 4 is make an impedance diagram. So what is this impedance diagram? The impedance diagram is coming from your single line diagram actually. Whatever is the loop of your single line diagram, the impedance diagram basically is, they look similar, not totally the same, but more or less they are like this, no? So we have there the transformer, we have the reactance, which is the X utility, and transformer. I use the subscript X1, which is what you call this, which is positive sequence. Okay, so as you can see, this is how the impedance diagram look. No, this is how it look out from our single line diagram. Okay. So as you have noticed here, if there is fault at bus 1, for example, at 460 volts, as you can see, this is the flow of the currents, the red ones. So from the utility, okay, it will goes to the bus point, and also some of the loads downstream, like motors, will also contribute short circuit currents going to the short circuit area or point of the system. So once this occurs, we can expect that there is an excessive amount of current. And by the time this will occur, we must see to it that this overcurrent protection that we have, which is the circuit breaker, will able to withstand the thermal and mechanical forces that are present in that time during the short circuit. So if our circuit breaker is properly sized up, then it will able to interrupt the fault current safely. And once it was cleared, then we can back to normal operations. So the question is where to get these impedances? Out from your single line diagram, okay, let's do it slowly. Out from your single line diagram, you will draw or you will make an impedance diagram. And where to get these impedances and what are these values? Okay, so if I may recall, these are the reference or the things that you need to look. No? For utility, you coordinate with the utility. And for transformer, you review the nameplate rating or the catalog. For low voltage cable or conductors, you may refer to PAC. And for transformer, again, nameplate. And for LV, PAC. And for motor is table or catalog or other standard references. So I think all of these are clear right now. And we proceed to the next steps. So step number 5. Combine the impedances or using the Thevenin theorem. So let us, I think all electrical engineers, or even not engineers, just practitioners are quite familiar with Thevenin theorem. No? So the calculation for the three-phase fault can be done using Thevenin's theorem. So this reference is electrical transmission and distributions, courtesy of the late engineer Oscar Pasilan. So this is a well-known theorem which states that with respect to any single external circuit connected to any given pair of terminals of a network can be replaced by a single branch having an impedance Z equal to the impedance measured at the terminals looking into the networks and containing a single EMF source. So this is out of the three-phase. Now, do you have a single line diagram? And you will simplify all of those impedances that are presence in your impedance diagram, and you will end up, no, at a Thevenin equivalent circuit. Okay? So here, we have our single line diagram, and this is our impedance diagram. So the task that we have here is we need to find the rated impedance of its electrical parameters. Rated impedance, meaning at their own rating, no? Sa kanya o in each equipment. So here, so this is our impedance diagram. So the first element that we are going to check is the reactance of the utility line. Okay, I hope it is clear now. And again, where this 1.0 came from, as we discussed a while ago, the reactance of the utility line is 1.0 on its rated value. Okay, so the next that we have is the transformer. Okay, reactance. Where is reactance coming from? Again, it is coming from the nameplate of the transformer, which is here 5%. No, medyo maliit lang siguro sa screen, but this is a 5% IZ. So that is why we have here 0.05 per unit. The next impedance are resistance and reactance. The 0.029 and 0.028, where these numbers came from? Okay, take note that this cable has a length of 30 meters. So this is how to calculate. No, as I discussed a while ago, we will use the Philippine Electrical Code Table 10.1.1.9. Alright? So from this, these are the reactances that we are going to use. Our cables is 250 mm squared. Okay? So look at this. This is 0.029, 0.048. So as where we can find 0.029, this one, this is the resistance of the cable using steel conduit. Alright? But for reactance, we have here a steel conduit, we have 0.048. Okay, you just use the table, no, for getting the reactance and resistance. So why we use the rigid conduit or the steel conduit? Because what you call this one, our raceway, no? The cable is installed at REC or rigid steel conduit. That is why we use this value. It's 0.029 and 0.048 because it's steel. Okay, it's steel. Then let's do the math. Okay, so we will convert this one because this value is not in ohms. As you can see, the unit is in terms of ohms per 305 meters. So we multiply, okay, ohms per over 305 per meter, and this 30 meters coming from the estimated length of the cable. So basically, it is a big factor yung what you call this one, the length of the cable, no, from source to load or from end to end. So hindi pwede na we will not consider the length of the cable because the longer it is, the higher is the impedance. Okay? So here we multiply by 30 over 8. Where is 8 coming from? This 8 is 8 conductors per phase. So bali, line 1 or phase 1, phase 2, phase 3, it has composed of 8 conductors per phase. So we divide. In 4 conductors, then you divide it by 4. And you do the math, you do the calculation, and we have this resistance and reactance. The unit now is in ohms, not now in ohm per 305 meter. All right? Now, in our single line diagram, if we try to look at back, there is a short conductor there, about 4 meters, the primary line of the dry type transformer. So in this case, we will neglect its impedance because it's very short. The next element is the dry type transformer. Again, it's the same as number 1. It is a 3% IZ, no? So that is why we have this reactance. So I do hope that it is clear now, no? I hope that all can follow how to get all these reactances. And the next is cable. And this cable is the same as, this is sub feeder and it's the same as the main feeder. Alright, so it is installed now in a PVC conduit. So if we try to look at our table, iba yung PVC conduit na tulong or yung value niya at iba din yung steel conduit. So when you do short circuit calculation, be mindful of these values because they are significant values that really affect in our calculations. Okay, we use 0.039 and we use 0.27 because it's PVC, right? It's PVC. Okay, let's do the math, and you have it in ohms. And the last but not the least, the motor. And where we get this 0.25? As what we have discussed a while ago. Okay? 0.25 per unit. Okay, so after that, solving the Thevenin equivalence circuit. The next steps is we need to express the rated impedance values into per unit values. The question is, what is that per unit and why it is necessary? Alright, so as you can see in our single line diagram or in our impedance diagram, they don't have the same unit. The others are in per unit, the others are in ohms. It's just like money, no? It is dollar, peso, Japanese yen. So you cannot add up all together. So in order to have a common value or a common measurement, a common system of measurement, we need to express this one into per unit, no? As what we have discussed a while ago in the conversion of the impedances from new or from rated to new impedance. Okay? So in this example or in this presentation, we are going to use an MVA base value of 100 MVA. Okay? If we recall the formula, no, it is the rated times the new base, the 100, over the rated base. So the 78.43 is coming from the utility because this is reactance from the utility. And G1.0 is the reactance of the utility on its rated value. We do the math and we have this value, 1.27. For transformer, the same formula. The new base is 100 and the rated of our transformer is 2000 kVA or 2 MVA. And it has a per unit value of 2.5. Same with the feeder and the resistance of the feeder and the reactance of the feeder. You do the math, and we discussed also this formula already, and you have this value. And as you can see, all of their value now is in per unit with the same base value. Okay? So the next are the transformer number 2, same process, no? And same as well as the cable. And also with the motor. The motor is 100 horsepower. Okay, so here we're done now with the what? The conversion of impedances into per unit values. So in this case, since they are now measured into common unit, then we can now simplify, no? Or we can now combine, no? The reactances and the resistances in our impedance diagram. So this is the rated impedance values and this is the per unit values. Alright? So here we are going to find the steps. In step number 5, we need to find the Thevenin equivalent circuit at the point of fault, or in this example, at fault number 1. So meaning to say, we need to find the equivalent impedance looking at this point, no? At fault number 1. So here we go. Let us try to recall our circuit 1 or physics, no? Resistance or reactances or impedance in series, we simply get the sum, no? If it is in parallel, so it is the product over the sum. Alright? So here, in this example, okay, we can combine here. But take note, I believe all of us are aware from this that the imaginary and the real part cannot be added. No? They are different numbers. So we can only simplify the real numbers and the imaginary. So if we do the math, we have this one for Z1 and same as well for Z2. Okay? So out from this, I can redraw this circuit. Will be like this. No? Lumit na yung mga components. It is now resistance and reactance for Z1 and Z2. And further, I can simplify this one. Now we can redraw like this one. Okay? And using Millman's theorem, I can further simplify the diagram or the circuit like this. And it's quite easy now to simplify this kind of circuit. We do it is parallel, right? It is the product over the sum. Okay, so if we do the math, you will give this, or we will have these numbers, no? Just double check, no? Because I'm only calculating this one last night. Maybe I put it the wrong value, and I'll be happy if somebody will call my attention if there is a wrong number here. Okay, so we're done with step number 5, I believe, no? We are able now to get the Thevenin equivalent circuit. Now, going back with the 7 steps, what is the step number 6? Step number 6 tells us that we need to determine the symmetrical current value. Okay? So, how to solve this symmetrical current value? So, we have here, no? For 3-phase fault balance, not only the positive impedance are applicable. Meaning to say, we are only interested with the positive sequence. And the formula, the per unit circuit is equals to the A, or the voltage, and over the Z, or X, it depends on the system. And this is coming from the Thevenin equivalent circuit. And the actual short circuit in 3-phase in amperes is the per unit short circuit times the base current. And these are the formula. Alright? So going back with our Thevenin equivalent circuit, the I symmetrical is equal to the per unit current times the base. And we have this the formula, the per unit is 1.0 over the impedance, which is 0.1658, plus the J na 3.932 per units. You do the calculation and you have this in in polar form. So solving the base current. If you recall, a while ago, our base MVA is 100. Alright, and the system voltage at bus 1 is 460 volt or 0.46 kV. If you do the math, you will have the base current of 125,000. Now, if we solve the symmetrical fault current, the per unit times the base, you do the math, and you have this 31,377.77 amps. This is the fault current at bus 1. Okay, I think it's very logical, no? Common figure or values. Okay, so let's do also the fault number 2 at bus 2, which is 230 volts. In the same process, now we do the impedance diagram, and since convert impedance diagram in per unit value, since we already calculated all these values a while ago, we simply put it up here and we do the simplification, no, for series or parallel in order to get or to solve the Thevenin equivalent circuit. Alright, you have here. Then this is the simplified circuits. So I can redraw like this. Further, I can redraw and simplify. And you have the ZTH, which is equals to 3.041 plus J19 3.86. And this is the Thevenin equivalent circuit at bus 2 or at fault number 2. Okay? So we have here. So in the same process, we need to solve the symmetrical currents. This is the formula. And you do the math. And the symmetrical short circuit current is 12,802 amps. This is the fault current at bus number 2 at 230 volts. Okay, so in summary, we have here fault number 1, 460 volts. Symmetrical short circuit current is 31,000. And fault number 2 is 12,000. So using the standard dual equipment short circuit current ratings, we will size up the our fault number 2 will be 14 kaik reading, and fault number 3 is 35. No, it must be greater than the calculated. Okay, so question: is this correct? Yes, at some point it's correct because we size up it, no, to the next higher, no, standard higher or commercially available standard higher. But let's examine most of our commercial circuit breakers. Okay, as you can see here, they are rated in RMS or symmetrical, no? And like this, they are rated in kiloamperes, RMS symmetrical. And same, no, this is from Eton, still symmetrical amperes. Okay, so here, 3. Sige, hindi ko man. Anyway, sige lang. So we have your step number 7. So we're going to evaluate the fault XR ratio to the standard test XR ratio for low voltage circuit breakers. Why? And or we are going to apply multiplying factors if necessary. So we have here the brief overview. So our short circuit current is composed of the following. We have AC steady state, AC decay, and a DC decay type of currents. So what are these? So these are symmetrical current at first 1/2 cycle for AC steady state, and the decay for maximum 1.5 to 4 cycles. These are the transient time, and the other one is the pick an RMS asymmetrical current component at 1/2 cycle base and its XR ratio. So how does it look? No? This is the waveform. Alright? So definitely, by the time that the short circuit occurs, no, as you can see, this is the actual current. No? And the dotted one is the symmetrical current. And we have another dotted one that will decay over time. This is the DC component. And the rate of decay is based on the XR ratio at the point of fault. I mean to say, the XR ratio is very important at this point in time because this is this will tell us now how long the DC component will decay over time. Okay? So in this graph, cycle number 2, no, the point of DC decay at 0. At over time, this is now the symmetrical value. So basically, when there is fault, it's not purely symmetrical current that is present, but there is what we call as the contribution of DC component in which it will decay over time. So mean to say, if we only size up our circuit breaker based on the symmetrical short circuit current that we have calculated, it might fail. No? It might fail to withstand the short circuit current because there are still other currents that are present, such as the DC component or the DC offset in the x-axis. Okay, as well as the big factor is the XR ratio. So what we're going to do, we need to consider this contribution, the DC current and the XR ratio. Okay, we have limited time. So this is how it looks, the sub-transient and the transient. All right. So this is how we are going to apply the multiplying factor of the XR ratio. We need to understand this one. After this, you can do it with your own. So the KA ratings of equipment is based on the controlled current injection with DC component based on the defined test XR equivalent. No? So the IEEE standard, we have these procedures, and therefore the nameplate is based on XR test value. So this is the catch. No? Therefore, if the calculated XR ratio is less than the XR test, all right, then the calculated symmetrical short circuit current can be compared directly with the circuit breaker symmetrical current rating. So mean to say, if the circuit XR ratio or if the short circuit XR ratio at the point of fault is less than of this value or less than of this XR ratio shown in the table below, then you do not need to apply any multiplier. Mean to say, if that is 10 ka8, then you can size up immediately for 10 ka8. No other multiplying factor that is required. However, if it is greater than from these values shown in this table, you must multiply it by a multiplying factor. Why? This is to ensure that the DC components the DC components are also taken into account based on our characteristic of this one, the short circuit, right? There are other currents. The symmetrical is the dotted one. This is what we solved a while ago, but during short circuit, there are still other currents that are present that we need to take into account because it might fail our breakers. So how to do? Okay, so you can see here, now, at fault number 2, at fault number 1, our symmetrical short circuit current is 12,000. We size up at 14K8, which is correct. 31,000, we size up at 35, which is correct. But let us examine their XR ratio. At fault number 2, the XR ratio is 6.57 and the other one is 24. So if you try to look at here, it's over, no? It's above. So you meaning to say, we cannot compare it directly. In other words, we need to apply a multiplying factor. Okay? So hence, the TIC rating of the FGCBs are undersized since their respective calculated XR ratio value is above the test XR ratio. So meaning to say, this is not yet enough, no, to size up our short circuit or overcurrent protection device because our XR ratio at the point of fault is above from the test value. This test value is coming from IEEE standard. Okay? So what we're going to do, just hold on, few slides left. So these are the MCCBs and ICCB multiplying factor. Now this is coming from IEEE. Next is, let us examine fault number 1 at 460 volts. The XR ratio is 24. So how we are going to use these multiplying factors? Okay, look, this is how we're going to do. Our XR ratio is 24 and you will find it in the table. You have here 24.98. We will choose this one and you must examine the symmetrical short circuit current is 31,000 and in this column there are choices. It can be less than 10,000 or it is 10,000 to 20,000 or over 20,000. And since it is 31, we will choose over 20,000. Then, what is the multiplying factor? 1.23. So meaning to say, our symmetrical or our asymmetrical short circuit current is the multiplying factor times the symmetrical. Multiplying factor is 1.23 times 31 and the answer is 38,000. Okay? And fault number 2, here the short circuit current is 12,000 and the XR ratio is 6.57. In the same way as what we do in fault number 1, alright? We have here 6.59. It is greater than 6.57. Alright? Now, look. The symmetrical short circuit current here is 12,000. We cannot use less than 10,000, but it is fall under 10,000 to 20,000. So we have here, the multiplier is 1.18. So if we do the math, it will give us 15,106. Okay. So let us compare our short circuit currents before and after application of multiplying factors with respect to their XR ratio. So, TIC rating of MCCBs before application of XR ratio, this is ratio. No? So this is 12,000 and we size up it before at 14Ka and the other one at 15 35Ka. But after, no, TIC rating of MCCBs after application of XR, at fault number 2 is 15, and we size up at 18, and fault number 1 is 38, and we size up at 42. So, meaning to say, it is worth to evaluate the XR ratio at the point of fault to ensure that all currents are taken into account in the sizing of interrupting rating of electrical equipment. So, if it did happen, for example, it's really happened, there is a fault at bus number 2, for example, and you size up your TIC rating of your breakers at 14Ka without taking consideration or taking account the DC component and the DC component currents. So it might, there is a big possibility that our MCCB or our OCPD were not able to withstand the short circuit current. Same as fault number one. No? Because we size up at 35 but the correct would be 42, and the other one we size up at 14 but the correct would be 18. Okay? So there are some from table, so IEEE can be your references as well. No? In after short circuit, if you really need to use the multiplying factor or not, no? If the XR ratio is above if this value, then you must apply a multiplying factor. Okay? So here, say, these are some references as well. This one also references. And in conclusion, in undertaking the short circuit calculations, ensure to follow the minimum 7 steps as discussed in this presentation. So, in the absence of the reference standard table or selection of the multiplying factors, after the calculation of the symmetrical fault current in step number 6, the question is there a rule of thumb? The answer is, it will depend on the designing engineer. It will adopt the rule of thumb, but nothing beats being accurate and specific on your design, especially if you are doing value engineering. So in most cases, the multiplying factor of 1.25 is safe to use. In the absence of all of those tables, you can do 1.25. But I will not suggest, but much better you will really do it using the multi-factor given by the IEEE. Okay, so that will end for me. And thank you very much for your patience. If we try to look at, there are only 7 steps. If we do the short circuit calculations in a three-phase system, especially in the low voltage. And that's all. Thank you very much and have a wonderful afternoon.
It was very kind of you, Sir General Bishop.
Thank you, Sir Bob.
So, by the way, the short circuit calculations is very important because you have to size up the wires and also the breakers. So with that, we are going to call in Mr. Ronmar Gonzalez to award the certificate.
Okay, so thank you so much, Engineer General Pinovicio, for sharing your valuable knowledge and experience. So, in behalf of Cebu, IIE Cebu chapter, I would like to award this plaque of appreciation given to General Pinovicio, PE, as our technical resource speaker on the topic of short circuit calculation and low voltage system. In the 21st Eastern and Central Visayas Regional Conference held on 27 to 30 day of July 2022 via hybrid at the Sky Hall A and B SMC site, South Road, Properties, Cebu. Given this 28th day of July 22, truly yours, Ronmar B. Gonzalez, PE, VP Technical Affairs, and Engineer Erwin G. Salvador, our Technical Consultant Advisor, and our President, Engineer Magdaleno M. Baclay, and our Regional Governor, Brian E. Basilan. Let's have a round of applause. Regional General P.
Thank you very much, Sir General.
Mr. Bob.
Yes, Dr. General Bishop. So, our next will be the video clips of our exhibitor. Virtual ads for a sponsor. A minute, 1 minute. Okay, so video presentation of our sponsor, Event Hub.
Eh, ano to? Sumunod talaga. Ani. Again, another technical glitch. So we are encountering a lot of technical glitch. So hopefully by next week,
Bachelor of Science in Electrical.
speaker for today is graduate of the Philippines, Quezon City. He was the project manager of Meralco Spectrum from 2017 to 2020. He was the project manager of UGE Philippines from 2020 to 2021. Currently, he is the project director of projects of UGE Philippines and boss of engineer Ronmar Gonzalez, our VP Technical. He will discuss the solar PV code compliance and safety installation. Ladies and gentlemen, would you kindly welcome Engineer Sidney Mangaring.
Hi, good afternoon, everyone. Can you hear me?
Yes, sir.
Hi.
Loud and clear.
Okay. Okay, Sir Bob. And thank you, Sir Bob, for the wonderful introduction. And again, it is a great honor and privilege to share or impart this significant topic to all of you. As we know that renewable energy, specifically the solar PV system, is one of the trending technology that we are developing to have a sustainable and clean energy. And also it is a part of RA 9513, known as a Renewable Energy Act of 2008. I'm sorry, I forgot to share my screen. Allow me to share my screen. Can you see my screen, Sir Bob?
Yes, sir.
Okay, thank you.
Welcome.
I think there's a technical here.
It's familiar. Sounds familiar.
Naka-present na ba ako, sir? Sir, sorry, medyo di ko kung nawawala yung
It's okay,
screen.
sir.
Ano yung nakikita nyo, sir, sa ngayon? Yung presentation ko?
Yeah. Baba, usa ka buo.
Okay, sir.
Nakita namin pero andun na sa left side ang mga presentation.
Okay, sir.
Full
Okay.
screen, sir. Maximize.
And how about that, sir, Rob? Nawawala ata.
That's it.
Okay. Bumabalik ka. Anyway, sige, sir. Okay, so the title of our topic is solar PV code compliance and safety installation, which I would like to emphasize that this presentation is just focus on a solar PV system and excluding the battery energy storage system or the BESS, just to avoid overriding the other presenter, which I think Sir Hill Losares will present the BSS by tomorrow. Okay, so ano ko lang sa full screen. Ito. Okay, so moving forward, the objective of our topic is first, we're able to understand the requirement according to our code or other relevant references and what are the proper applications. And also, we'll be aware what are the required permits and certifications to be applied, mandated by our local government units, such as DOE and ERC, and also the private agency like the distribution utilities, prior the operation of a solar PV system. And of course, the most important is we'll also learn the best practices of safety installation and accordance to our codes and equipment manufacturers recommendation. And lastly, we will also learn the required testing commissioning as per PDC 2017 and ERC number 06-2019. And if we have time later pa, kung mayroon pang time, I will share the list of codes of solar PV changes from 2014, 2017 up to 2020. Okay. Okay. Ayun, okay na siya. Sir, okay na po ba yung presentation?
Yes, sir. Kana, that is already the full screen.
Okay, good. Thank you. Okay naman. Okay, so let's start for the PB codes and standards and reference. So for the solar PV code standards references, first we have the Philippine Electrical Code version 2017. So this is referring from the NFPA 70 also, or known as National Electrical Code 2017. So actually we have already a NFPA 70 or NEC 2020 as of now, no? But ang difference lang naman nito is kung titingnan natin yung sa solar PV system is makikita natin siya sa article in PEC, article 6.9, and for the NFPA, makikita natin sa 690, article 690. So decimal lang yung pinagkaiba niya. And also we have the Philippine Distribution Code 2017. So ito this one is also part of our references, specifically our distribution utility, no, during the application of the DIS. Some of their requirement or references that the EPC or the developer of the solar PV should comply on this, on what is the PDC required. And also related din siya dun sa ERC natin na mga requirements sa mga resolution na mandated by ERC, particular na po doon sa net metering tsaka yung tinatawag natin na zero export requirement. Now we have also the Fire Code of the Philippines, or known as RE 9514 version 2019. Makikita natin dito yung sa solar nasa special structures, no, under article 10. If I'm not mistaken, 10.2.19. Doon makikita nasa division siya, division 19. So if you want to check these references, nandun po yung mga code natin and standards for the solar PV. Also, we have the relevant codes. We have also the Uniform Solar Energy Code 2012. So this one is cover solar thermal and PV system, no? So, and also we have the IEEE 1547.1, or standard conformance test procedures for equipment interconnecting distributed resources with electrical power system. So nandito yung mga pinapa-confirm ng IEEE na sinusunod ng mga manufacturers natin, lalo na sa mga inverters, modules, and energy storage system. We have also the ISAP, or International Solar Energy Provision, version 2018. So ito namang ISAP is this one is a collection of the recommendation from the various building. So ang mga makikita natin dito is more on the codes for the both solar thermal pa din, and PV, and also the safety standard. So sa US, ito yung nila kasi may mga thermal din sila doon normally. And also we have UL standard 1703 and UL 61730. So this one naman, ito yung tinatawag natin na So ito yung tinatawag natin na safety certification ng mga manufacturer natin, no, na kino-comply nila. So kung makikita natin yung mga data sheet ng mga modules, so makikita natin yung UL standard 1703 sa data sheet, and UL 61730 as well. And yes, meron siyang, kumbaga similar siya doon sa IEC 61730 second edition. So ito yung nasa photo. And of course, the UL standard 1741. So dito natin matagpuan yung mga compliance regarding the inverters and DC to DC converters na dapat makakomply ng mga manufacturers, lalo na kasi meron tayong mga requirements dun sa interconnection to grid. So this is one of the important na makikita natin sa mga inverters natin. UL 1699B, this one is specifically required for the PV solar system to have a arc fault circuit protection, no? Normally ngayon sa mga mga inverter natin, we have makikita natin sa datasheet niya, no, kung meron siyang AFCI features, but there's an exception later on. I will discuss based our pursuant to our PEC. And other relevant codes that I will suggest is, of course, the NSCP, no, for the during the design stage. So before we proceed dun sa detailed design, we need to check also the NSCP kung saan located yung area ng project. There's a zoning kasi, no, kung ilan yung wind speed or the wind pressure, kung ilang kPa or kph yung nandun. So we need to verify, and we need to share it to our manufacturer, or the vendor or the supplier, na ito yung requirement doon sa project na yun. Okay, and also the ASHRAE and the National Building Code of the Philippines, or the NBCP. Now, so moving forward, proceeding to our PEC 2017. So as I mentioned a while ago, the solar PV is under Article 6.9. So now we jump to 6.90.2, because 6.90.1 is more on the definition and the scope of the solar PV. So, and also kung titingnan natin doon, meron din doon mga different interconnection and configuration for solar PV, including the energy storage, no. But again, energy storage is located in 6.7. Okay, so first, under section 6.90.2.1, the maximum voltage defined as the DC circuit shall be the highest voltage between any two circuit conductors, or any conductor and ground PV system, DC circuits, or in one and two family dwellings shall be permitted to have a maximum voltage of 600 volts or less. Also, DC circuits on other types of buildings shall be permitted to have the maximum voltage of 1,000 volts. Were not located on any buildings, listed DC PV equipment rated at the maximum voltage of 1,500 volts or less. So what does it mean? So ito po yung mga requirement na it is clear, no, na yung 600 volts is applicable for the residential. Or maybe based on our experience, may mga 600 volts pa rin sa mga commercial, pero maliliit na project na lang yun. But just to be clear, normally yung mga inverter kasi na ginagamit sa residential is we have 5, 12 kilowatt. So bihira yung mga 20, malalaki na yung load na yun. But normally 2, 3, 5, 8 kilowatt, and 12 kilowatt, no. So for the single phase. So ibig sabihin nun, yung string mo doon, when you say string is the summation of the PV modules connected in series. So let's say pagka meron ka ng inverter in modules, meaning doon pa lang sa inverter, makikita mo na agad sa datasheet na yung mga ganong type na rating na inverter, yung binanggit ko na 5 to 12 kilowatt, ang pinaka-maximum na input voltage niya, no, or the per string or per MPPT is 600 volts. So wala ka na makikita na 1,000 volts na mga ganung 5 kilowatt. So ang 1,000 volts naman is more on sa mga commercial and industrial. So doon po natin makikita yan, no? Pagka kukuha tayo ng mga inverter, the rating is above 30 kilowatt, 32, 30, so mga 25 siguro last kay SMA, no? 25, 20. So meron yon mga 1,000 volts. And then sa 1,500 volts naman, yun yung sa mga utility scale natin or the solar power plant na. So more on the ground mount, so yung mga malalaki na inverter natin. Okay? So yun yung naka-specify sa code natin for the maximum voltage na applicable doon sa premises. So ngayon, I'll share the voltage correction factors. So what is ano po bang ano nito? Ano po bang kumbaga bakit ko pinapakita is we have the maximum system voltage formula. So if we calculate later, so ito po yung magiging ano niya, magiging formula nyo. We have the open circuit voltage. So meaning ito yung kayang i-produce ng isang PV module na at the peak, no? Let's say kung ang nakalagay doon is 450 watts, pag na-meet niya yung 450 watts, meron siyang 50.01 volts. So yun po yung VOC niya, no? Open circuit pa siya, hindi pa siya connected in series. Okay? Per module po yan. And times PV modules in series connection, times this one is 1 plus minimum temperature degrees Celsius minus 25 degrees Celsius is this is the difference temperature that we call. And also we have every datasheet in PB module, meron po nakalagay doon na module coefficient. So dito po nagkakatalo yung mga manufacturer natin. Okay? Now, let's have example no for the string size calculation based on the maximum voltage, how to get. So mamaya pa ipapakita natin, ipoprove natin na with this formula, this one, I'll try to have a pointer. With this formula, pag ginamit mo itong voltage correction factor, which is the same, no? Although this is part of the design, no? So ano lang, hapyawan lang. So given at STC, by the way, the STC is the standard test condition. And kung narinig nyo na rin po yung NOCT, which is the normal or the nominal operating cell temperature. So magkaiba po siya, no? So yung STC, this is the both test condition is reflected on the datasheet. But ang pinaka basis natin for the design is the STC. So kung mapapansin natin dito, we have a given based on the datasheet of the module or the solar panel. So let's say we have the rating of 460 volts and the open circuit voltage is 50.01 volts and the module temperature coefficient of the voltage open circuit is negative 0.272. And let's say we will use the inverter maximum PV input voltage to 1000 volts. So meaning 1000 volts, the project is commercial industrial. Now, ito muna gamitin natin 1 plus minimum temperature degrees Celsius minus 25 degrees Celsius. So ito po siya. So bakit may standard time 25 degrees Celsius? This is not the ambient temperature. So according to the NREL, no, the National Renewable Energy Laboratory, during the testing at STC condition, yung 25 degrees Celsius, yun po yung na-measure nila doon sa heat ng panel. So hindi po yung ambient temperature na nakukuha na yun. At 25 degrees Celsius, given that we have a standard irradiance value. So kung may idea po kayo ano yung radius value, the sunlight can give 1000 watts per square meter. So although doon talaga sa taas pa, no, sa ere, so nasa 1,300 yan yung binibigay ng araw, but pagdating niya sa Earth surface, 1,000 na lang siya. So at that condition, 25 degrees Celsius, na-meet niya yung 460 watts. Kaya nga sinasabi nila kahit yung different brand, pareha sila ng wattage, magkakaiba pa rin sila ng open circuit voltage kasi nagkakatulad sila dito sa temperature coefficient dahil na rin doon sa material na ginagamit. Okay? So that the 25 degrees Celsius naka-standard na po yan. Now, assuming that the ambient temperature that we'll use is 20 degrees Celsius, no? So the minimum temperature degrees Celsius. So gagamitin natin. So given the formula, so we have negative 5 degrees Celsius for the difference in temperature. And multiplying this one, the module coefficient, so we have 1.36% increase of temperature, okay, at 20 degrees Celsius. Now, we will multiply, following this formula, we will multiply the VOC, or the open circuit voltage, by increased temperature, which yung 50.01 naging 50.69 volts at 20 degrees Celsius. So yun po yun, no? So ayan, 50 point. Kung mapapansin rin po natin, yung increase of temperature, if you take a look, 1.0136, so magkalapit po siya dito. So we're using 20 degrees, no? Ambient. So kung titingnan natin yung factor, nasa 1.02 po siya. So ito na yung naging changes nung nasa site na yung module, no? In-install na natin. Now, how do we get the number of modules in series? Of course, so madali lang siya, no? Pag alam mo na yung inverter mo, so given the data sheet, meron nga doon na input per MPPT, no? The maximum voltage per string. So since nakalagay doon 1,000 volts per string ang maximum, madali mo na makuha yon kasi ang modules mo, meron ka nang given kanina na 50.01, applying the difference in temperature, naging 50.69. So makukuha mo na yung number of modules mo sa isang string in series. So meaning, pwede ka mag-series ng 19 pieces sa isang string pa lang yun, no? So ayan. So meaning, pwede ka na mag-series ng 19 pieces sa isang string. And ang VOC natin, or open circuit voltage, na new, So meron tayong 963 times 0.11. So ito na yung maging VOC natin. Kung ita-times mo yung 19 pieces to 50.01, of course, less than 963 yon. Okay, now, let's prove kung tatama ba kung gagamitin natin yung correction factor. Kunyari, hindi natin alam to. So, this one. So, the maximum system voltage, ito. Kung sanay na kayo mag-calculate, so we can do this, no? Kung meron kang 50.01, which is given na nga ito sa datasheet ng mga solar panel, times mo lang ng 19 pieces, kasi alam mo na gagamitin mo lang yung 1,000 divided by 50.01, 19 pieces pa rin ang lalabas dyan if you calculate. And since meron na nga tayong voltage correction factor na hindi tayo gagamit ng formula na to, if you take a look, 969 siya. So very near yung value nila. So meaning, if we will use this voltage correction factors na binigay ng code natin, mas mabilis, no? 969. So pasok pa rin, which we can use 19 pieces per string. Okay. Now, moving forward for Article 6.90.2. So this one is for the circuit sizing and current. So calculation of maximum circuit current. The maximum current for the specific circuit shall be calculated in accordance with 69.2.8.6. Sorry. And the photovoltaic source circuit currents, the maximum current shall be calculated by one of the following methods. First is the sum of parallel connected PV module rated short circuit currents multiplied by 1.5%. And of course, we have also the conductor ampacity. So, i-diretso ko na po no, sa before application of adjustment and correction factors, 125%, another 125% mentioned in our code of the maximum currents calculated in 6.90.2.2a, which stated above, before the application of adjustment and correction factors, meaning there is to 125%. So, example, we're using GE Solar. No? By the way, I'm not promoting the GE Solar for the sake of our presentation lang. I will use 460. So, based on our sample a while ago, for 60 watts. So, this one, 50.01. Now, hinahanap natin yung short circuit current. So, this one will be our basis for our design, 11.45. So, ito yung kayang i-produce ng module mo at peak. No? Pag na-reach niya yung 460 watts, kaya niya ibigay yung 50.01, kaya niya rin ibigay yung 11.45. So, para makuha natin yung protection and also the conductor sizing, so given the series modules per string, we have 19 pieces as calculated a while ago. And also, number of parallel string is one string. So hindi na natin pwedeng i-parallel to kasi nga yung isang string pa lang kanina na na-calculate natin nasa 969 volts na. So kung mag-a-add ka pa ng tawag dito, mag-a-add ka pa ng another string, which is kung ipaparallel mo naman siya, same voltage yun, no? But the problem is baka yung short circuit current mo since 1145 times 2 hindi na uubra doon sa inverter mo. 'Di ba? So kung 11.45 pag nagparallel ka ng dalawang string times 2 tapos yung let's say yung inverter mo is nasa 20 amps lang, so hindi na obra. So I assume that we will use one string only, no? So ayan, maximum string current ISC times number of parallel string times 1. Of course, maximum string current is 11.45 pa din. And size of conductor per MPPT string. So as I mentioned a while ago, so we have the squared of 1.25, which is we're using 1.5625. So based on the code. So now, 11.45, compliance dun sa sinasabi ng code natin, ang conductor natin is magkakaroon siya ng current based on our calculation, 17.89 amperes. And we will use two wires, positive and negative 6.0 mm squared. Kung titingnan nyo rin yung wire catalogs or brochure nung kung gagamitin mo yung 6.0, masyadong mataas yung 6.0, nasa 50 plus. So maybe 17.89 is pasok sa 4.0. But considering the string is malayo, no? So very far, and if you exceed 150 meters So consider na natin yung voltage drop so that we will use 6.0. And also, hindi natin kakalimutan yung ground, 5.5 mm squared. And it's up to you kung anong gagamitin natin. Of course, compliance pa rin to doon sa code natin later on, kung ano yung mga protection, no, for our cables. Now, for the overcurrent protection, after the solar conductors opacity, so moving forward for 2.3, the overcurrent protection. So this one is ito yung medyo confusing, no? Kailan ba tayo gagamit ng DC fuse? Kailan ba tayo hindi na pwede palang gumamit? Kasi so far in our practice, no, with due respect sa ating mga fellow practitioners, of course, okay yun kasi safe but redundancy but not economical. Pero meron kasi tayo sa code na DC fuse requirement based on IEC 63647 the 712 version 2017. So sinasabi doon na kung meron kang number of parallel strings, times mo na ng short circuit current ng module. So again, given po yan, no? Given yung ISC MOD and also the maximum current of module for the overcurrent protection rating. Now, kung yan is more than the overcurrent protection rating ng module mo, we should put the DC fuse. But kung less than yan, we don't need to put the additional DC fuse, no? In fact, we have a rapid shutdown and also the SPD built in our inverters and the DC switches. Okay, so but there's an exemption. So ito na nga po yun, an overcurrent device shall not be required for PV modules or PV source circuit or DC to DC converter source circuit conductor size in accordance with 6.90.2.2b. So where one of the following applies, there are no external sources such as parallel connected source circuits or other energy source batteries or backfeed for inverters. So far yung mga inverters natin ngayon protected na siya, no, for the backfeed, no. And the short circuit currents from all sources do not exceed ampacity. So ito na po yun. So part na siya dito sa ito kung gusto niyo malaman. We'd like to share lang, no, para siyempre kung gusto nating makamura sa design natin, also our installation. So you can check this one. Now, we have also the correction factors. So ito gumamit lang ako ng data from the manufacturing or DC cables just to to verify. So DC protective device for MPPT string, we have the maximum string current times 125. So ito na po yung nasa code natin. And we have the 22.36. So or you can use 20 ampere trip 2 pole 1000 volts per string. Okay? Kung meron kang DC fuse, by the way. Kung meron kang DC fuse, but just to check lang, no, yun pala yung makikita mo naman to kung pasok to sa datasheet na nakalagay kung ano yung protection ng inverter mo per string. So kung 25, pasok ka. But kung 20, pasok pa rin pero meron kasing time na mag-peak. So baka mag-trip yung mo, no? Mag-trip or magkaroon ng error yung inverter mo. But just to be safe, pwede ka nang mag ng ibang inverter. Now, applying our correction factors based on our temperature rating of conductor. So, ayan. So let us use the ambient temperature 36 to 40. So at 90 degrees Celsius, so 0.91 po siya. So apply lang natin, no, in-cable laying factor. So kung isang lang po yan, laying yan. So wala naman nakapatong dyan sa cable trace mo. So you can use 100%. So meaning ang 6.0 mm squared ampacity mo is nasa 50.05 na lang yung ampacity ng wires mo from 55. Okay? So moving forward for the 6.90.2.5, so we have arc fault circuit protection and direct current. So this one, pagka PV system operating at 80 voltage DC or greater between any two conductors shall be protected by listed PV arc fault circuit interrupter. So actually yung mga natin ngayon, mga inverters, no, I'm present example lang dito yung Sungrow brand, no. So again, I'm not promoting Sungrow brand, just to seek for presentation. So may makikita ka na diyan, no, na AFCI. Yung ibang distribution utility, specifically dito sa NCR Luzon, si Meralco, very strict po sila dito sa FCI. Kung walang FCI ang inverter mo, i-disapprove nila yan during application of the distribution impact study. Okay, so si Huawei meron na rin, but previously yung mga ibang model nila wala, but now meron na rin ho sila, and other inverters na rin po. Now, ano yung exemption nito? So may exemption din ang FCI kung kailan lang pwede gamitin to, or may feature ang inverter mo. So sabi dito, PV system not installed or in buildings, PV output circuits and DC to DC converter output circuits that are buried, installed in metallic raceway or installed in closed metallic cable trays are permitted without arc fault circuit. So ang pinakamaganda example dito is yung sa mga yung sa mga ground mount. So yun. Next, we have the 6.90.2.6, the trending sa the rapid shutdown or the RSD device. So may exemption din ng ano natin, no, ground mount PV system circuits that enter building which the sole purpose to house PV system equipment. So ground mount din po ang ano nito, no, mga project din sa ground mount, we don't need to put the rapid shutdown. Normally ang requirement talaga nito is sa mga rooftop. So the roof deck, so but the carport wala na rin, no, kasi naka-detach siya sa building kung nasa baba. Okay? So this one is the summary, but later on we have a detailed this one. So okay, so let's discuss the changeover code, which the PEC is based on the NEC 2014 and NEC 2017 lang naman tayo. So far we are tawag dito, same with the NEC 2017 as of now, no. So we are in a module level na. So for the NEC 2014, so the array boundary definition, dati po naka 10 feet away from the PB array. So when you say PB array, yun po yung group of modules. 'Di ba may group of modules, let's say 20, tapos may daanan ka. So isang array na po yun. Okay? Or let's say isang group, so still that is an array. Dati, 10 feet po siya or 3 meters from the PB array, dapat doon naka-install yung rapid shutdown mo. Dati yon, NEC 2014. But nagkaroon ng NEC 2017 and also meron na rin din po sa NEC 2020, no? But still the PEC is based on the NEC 2017. Meron na rin po doon na nagbago yung distance, which is 1 foot na po from the PB array. But ito yung tinatawag natin na module level. Kasi ang mga rapid shutdown po ngayon is pwede mo nang i-clip doon sa ilalim ng module mo o solar panel. So which is we are complied na kung yun ang gagamitin mo. So this one. So far wala naman na sigurong gumagamit na ngayon ng mga array level. So far karamihan nasa module level na yung mga RSD mo. We have the single input, single output, 2 input, single output. So depende po sa model na gagamitin and requirement po ng design. Okay, so aside from that, we have also the outside the array boundary. So ito po yung mga limitations na tinatawag. So ito yung sa mga control conductors, requirements for control conductors should apply to PV circuits supplied by the PV system. So yung mga control limits natin, as I've said, based on NEC 2017, nasa 1 foot na po tayo ang requirement. But yun nga, since naka-module level na tayo, compliant na talaga. Which is as per code, 305 mm nga lang eh. So from the edge, nasa ilalim ka na ng module eh. So wala natin pag-uusapan dyan. So ngayon, meron lang siyang limitation in terms of the limits or control conductors pertaining the outside the array boundary. Meaning to say, pag sinabing outside the array boundary, yun po yung string home run mo na lumabas sa array. So ano po ba yung limitation nun? So sabi sa 2014, previously, ang limited niya is 30 volts within 10 seconds. Once na i-initiate mo yung RSD or pinagana mo. So ngayon, pag pinit mo yung RSD ngayon, within 10 seconds, dapat mula sa rooftop going to inverter station or the electrical room kung saan man nakalocate yung RSD controller mo or the inverters, dapat 30 volts yung masusukat mo na voltage end to end. Again, array going down. Okay? Now, sa 2017, nag-iba na. So 30 volts within 30 seconds naman. So pagka ano mo, tawag dito, sa 2017, kasi nga kaya humaba yung oras kasi naka-module level array ka na. So based on our experience, no, pagka itines mo yung module level from doon sa string nung home run na nasa baba, tapos of course connected na yung mga panels mo in series with rapid shutdown device, nakukuha naming reading, sa totoo lang, may 0 to 10, mataas na yung mga 12 volts. So meaning hindi ka na talaga maano nun, makukuryente kung tutusin. So yun yung requirement during the testing. Makikita natin kung yun ba yung kumbaga nami-meet ba nung rapid shutdown natin device. Okay, so that is for outside array boundary and also the inside array boundary. So we have also the limitation, no? So sa ano natin, sa NEC 2014, wala siya, pero sa 2017 nagbigay siya ng provision na pag nasa loob ka ng array, I mean sa group of modules, kung nandun ka sa gitna nun, dapat ang masusukat mo is 80 volts na lang within 30 seconds. Pag pinindot mo yung pag in-initiate mo yung controller, or let's say example, one of our brand is the AP Smart, no? There's a PLC transmitter located under, or it depends kung saan mo gusto ilagay, but mas maganda kasi accessible. So doon na rin sa electrical room. Pag kayo nag-initiate, so dapat 80 volts na lang yung nasa loob ng array mo. Okay? Ayan. So again, this is the detail, no, sinabi ko kanina. Yan. So this one is the outside array. So dapat itong string na to or cables na to, kasi ito yung invert modules mo, one array. So dapat ang mga voltage na lumabas diyan nasa 30 volts na lang. Okay? So again, the requirement from this array, and the 1 foot, no, yung as per 2017 code. Also for the, ayan, sorry, hindi pa pala na click. So less than 30 volts or 30 volts maximum yung requirement for the outside array boundary. Okay? So for the inside array boundary naman, ayan. So dapat within array naka 80 volts within 30 seconds upon initiation of the RSD. Now, there's an exception, no? Stated here, number 3, the PBRS with no exposed wiring methods, no exposed conductive parts, and installed more than 2,500 mm from exposed ground and conductive. So meaning to say, kung gusto mo na hindi maglagay ng rapid shutdown, no, kung walang mga rapid shutdown yung per module mo, so pwede ka yung mga wires mo dyan or string, DC string, make sure na naka-raceway po siya. So far wala pa naman kaming ginawang ganun just to eliminate the RSD, but ang point kasi din doon is, 'di ba, kung sakaling mag-initiate ka ng, I mean, kung wala kang RSD, pag pinatay mo yung inverter mo, still electrical room or kung saan nakalocate yung inverter mo, from there going up to a rooftop, buhay pa rin yung string mo or home run mo, kasi nga yung modules basta may araw yan, energize yan. So yun yung ano lang dito, nakikita ko na yes, makakatipid ka, economical, but for safety, yun ang problema kung may nasusunog ka na module, so and you need to troubleshoot, papatay mo yung inverter, tanggalin mo yung string, but still energize yung buong string mo going down. Okay? Next is Article 6.90.6. This one is the provision for the labels, no, of the RSD. So sabi dito, sa buildings with rapid shutdown, PV system shall have permanent labels as described in 6.90.6.6C 1 through C3. So ano po yun? So sa A natin, for PV system that shut down the array, conductors leaving the array. So ayan, so may mga, hindi ko na po pinakita yung buong ano ng code natin, but just to ano lang, just to appreciate. So meron tayong mga color coding or labels na ilalagay. So kung ang ano mo, ang RSD mo is pag initiate mo, ang purpose lang niya is ma-turn off niya yung this string home run from rooftop outside array going down, you will put this one, the red label. So sabi nga dito, turn rapid shutdown to the off position to shut down conductors outside the array, conductors within array remain energized in sunlight. Okay, so ngayon, but so far kung naka-module level array ka na, normally ito na yung malalagay mo kasi sabi dito pagka turn off mo, magsi-zero na yung ano mo no, mag-off na yung buong modules mo until to inverters up to the disconnect switch going to the grid. Okay? So meron tayong mga dapat ilagay sa ating rapid shutdown which the labels as mentioned now code. Okay, so the rapid shutdown and optimizer branch. So this one, I would like to share lang, no? But still, I'm not promoting. So if you want to check lang kung ano yung mga pwedeng gamitin. So you can check, i-google nyo and website po. Meron sila. Makuha nyo na agad yung mga datasheet nila and correct application. So we'd like to share the UGE standard for our engineering design, headed by our engineering manager, Sir Ronmar. Actually, si Sir Ronmar yung boss ko. This one is a sample of our single line of one of our project in Luzon and standard in our SM projects po. Ito rin po yung mga ginagamit namin. So yan, makikita natin dito, we have the modules connected in series. So hindi lang po kita, no, medyo maliit na yung presentation. So meron kang RSD dito. So this one is two modules, meaning the connected to RSD, meaning the RSD is 2 inputs and 1 output. Okay, so going to the MPPT, and so yung DC switch po medyo exage lang yung gawa kasi this one is already built in the inverter. So wag po kayong ma-confuse. This is not a DC fuse. So this one is built in inverter. So pinakita lang po namin. Ayun po, ito pala, sorry. This one is the entire diagram of our inverter. So sample of our design is equipment layout. So ito yung mga RSD ano natin, no, controller, the PLC transmitter nandito siya sa gilid. If you take a look, bakit ang dami naming home run? So this one is just to share lang for the safety purposes. Although sa mga ano no, sa mga kumbaga in a common installation, syempre gusto nating makatipid economically yung DC string mo will use one DC cable tray only. But the advantage is pag kami nasunog na isang string under inverter 1, meaning damay na yung string na under 2, 3, and 4, 5, and 6. So ngayon, UGE nagde-develop rin po ng mga standard applications. So per inverter na po namin ginagawa kahit may rapid shutdown siya. So meaning isang inverter, lahat ng string nun, isang cable tray. So and then pagdating sa baba, distributed din po yan separately. Ayan. So ito yung rapid shutdown controller sa ibaba. Dadaan kasi yung DC string sa rapid shutdown controller and bago siya pupunta sa maximum power point or MPPT ng inverter. Okay, and the AC string lalabas po siya. So going forward to the grid. Okay. Now, we have a actual installation sample lang for the rapid shutdown module level actual installation. Yan. So ito yung sinasabi natin, no. Ang requirement ng code is 1 foot. 'Di ba? So but so far within ano ka na nga within the array boundary ka na, inside boundary. So yun na po yung ano ngayon, mga ginagamit. Dati po forgot the brand, no, one of the brand of the RSD. So naka 3 meters away po kami from here going there, naka 3 meters away po kami, compliance po doon sa NEC 2014. Andun yung controller ng rapid shutdown. Okay. Yan. So this one also a optimizer using the Solar Edge inverter, no. So pagka solar edge gamit mo and may optimizer ka, so no need to ano na po siya, no, to provide rapid shutdown. Now, moving forward for the 6.90.3, so or the disconnecting means, sorry, as per code, we should have the marking. Sabi dito, PV system disconnecting means shall plainly indicate where in the open, off, or close on position and be permanently marked PV system disconnect. Yes, so this is one of our project. So ito po yung mga ano niya, yung mga labels or mark. Okay. So dapat mayroon po tayo niyan sa mga disconnect switch. Sa mga residential naman po, yes, you should provide on that for the disconnecting means. So of course, up the PV modules, I mean the parts of the solar PV system is modules, DC breakers, fuse, inverters. After the inverters, you have the disconnect switch. So you should provide this and to comply our code. Yan, so disconnection of PV or the photovoltaic equipment. So hina-highlight ko na lang po yung mga important provisions in order to, let's say, gusto natin mag-inspect sa mga project, lalo na dun sa mga owner side, no, ng mga fellow practitioners natin. Gusto nilang makita kung compliant ba yung mga developers or EPC. So this one po, no. So ang sabi lang sa code is isolating device or equipment disconnecting means shall be installed in circuit connected to equipment at a location within the equivalent or within site and within 3 meters or 3,000 millimeters of the equipment. An equipment disconnecting means shall be permitted to be remote from the equipment where the disconnecting means can be remotely operated from within 3,000 mm of the equipment. Sorry. Yan, so just to appreciate lang, no, ano ba yung sinasabi ng code. So if you have the electrical room of our client, no, dito. So now, kung maluwang pa yan, usually nandyan yung mga inverters mo rin. Or hanggat maaari, pag nagde-design tayo, malapit tayo doon sa tapping point. Of course, to reduce the cost of the AC cables and the cable trays. And also, ngayon, as per code, dapat meron kang disconnecting means doon sa malapit doon sa area ng solar PV system mo, which is ang required nga is 3,000 mm lang. Ngayon, kung meron ka na dito, okay na yon. But some of the DUs, no, so far ang nagpapa-required pa nito, no, sa mga 100 kilowatt above capacity, which is okay din naman based on our experience, same with the Meralco. Pagka nasa loob yung solar PV system mo or sa nandun yung premises niyan, nagpapalagay pa sila ng PV shunt trip dito. Kahit meron na kaming isolating device dito, no? So again, we have the disconnect switch. After the inverter, we have panel board for the distribution for inverter protection. And after that, we have disconnect switch. In case na mag-fail yung panel board mo for the inverter, so safe pa din yung solar mo at the same time, hindi madadami yung grid. Ngayon, nagpapa-required si like Meralco, magpapalagay na yung shunt trip dito. So ang ayaw niya kasi is during the trouble, ayaw niya nang nagpapaalam pa sila o papasok doon sa loob ng facility ng client. Dati pumapayag sila na magbigay lang ng letter si client sa kanila na they are 24/7 allowed to enter on their facility, no. But ngayon nagigpit na po sila. This one of our experience na doon talaga sa labas nagpapalagay. So ito siya. Normally malapit siya sa meter, sa kilowatt hour meter ni Meralco or sa pole. So ayan. So this one is PV shunt trip. When you push the button, automatic po mamamatay yung ano po yung mamatay dito is siyempre yung solar lang po siya. Ito, this one. Ngayon, itong sa 30 amperes, kung makikita nyo, nangyayari din po ito sa residential. So based on my experience, dati pag yung bahay is walang disconnecting means or disconnect switch, no, after kilowatt hour meter ng DU, diretso na agad sa loob. So ngayon, kumbaga pag may trouble yung yung solar or yung nila, yung grid itself, wala silang kumbaga hindi sila makapasok agad. So ni-required din dito sa NCR, ni-required rin po yung switch na maglagay sa labas, lalo na kung greater than 30 amperes. So meaning kung meron kang inverter, after inverter, maglalagay ka pa doon ng tawag dito, disconnecting means or switch sa labas. Pero ang nangyari, hindi na kasi imagine kung maglalagay ka pa ng ganun, which is okay yun kasi pag pinindot mo yung breaker sa labas, ang mamamatay lang yung solar. Kasi nga after inverter yun eh. But si Dio pumapayag na maglagay ka lang ng disconnect switch after the kilowatt hour meter. Pero ang disadvantage nun, patay lahat. Pag pinindot nila yon, patay yung solar mo, patay din yung grid mo. So as in naka-turn off yung buong system. So unlike this one, solar lang to kasi itong shunt trip is connected to dun sa disconnect switch mo, relay. Now, another one required by our code, we have the devices mark line and load. This one, kung makikita natin yung grid merong mark line and load, that's okay. Kasi yung grid, I mean yung disconnect switch naman ng client no is sinusuplayan siya ng grid or ng DU. So ngayon, sa solar hindi siya pwede. Sabi dito, devices marked with line and load shall not be permitted for backfeed or reverse current. Kasi nga sa solar, during night time, kung wala kang araw, pumapasok yung power ng though minimal yung negligible yung current, but pumapasok pa rin doon sa inverter mo. Kaso hindi lang nag-on yung inverter mo kasi wala kang DC. So, yun yung ni-required ng code natin na kailangan yung breaker mo dito, wala siyang marking na line and load. This one is okay for the tapping point or the client side. Kasi supply lang ng supply eh. Yung solar mo dito, tuloy lang ng tuloy. Okay? So, but for the solar breakers, so, ayan. So, dito sa side na to, ito yung panel board, distribution panel board ng mga inverters, and this one is disconnect switch. So, ito po dapat wala pong line and load marking. So, ang okay lang is this one for the tapping sa client side. Okay? Now, moving forward for the wiring methods naman, so this one naman, no, very clear po ito, no, with due respect din dun sa mga fellow practitioners natin. Though, marami marami tayong mga installers na nakikita ko na yung after inverter, yung DC and AC magkasama sa isang raceway. So it is very clear in our code that the PV source circuits and PV output circuits shall not be contained in the same raceway. Cable tray, cable outlet box, junction box, or similar fittings as conductors, feeders, branch circuits of other non-PV systems, or inverter output circuits unless the conductors of the different system are separated by partition. Yes. So pagka yung pwede naman yun, no, yung ilalim ng inverter mo, if you have a cable tray, so kung meron kang separator doon for the DC and AC, okay lang po yun. So one of our project example lang. So this is the DC system coming from a rooftop, and we have the AC. So yan, so separate po siya bago siya nagpunta sa distribution panel and disconnect switch. So hindi po magkasama yan. Now, another one is the grounding and bonding, no? So very important. So ayan. Pero may mga tanong kasi, normally may mga nagtatanong sa amin kung required ba maglagay ng electrode for the DC. So kahit po sa NEC and PEC po, other relevant codes, wala pong nakalagay na required ang paglagay ng DC electrode, but it's up to the client or it's up to you kung gusto mong may double protection in terms of grounding. So pwede yun, but remember yung cable grounding natin dito, or this is the normal HSN or AC wires, no? So connected siya sa railings, and the railings connected to the LFIT, and the LFIT connected to the purlins of the roof structure. And remember, the purlins connected to the process or any raptors, and going to the column, and the column connected to the ground. So yun po. So wala pong but depende po sa client yun. Again, So kung gusto niyang electrode, wala pong problema.
Say excuse. You have only 5 minutes remaining time.
Sorry, sir.
You have only 5 minutes remaining time.
5 minutes. Okay, sige, sir. I-wrap up ko na lang. Okay, so the PB module manufacturer code is hard compliance. So this one lang, no? Ito yung mga codes na kailangan natin. And codes and also the manufacturing of the racking system. So yan. So yan lang makikita natin doon sa mga data sheet kung compliant sila nito. But I'm not saying na lahat po. So of course kung meron sila niya. But the usual is 2703. This one. So ito yung mga railings natin in clamps na kumakapit sa modules. So ito naman yung sa NREL. So yung mga class na yan, ito yung sa rating ng modules. So of course the class A is yung pinakamaganda. So but the class B okay na rin po siya. So ito yung kung gaano kabilis mag-spread yung fire once na yung frame ng module masunog. So ito po yung during ito yung mga yung mga ini-implement during testing. So moving forward for the permits and certification. So again, for the during the pre-construction phase, we need to comply the distribution impact study no application to the DU. So ang mga requirement lang naman nila dyan is a single line and the technical specs of the what you call this mga equipment, modules, inverters, and also the they have a plant parameters no ilalagay mo doon kung ano yung mga rating, also the load of the client. So medyo iba-iba po kada DO. So may kanya-kanya silang template. And yes, siguro hindi ko na masyadong elaborate yung sa net metering interconnection because I have no time na po no. So and of course before we start, we need to apply the electrical permit. So OBO, and it depends kung under siya ng PESA or LGU. And also the DOE, this one is a CORFO or Certification of Registration for Own Use. Ito yung may tax benefits no. Before we start the project, pwede ka mag-apply kay DOE to be able to have a kumbaga benefits no. Kumbaga kung galing sa China yung mga equipment nyo, pag in-apply mo to kay DOE, pagdating dito sa mga duties and taxes, so less po tayo. And also once na matapos na yung project, ito yung mga one of the document that we need to secure from our distribution utility between client and the DU, issued of the fixed asset boundary document, or ito yung tinatawag na interconnection agreement na nagkaroon kayo ng solar sa system nyo na pumayag si DU. Okay, so yung CFI po depends on the DU, the OBO kung required nila yan or hindi. Depende po sa area. So again, also the ERC resolution, this one is under the net metering application. So the bidirectional meter. So and net metering. So sa ngayon po dati net meter lang no, and now I think karamihan sa atin aware na meron na dagdag yung tinatawag na rec meter. So yung rec meter po, ito po yung in-install after the panel board. So kumbaga direct siya kumukuha ng reading doon sa pinoproduce ng inverter. Okay, yung net meter kasi is papalitan mo yung meter ng client. Yung existing meter niya, papalitan niya ng net metering. But yung rec meter, so yun yung ilalagay after doon sa inverter mo or panel board mo para makuha mo yung exact production ng solar mo. Okay? This one is a sample diagram from the DU, I think Meralco. Risk of non-compliance, so yeah, damage corporate image and reputation. So this one, no, yung pag hindi tayo nagko-comply, so ito yung natin. So risk. So non-compliance to DO, of course, meron kasi tayong contract sa kanya, lalo na yung mga malalaking manufacturing plant. So we need to inform to with them na magso-solar po. And would like to share no yung mga dapat i-check before the installation because part of our discussion is safe installation. So of course, yung structural certificate. So dapat ma-verify natin yung structure na safe ba siya. Okay, so and then locate storage area of major equipment, temp facility and access of workers. and conduct leak test. Kung may mga tulo man dyan, of course, dapat maayos muna kasi mahirap kung naka-install na and magre-rectify tayo. And road mapping for traffic management. And the one that dapat nandun is yung barricade in rooftop during installation for the safety board workers. So ito yung isa sa mga importante, no, yung sa mga mounting installation. So karamihan kasi let's say kung yung sa mga sa mga residential, so we have no assurance or guarantee na pag may nangyari diyan, kaya ba nating maano yung insurance doon or kaya ba nating palitan. So one of our practice is kung magde-design kayo, so bigay lang kayong PV module tapos i-fill up nyo tong mga ganitong form template from your vendors. Sila magsasabi kung ano yung appropriate mounting na ikakabit. And also magbibigay na rin sila ng quantity for you to have a costing. So ang maganda lang dito is you have assurance, no, pagka nagkaroon man ng problema after the may mga incident, so meron tayong claims. Yan. So mounting insulation, yeah, very important din po yung sa mounting insulation, yung naka-perpendicular yung racking natin, railing. Kung nandito yung purlins mo, so dapat hindi ka nakaganito. So though pwede naman, pero yung pagdating sa safety, mahina siya yung kapit niya. So kung nandito yung purlins mo, okay yun. Which is naka-perpendicular yung railing mo, marami siyang kinakapitan. Unlike sa naka-parallel ka sa purlins. So isa po yan sa kino-consider during installation. So i-rough up ko na lang po, no, during testing, I mean inspection, check natin yung mga levelness for the quality. And yeah, this one also, pagka yung mga clamps dapat naka-torque po yan. So per clamp po yan, end clamp and mid clamp. And also the L-fit, yung kumakapit dito sa rooftop, dapat naka-torque din po yan bago isilan. And another one is this one, no? So part of the calculation kasi nung tinatawag na clamping zone, so dapat masunod natin yung mga requirement ng module. Marami pong nakikita na yung racking nandito na, o railing nandito na sa dulo, no, konti na lang kumakapit. So pagdating niyan sa mataas na o malakas na hangin, so mahina po yung kapit niyan. So meron po yung formula L/4 plus minus 50. So makukuha mo na yung ano niyan. Yun yung normal na mga ginagamit ng manufacturer. Depende kung ang installation mo is paalam or pataas. Of course, isa to sa mga nangyayari din, no. So yung sa tinatawag natin na compatibility of DC connectors. Kasi ang mga modules meron yang mga connectors requirement. Also, the RSD meron din yan. But just to share lang, ang RSD is pwede silang mag-adapt kung ano yung module gagamitin mo. Pwede nilang palitan yung connectors nila to have a same connectors. Kasi kung ang module mo is MC4 tapos yung ano mo iba amphenol, so hindi yun yung cross mating na tatawag. Possible po baka doon magkaroon ng kumbaga problema. Yan, so dapat parehas sila, compatible yung mga equipment natin, connectors. So one of our system ito po. So pare-parehas po yan kahit may rapid shutdown. Dapat pare-parehas yung mga connectors to avoid cross mating. No, proper termination, ayan po. So makikita naman natin to sa manufacturing or installation guide nila. So madali lang makuha. Dapat ma-fit ng maayos yung cables dun sa mga pin. So isa po to sa mga problema na dapat iwasan yung proper bending radius ng DC wires. Yan. Another one, so yung DC string tagging natin, yan. And so per string, in case of trouble, madali natin malaman kung ano yung pwede nating tanggalin sa MPPT. And for the AC side, mga torque marking, tagging, so yan lang po. And yeah, this one siguro hindi ko na elaborate, no. I'll give this presentation na lang. So yung mga required testing for the as per the PDC and ARC. So ito yung mga kino-conduct, no, during functionality test before we energize the system. And some of these requirement makikita na rin doon to sa specs nung or technical report nung test report ng mga inverters. Pero kung chine-check pa din to minsan ng mga DUs natin. So normally yung anti-landing and anti-landing tsaka yung system-energized lang normally. Pero pagka 100 kilowatt above, we have a zero export device. Yan, so this one. So malapit na matapos. So this one, so I'll share one of our project. Ayan, so ito yon, so mga minimum requirement, but ayan.
I said,
Thank you, sir.
we visit
Okay
now
na, sir.
1 minute.
I think we're done, sir, no? Thank you. So this is for our project. So
Wrap up
that's
lang,
all
ma'am.
for our presentation, and maraming salamat po sa pakikinig niyo po. Thank you so much. IAE Cebu.
Sir, this is Bob Cup, sir.
Hi, sir
I have
Bob.
one
Yes.
concern.
Yes, sir Bob.
Do you install a floating solar panels?
So far, sir, we have one project, no? So hindi ko binisabihin yung project, but wino-work out pa namin, sir. But in UG Philippines, USA, and Canada, wala pa kami so far. Hindi pa kami nakakagawa ng floating. But si Sir Ron Marata, meron na siyang win-work out din, isa sa Cebu, and meron din kami din sa Manila ngayon.
Yeah, actually, we have a workout here in Cebu, but we cannot mention the name as of now. Sorry, Sir Bob.
Okay, sir, thank you very much for sharing your expertise in solar PV panels and also its application. And you know, for the electrical engineers, our direction for this century is more on alternative energy source. And PV is one of the qualified technical devices that we can harness power from the sun. Okay, so may I call in Ronmar Gonzalez, our BP Technical, to award certificate for you, sir. Sir Ronmar.
Thank you so much, Sir Bob. Okay, so thank you so much, partner Director Sidney Magaring, for sharing your valuable expertise and knowledge in solar industry and commercial and industrial. So, if you choose UGE, rest assured that your PV system is safe and reliable. Okay, so in behalf of IIE Cebu chapter, help me award this plaque of appreciation given to Engineer Sydney B. Mangaring, RE and CEM, as our technical resource speaker on the topic of solar PV code compliance and safety installation in the 21st and Central Visayas Regional Conference held on 27-30 day of July 2022 via hybrid at the Skywall A and B SMC site, South Road Properties, Cebu City. Given this 28th day of July 2022, yours truly, signed by me, Ronmar B. Gonzalez, VP Technical Affairs, Engineer Erwin Salvador, our technical consultant and advisor, Engineer Magdaleno Baclay, President, and Engineer Brian Basilan, our Regional Governor, Eastern and Visayas, Central Visayas. Thank you very much, Engineer Sydney.
Thank you, sir. Maraming salamat po.
Okay, sir. Thank you very much for sharing your expertise to all electrical engineers. So, our next speaker for this afternoon, last speaker, he is a graduate of a Bachelor of Science in Electrical Engineering at Seliman University, former electrical engineer in Al Riyadh Company, Al-Hada Armed Forces Hospital, United Medical Group, and Armed Forces Hospital, Taif Region. Currently, he is the manager and proprietor of Aris Electrical Consulting Services in Dumaguete. Ladies and gentlemen, would you please welcome our speaker for this afternoon, Engineer Benjinito R. Simini.
Thank you. Thank you. Thank you. Am I loud and clear, sir? Klaro ko diya,
Sir,
sir?
nakamute ka, sir.
No,
Nakamute ka, sir. Okay.
Sir, you're mute.
Kana, sir? That one?
Okay, sir. Go ahead.
Okay. So, good afternoon and a pleasant afternoon, everybody. And thank you for having me here. It is a privilege, in fact, to be invited by no less than Governor Pasilan. Thank you so much, and the organizers of Eastern and Central Visayas IIEE for having this forum. My task this afternoon, I will not be doing any calculation, but I enjoyed watching the other presenters. Anyway, my topic is about healthcare facilities, which is really a unique one, and especially that we are in the pandemic. Over 2 years, we heard a lot about hospitalization and the number of people that are infected. So I decided to present something which could be of help for us engineers to be knowledgeable on what is really involved in the design and the inside of the healthcare facility or the hospital, especially those retirees and those in the twilight zone. And really, you'll feel the interest of this subject matter. So as we go along, I have only limited time, and hopefully I can catch up. Okay, the pandemic has highlighted the need for us electrical practitioners to be knowledgeable on the unique electrical systems of healthcare facilities. Due to the critical nature of the care being provided at these facilities and their increasing dependence on electrical equipments, healthcare facilities have special requirements to ensure safe use of electricity for the preservation of life. The discussion comprises electrical power distribution systems, electrical safety, patient care issues, continuity of electrical service, and reliable power source to all sensitive and critical equipments. The objective at the end of this lecture, the kind of electrical systems you would know in healthcare facilities, the basic protection to limit hazard currents, the need coordination and protection, and the requirements of standby power plants in healthcare facilities. I will not go over with these definitions. You can read this one in my report. It's quite lengthy, and so that I can save time. Now, like in any other organization, a healthcare facility or a big hospital is governed by standards. There are standardization organizations that develop and stipulates the standards that will be implemented in each healthcare facility. And on top of that, we have the NAC, National Electrical Code, NFP 99, healthcare facilities, NFP 101, life safety, and NFP 110 about standby generators, IEEE, electrical systems in healthcare facilities, and of course, our own PEC 2017 edition. And last but not the least, a very important one, the Joint Commission International. This is the accreditation body in each standard healthcare facility, and these are the group that are going around to give the accreditation to any healthcare facility to prove that they are following what is the proper practice, electrical engineering practice, and also mechanical and biomedical. So we're part of this one. The risk categories. Now, the healthcare facility are categorized according to the risk involved by the patient and the staff that is occupying in that particular space. So, risk category 1, it involves major injury or death to patients or caregivers. Risk category 2, minor injury to patients or caregivers. Risk category 3, patient discomfort. And risk category 4, no impact on patient care. I will be discussing on the toughest risk category, the dangerous category, which is category 1, because it involves human lives. In any healthcare facility, there are two subgroups of loads that are under important consideration. First group is what we call the non-essential electrical systems. This involves the general lightings, general lab equipment, service equipments, patient care areas, and so forth. And the other group is very important load. We call it essential electrical system, or we call it EES in our practice. So EES vary according to the risk to the patients and staff that occupy that space. An example of that is this facility where I was involved in the development of this healthcare facility in Saudi Arabia. So this is a complete facility with life support, cardiac ICU, surgical ICU, BICU, and neonatal ICUs. So it is compliant type 1 EES as per NFPA 99 section 4.4 and accredited by the Joint Commission International. Next to that, the essential electrical system comprises of three subgroups also of loads. We call it the critical branch, the life safety branch, and the equipment branch, which will be discussed in the following slide. The critical branch comprises the isolated power systems in special environments, task illumination, lightings on selected receptacles in the following areas: pedia ICU, medication preparation, areas in pharmacy, acute nursing, psychiatric areas, ward treatments, nurse stations, specialized patient care illuminations, nurse call systems, blood-borne tissue banks, telephone equipment room, task illumination, selected receptacles, and selected power circuits for the following general care beds: angiographic lab, cath lab. When you do your heart catheterization, yung mga nilagyan ng mga stent. So, coronary ICU, hemodialysis, emergency treatment rooms, human physiology labs, and so forth. And additional circuits and single-phase fraction motors needed for effective operations, such as the positive and negative pressure rooms, which are popular, which are famous during the pandemic. And even now, there are patients that are on negative pressure rooms. Next to that is what we call the life safety branch. The life safety branch comprises illumination means of egress, the lightings in the corridors, and the stairways, exit signs, alarms and alerting systems, emergency communication systems, task illumination, battery chargers for battery-powered lightings, and select receptacles at the generator, elevators, lighting controls, communication and signal systems, generator set locations, task illuminations, battery chargers, important receptacles, generator and transfer switch rooms. Generator accessible, essential for generator, accessories essential for generator operation. Of course, the automatic doors used for exiting the people in an emergency. Now, the life safety branch is exclusive. These are the only loads allowed. You cannot add. And of course, this is also per the code and the agreement with the authorities having jurisdiction or the hospital administration. So if ever there is an addition, that must be discussed properly. But the code says only this group of loads are allowed in this particular branch. The equipment branch. The equipment branch is also subdivided into non-delayed auto transfer, delayed auto manual transfer, and the delayed transfer. For delayed automatic connection to alternate power source, meaning this can be transferred beyond 10 seconds on the onset of the power interruption to the emergency source. So you have the central suction systems, the sump pumps, compressed air, medical air, smoke control and stair pressurization for fire, kitchen hoods in the dietary, ventilating systems, your AHUs, the HVAC systems, air conditioning, and your positive and negative pressure requirements. Equipment for delayed automatic transfer. Another group, heating equipment for ORs, labor and delivery, recovery ICUs, cardiac care unit, nursery infection isolation rooms, emergency treatment space, general patient rooms, pressure maintenance for fire pumps, pumps for water-based fire protections, hyperbaric and hypobaric facilities, pressure-related treatments, automatic doors, and autoclave for sterilization. Equipments for non-delayed automatic connection. These are the instant transfer within the 10 seconds period. On the onset of the normal power loss, this should be transferred immediately to the generator supply, to the backup power. All generator accessories such as transfer fuel pumps. Obvious, because if the fuel pump have no power, eventually your generator will die down. Electrically operated lowers, essential for generator operation. Now, this is an example of a very simple healthcare facility, small hospital per se. So we have a normal source, we have an alternate power source, normal source from your utility. The alternate source could be a generator, but the code says it is also acceptable if the normal source is a generator, self-generation, and the alternate source is also another generator or a fuel cell. So you have here in the normal bus bar, the non-essential loads, of course. And in between to this, in conjunction is the automatic transfer switch, a single transfer switch. So downstream on the emergency bar, we have the equipment system, critical branch, life safety branch, we call it essential electrical systems. And this is allowed if the total connected load of EAS is 150 kVA or less. This is cheaper in installation, but redundancy is inferior. Another arrangement is the installation of multiple transfer switches. So the EAS is subdivided into 3 transfer switches. And again, this is a typical arrangement and allowed if the EAS is over 150 kVA. And of course, we have this a bit expensive kind of arrangement. You have 2 sources, source A, source B on the normal source, and you have your normal bus bar and the normal loads, and you have your multiple ATSs with a multiple generator as backup supply. So better for redundancy, but a bit expensive. And again, this is over EAS 150 kVA, popular in large hospitals, heart hospital facilities. Now, requirements in the OR. Power requirements in the OR. Here, you have the setting in the OR wherein these people are really very busy about their doing. Then, there are a lot of equipments surrounded. So the code says the OR will require 36 hospital-grade receptacles with at least 12 receptacles, but not more than 24 shall be connected to the normal branch or to the critical branch. It is to be divided. And the receptacle has to be color-coded, white for normal and red for emergency. So to those people who have experienced this kind of situation, I mean, you're a patient, God forbids, then this is what you will find in a standard OR. Lesser than that, you're in danger. ICUs. This man is in big trouble. This is an ICU. You will find the number of biomedical life support equipments. So you can imagine the need of us electrical engineers to provide this kind to save the life of the, help save the life of this patient through our engineering knowledge. So the ICU will require a minimum of 14 hospital-grade receptacles with at least 1 of which connected to either the normal or critical branch, and likewise, it is color-coded white for normal and red for emergency. Critical general care, normal room, it will require at least 8 receptacles. And part of this one to be normal, and depending if you will also put part of that to the emergency. Let's talk about the very important element, we call it in the emergency systems, to designate a generator, whether it is a separately derived system, ground system, or a non-separate derived system. We're talking about the grounding here. If the neutral of the generator is hooked up, directly bolted to a 3-pole automatic transfer switch going to the source, then that is not a separately derived system. If the neutral point and of the generator is connected to a 4-pole automatic transfer switch, then grounding is prohibited, and that is what we call separately derived system. The importance of this I will discuss in the slides as we go along. This is a particular room, patient room, the importance of grounding. So how can I close this one? Okay. So grounding, here you'll find bed 1 and bed 2. So there are 2 patient beds in a particular setting. So in the headboards, you will find the socket outlets, the one I discussed, distributed between the normal source and the emergency source. On the left side, you should find what we call the grounding point. The grounding point. Now, what is the importance of this grounding point? We call it ground jack. The importance of this, if the biomedical people will bring in mobile x-rays, defibrillators, or other biomedical equipments to be on the safe side, they will plug the ground wire to the grounding jack to dissipate any earth leakage back to the earth. That is the importance. If you go to the hospital and you are, God forbid, in an ICU, you should also, if you still, if you're mindful, I mean, you will find that this is available, these ground jacks. Typical grounding point, at least one ground jack in each critical patient bed location. So about critical patient, there should be one group of one grounding jack like this, and 6 ground jacks in an operating location. Now, these are the wiring requirements, and you can read this one in the Philippine Electrical Code 2017. And the message, what is important here is the separation between the emergency branches and the normal branch, and all the branches coming from different ETSs must be independent to each other, so that a fault or a fire on one of these groups will not affect the other one, and thereby the continuity of service is still available to the EAS system. Electrical hazards. The major contributors to electrical hospital accidents are faulty equipment and wiring. This is the earth leakage. Electrical accidents fall into 3 categories: fires, burns, and shock. Electrical shock is produced by current, not voltage. Why I am emphasizing this one? The patient, especially those in the ICUs and in the OR, they are sedated. They cannot even shout, they cannot even talk, and therefore they cannot feel if they are already on a silent electrocution mode. So we as electrical engineers are responsible on this in collaboration with the biomedical engineering. The biomedical equipments has to be calibrated to minimize, to mitigate this kind of risk and to prevent silent electrocution. The human body acts as a large resistor to current flow. The average adult exhibits a resistance between 100 ohms and 1 million ohms measured hand to hand. The lowest levels of current that are perceptible to a person starts about 100 microamps. An arm muscle contraction and pain may develop 1 to 5 milliamps and is assured at 10 milliamps. Uncontrolled contraction, no let go, ito na, can start at levels of 6 milliamps and higher. Temporary respiratory paralysis can occur. Above 30 milliamps, the chances of fatality from variety of causes, including ventricular fibrillation, increases. So the patient by unfortunate events will not only die because of this illness, because of the medical procedure. So we electrical engineers, probably, we are also one of the contributors through the leakage current in collaboration with the biomedical engineering. That's why we have to check our plugs, the wires, the equipment insulation, this is the biomedical equipments, and the setting in the OR or cath lab tables wherein the heart stents are installed. Then there should be a maintenance, periodic maintenance to check on this one, and the installation has to follow the appropriate codes as stipulated. Otherwise, silent electrocution is a very dangerous, and it is a reality. That's why patients die, and of course, we do not know, because probably they will write the report, it's a medical condition, but probably we are also as electrical engineers guilty of this one. Allowed leakage currents, OR table, 75 to 100 microamps, and you can read this one and so forth. So each hospital equipment has its own leakage current contribution. It has a minimum leakage current. So if it goes beyond to this one, this should be noticed, and something has to be done about calibration and insulation mitigation measures. Maximum safe current leakage as per NFPA. For portable equipments, about 300 microamps. Portable equipment with non-isolated input patient leads at 100, and portable equipments, housekeeping maintenance, about 50 microamperes. So it is only within these limits. Protective measures for leakage current. So here, you will find our grounding system is the primary safeguard for bypassing the leakage and fault currents to prevent shock from these sources. So grounding is very important. Metal conduit lowers the effective grounding impedance by providing another parallel path. Actually, our EMT pipes, REC pipes, they are what we call equipotentially bonded. They are grounded so that any leakage current should flow back to the earth. The use of isolated power supply in special environments, the use of ground fault circuit interrupter is also part of the solution, as will be discussed in the next slides. Conductive flooring. So when you do an OR, operating theater, the
Wala kay number niya, right? Oh. Hello, everybody. By the way, the signal of Engineer Simini has been lost. I don't know what happened to his technical team there. Maybe we can wait for a while, or a couple of minutes, and then if we don't have his signal again, then we may adjourn. Just a few minutes, guys. Tubog sa simini. Naputol mo tingin siya. Bye. Hello.
Hi, Sir Roberto. Ano audio po? Sir Bob? No audio po kayo, sir.
Hello, everyone. We apologize for the discontinuation of the sharing of Engineer Semini. He is from Dumaguete, and maybe there is an issues in his signal. So therefore, we are going to adjourn this afternoon session. So see you tomorrow at SMC Side Hotel, wherein our chairman of the board for electrical engineering will be with us. So please be there tomorrow. Thank you very much and good afternoon.
Thank you.
Deh, ikaw na lang. Ako nag-sign off deh. Sign off na lang. Siya naputol eh, no? Nawa mo sila ngayong kuwan. Ang iyang kuwan doon sa chat, nawa mo sila sa panelis, nawa mo siya.
Hindi ka ba napapansin? Pangarap ba ay napipitin? Tala'y gustong sungkitin, pero ang layo ng dapat ahakin. Dito sabay-sabay iaangat ang bandera at isa't isa. Dahil galing ng isa, mas magaling pagsama-sama. Ang galing mo, ipakita mo, basta Pilipino. Galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino. Galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino. Galing dito, galing dito.
Luzon, Visayas, Mindanao, ay kamakaret nagkakawaw. Yeah.
Malawag pa'y itiranyag, kiti aldaw. Sumikat ka, ito'y lubong nabaw. Pilipibyo, kung orgulyo grita na itero mundo.
Hawod ang imundo ko, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Visaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito.
Hello? Can you hear me? Hello, sir. Nakat ko, sir. Nakat.
Hi sir, Engineer Benji. Unfortunately, no, na-cut out ka about around 30 minutes. So I think uh, we will resume your presentation. We have still 180 participants as of now.
Which part na nakat, sir? Can you look at it?
Okay, so Engineer Benji, you can continue your presentation.
Yes. Which part na nakat, sir? Am I audible?
Sir, I did not saw your last presentation slide. So I think sir, are you ready now?
Yeah. But if you can give me any information, which part, so that I can start.
Sir, just I think just proceed. I think last time I saw it is in a GFCI.
Okay. GFCI. Okay. So just to recapitulate, and I'm sorry for that. Unknowingly, I am clear, sir. Clear na ko dia. Okay. So this is an example. Loud and clear ko, sir. Okay ra? Am I loud and clear?
Sir, you're clear, and then I will also saw your presentation, sir. You can proceed now.
Okay. So I have to go back, I think, on this particular setup, an example of GFCI. So the working principle is that the what goes in must come out. If there is a 1 ampere going inside, then should be 1 ampere going outside, and this sensor, CT, will be in equilibrium. However, if the return is less than what is going in, then the CT will act to trigger an opening sequence. And coordination, selective coordination. Here, you'll find that the network is poorly coordinated. When the fault happens at this point, everything is affected and it will cause a blackout of the entire facility, which is dangerous. This is a healthy coordination where, in fact, if there is a fault at this point, only this overcurrent protective device will see this problem and open the fault to isolate. So this is where a short circuit study will come in. This is an example of a selective coordination. Again, if a fault happens at this point, then this overcurrent protective device will be the only one to trip and isolate this branch. Likewise, if it is here, this feeder protective device will isolate this and not the other way around, because you have a bus tie which is supporting also the other loads. Likewise, if it is on the emergency side, if this fault happening on this branch, then only this protective device will open and not the upstream devices. So again, as I've said, I have heard and I have watched a lot of short circuit reports, short circuit studies discussed. So it's just a very basic thing that I have here. This 2000 amps mains is the main breaker of this facility. We have two incoming mains, so normal source A, normal source B. So if it is a fault, three-phase fault happening at this branch, then the calculation was found out that the prospective fault current is about 29,780. And if you go to your tripping curve, you will find this at this zone, this region, and the opening time is about 0.5 seconds. So likewise, as you go downstream, and on this feeder, if a fault happens, then this is the only breaker that will operate as it sees a prospective current of 27,877 amperes, and this is on this region, and the opening time is 0.18. So selective coordination is already in place. And likewise, if you have this fault somewhere at this junction, then the breaker upstream to it, like if the fault happens here, then this breaker will see the prospective current at 18,241, which is on this region, and the opening time is 0.1 seconds. And on so forth, the 20 amps will have 2,770, and the opening time 0.03. The importance here is that there is a selective coordination. They are not overlapping. So short circuit study is very important to determine your short circuit level at any point from upstream to downstream. So ground fault protection. Again, I will repeat this one. Ground fault protection is required on any feeder or service disconnect 1,000 amperes or larger on systems with line to ground voltages or greater than face-to-face voltage of 600 volts or less. In healthcare facilities, an additional step of ground fault protection shall be provided, and the next level of feeder disconnecting means downstream towards the load. Wherever ground fault protection of GFU equipment is applied to the service grounding power to a healthcare facility, an additional level of ground fault protection is required downstream. The story of this one is from NEC, as I have discussed a while ago. Unfortunately, I was cut. So NEC before allows multiple feeders to the elevators with one protection upstream. So a fault on one of the elevators it's render the rest of the elevators inoperative without power. And also, this is to catch this low magnitude ground current. Low magnitude ground currents are a dangerous condition because if it leaves undetected, it will create heat and produce fire. So NEC 517.17 prohibits the use of additional levels of ground fault protection on the following systems. So not all of them is required with ground fault protection between the on-site generating unit and the essential electrical transfer switch on the load side of the essential electrical systems transfer switch. Ground fault protection for operation of the service and feeder disconnecting means shall be fully selective, such that the feeder device and not the service device shall open on ground faults on the load side of the feeder device. Very important. A 6-cycle 0.1 second minimum separation between the service and feeder ground fault tripping bands shall be provided. Operating time of the disconnecting devices shall be considered in selecting the time spread within these two bands to achieve 100% selectivity. So as engineers, the short circuit study is very important. I have to emphasize. For ground fault protection of equipment, the alternate source of emergency systems, generators shall not be required to have a ground fault protection with automatic disconnecting means. Therefore, for the above reason, healthcare facility systems provide ground fault indication alarm only on standby generators. So that is shown in this illustration. So ground fault protection is not allowed downstream to the EES, between the ETS and the emergency electrical, essential electrical system. And also from the emergency bus bar and to the ETS, ground fault protection is also not allowed. But now in the latest edition of NEC, an alarm is allowed. And also here from the generator to the bus bar, emergency bus bar, an alarm is the only required to indicate that the ground fault is imminent or in ongoing. The rest of the normal feeders on these normal bus bars, ground fault protection is mandatory. So a simple ground fault relay is that same principle. What goes in must goes out with the same magnitude. However, if there is a breach, then part of that ground current will surely goes to the ground. It will trigger the equilibrium of this GFR, ground fault relay, to open the breaker. And I have already shown this one, the generator. So this is for the new graduates and those who are still gaining experiences on their field of practice. So I have expound a bit on the parts of this generator. So here is the AVR. The AVR for voltage control by flux processing to the from the exciter going to the main field. So it controls the voltage. Here is the alternator itself. So when we say a generator, it's composed of an alternator and the generator engine. So you will find probably your PMG, permanent magnet exciters, in the rear part of this machine. And of course, this is for the field production of your magnetism going to the main winding, and in conjunction with the ABR controls the voltage. So here is your governor. The governor is for speed. Don't interchange. Because some of them think that the governor is related to the voltage. No, the governor is related to the speed or frequency of the engine. So you'll find your adjustments here and your protective device, in this case an air circuit breaker, to protect the winding against fault currents. So I will skip this one. And here, a very important discussion, typical governor transient load response and typical ABR transient load response. Many suppliers of generators, especially the China origins, so you'll find that they're only good in the literature, but during the test, you'll find that some are true and most of them are not true. So upon the application of the load, this is very important in medical facilities because it will affect the loads, the image quality. Nowadays, the MRIs, CT scans requires a very good condition voltage. Although there are UPSs in use downstream to the ICUs and to these areas, but still your generator is required to produce the right voltage. So here you will find that the application of this load for the at this particular junction. So once the load is applied, the tendency of the generator and engine is to lower its speed, lower its frequency. Then the function of the governor is to recover. to recover and put it on nominal frequency. Then when the load is removed, you'll find that the speed will tend to increase, and again the governor will function to brought it back to its nominal frequency. Likewise, in the AVR, when the load is applied, the voltage will tend to drop, and the AVR will produce more field flux going to the main field winding from the exciter, and thereby normalizes the voltage. And when we remove the load, the voltage will tend to go up, and again the AVR will control this voltage back to this nominal value. So this thing, if you read this one, is very, very important, that running a generator under load is not advisable. When you see the smoke is white, that is underloaded. If the smoke is light, about bluish, that's correct. It should be 80%. And you have your frequency also required in your decision making to when you buy or specify a generator. This is where the grounding of the in relation to the automatic transfer switch that I discussed a while ago. Generator solid grounding is a function of the ETS. So if your ETS is 3 poles ETS, then the generator neutral should not be grounded. If your ATS is 4 pole, then the generator neutral should be grounded. This is to avoid nuisance tripping on the sensor of the ground fault protection because of the zero sequence. So here is the explanation. In a healthy setup where you have a 3 pole ETS in between the normal source and the generator, if it's not grounded, then there is no nuisance tripping. However, if by mistake 3 pole ETS in use and your alternator is grounded by mistake, so you will have a multiple current path and some of them goes to the ground, thereby tripping the normal utility source. This is dangerous. The fact that the presence of the normal power, the generator will not start because the sensor of the generator is always reckoned to the normal bus bar. So total blackout will happen to the facility. And if you have a UPS downstream, your battery will be drained. And without the knowing of the maintenance engineer, you will find that really this is a serious matter afterwards once this grounding is corrected. It's wrong to ground using the common point of the generator winding using a 3 pole ETS. It will create nuisance tripping. The recommended is the 4 pole ETS. So here is a healthy installation and there is no nuisance tripping that will happen. So we know what is an auto transfer switch. As I've said, I always recommend transfer switches with bypass in my projects before. So many times you have experiences. I've been called to check on some faulty ETSs. So the system can be mitigated by incorporating a bypass switch. So this is an example of an ETS with a bypass switch, and it is recommended that the contactors or the breakers must be draw out type. You can draw it out for maintenance purposes while you engage your bypass easily without compromising the power for the patients, critical patients. So generator loads, when we specify a generator, without knowing that we are buying the wrong size. So oversizing, definitely it's wrong also. If it is too much oversized, but that is money. And undersizing definitely is wrong also because it will affect the result of the CT scans, the MRIs. So the quality of the picture. So it might happen that you don't have a tumor by MRI, and when the doctor reads it, it's blurred, he will say, okay, there is a tumor. This part will be operated, but of course, that is a big problem. So also regenerative load. Regenerative load is generated by the elevators. As the elevators direction goes down, it will create a regenerative power, which is absorbed by the engine itself, and it will cause overheating of the coils of the alternator because it is an added load to the generator. So that should be under consideration also. And the harmonic generators like the BFDs and the UPSs, again, there was a subject this morning about harmonics, and that was a good explanation. And really, that is a serious matter. You have to oversize or make your neutral cable equal to the phase cables. That's the trend now. And have your HVAC loads, low and high inertial loads, Also, these are motor loads should be factored in. And the lighting loads, this is not so significant nowadays because of the LED technology. So all the ballasted lamps and electronic ballast lamps are starting to be phased out. So there are a lot of computer programs to do this generator sizing, but it's very good to do it manually and cross-reference to your software. That is the best, and that is really recommended. And again, to summarize my simple healthcare facility electrical systems, of course, except the utility, that is the utility, that's not the responsibility of the facility itself. So you have your generator, standby plant, and you have your emergency normal panel boards, and you have your ETSS, and downstream is your EAS. So very simple thing, but as you go along, it's not only a low voltage standby plant. Shown in the next slide, these are low voltage switch gears. These are the breakers now with the microprocessor trip controls. And if you look at closely, you'll have your other switch gears inside. At the back of this one, you have your CTs, the bus bars, and your cables, and so forth. So this is the plant that I was involved, and it was the subject matter of my TER in the application of the PE license. So this is a 13.8 standby plant. It's a big facility, military facility. That's why we have this kind of plants. Aside from its medium voltage, we also have a low voltage plant of the same numbers of gensets. So since it is medium voltage, you have your medium voltage switch gears, SF6, sulfur hexafluoride. So these are the SF6 tanks, and you have your also vacuum circuit breakers. And a closer look to that, for SF6, these are the tanks, and the inside of this one is the contacts, and these are the controls and the charging mechanism. And if you put that inside, as you look at this, you will find this is the column of this one. You'll find your CTs and your grounding links, your mechanical interlocks, and your medium voltage cables. So also for for vacuum circuit breakers, you will have your vacuum tanks and your contacts inside, and of course your circuit breaker on its front view. And with this rack in, these are the controls and the relaying for feeders. And that ends my presentation. And really, I'm sorry, I was out of the loop for about 30 minutes. So hopefully I have contributed to your additional knowledge. And thank you so much for giving me this privilege to share with you my subject matter. Thank you. I am ready to answer questions. I'm not hearing you, sir. There's no audio.
Hello, sir. Hello.
Yeah,
Hello.
I can hear you now. Salamat.
Thank you.
Really. Thank you so much.
Okay, so any questions from the group? Okay. So, sir, do you have your copy with copy sa imong presentation, sir? Because we are going to share that to.
Just give me one email. I think I can share.
Okay, just email it to us, sir, and then we'll be the one to, in every certificate, ipadala na namo sang asang link, sir.
Okay, sure. Salamat kayo.
Okay, so
really appreciate it.
We will award you the certificate, sir. Hold on, sir, for a while. Okay. Plaque of appreciation given to Benjenito R. Semene PEE as technical resource speaker on the topic electrical system design for health care facilities in the 21st Eastern and Central Visayas Regional Conference held on 27th to 30 day of July 2022 via hybrid at the Sky Hall of SMC Side South Road Properties, Cebu City. Given this 28th day of July 2022, signed by Ronmar Gonzalez, PEE, VP Technical, Erwin Salvador, Engineering, Master Engineering and PEE, Technical Consultant, Madalino Baclay, President, IIE Cebu Chapter, and Brian Pasilan, PEE, Regional Governor. Please accept our certificates, sir.
Thank you, sir. Thank you. Thank you.
Okay, so see you tomorrow, sir.
Okay, Pohon. I'm glad to meet all of you. Thank you.
Okay, thank you, sir. Bye.
Visayas, Mindanao, ay kamakaret nagkakawaw. Yeah.
Nalawag pa'y itiranyag kiti aldaw. Sumikat ka ito'y lubong